Hello everyone, my name is Shambhavi and today we are going to solve a question on central limit theorem. So basically in the last video I have told that what is central limit theorem. So let me quickly open that thing. So this was the thing which we were just discussing, and this was the statement for central limit theorem for sample mean says that if you keep drawing larger and larger samples and calculating their mean, the sample mean forms their own normal distribution. So this was the statement which we have seen for the central limit theorem of sample mean. Okay, as I told that it has two types, central limit theorem for sample mean and even for sums also, right? So this was the thing, and now let me just go to that question. Fine. So today we are just going to see a question. In that we are just going to solve the things, and here this is my question. Okay, so what is my question saying to me? The question says that an unknown distribution has a mean of 90 and a standard deviation of 50. Samples of size n is equal to 25 and drawn randomly from the population. Okay, find the probability that the sample mean is between 85 and 92. Fine. So this is a very simple question that we are seeing this question from the very starting. Like we are just seeing these types of questions from the very starting of this statistics video series. Fine. Okay, let's do that thing. So let's understand the question one more time in a little detailed way. Fine. So now what I am given with here with the questions. So first of all, before that, let me just try and see one thing that can I do that thing. Hold on for a second, guys. Let me go backside, and this is my home, and let me just try out some things here. Okay, no, I don't think that I can basically do anything this side. Fine. Let's move on with the things here. Okay, so it is saying that an unknown distribution has a mean of 90. So it is given that the value for the mean is 90, right? And the standard deviation of 15. So even I am given that the value for the standard deviation is 15. Fine, so this is also done. Now what else I have? Samples of size n is equal to 25. I have the value for n, and that is 25. This is also done. And drawn randomly from the population. Fine. Problem 1 says that find the probability that the sample mean is between 85 and 92. So firstly what I need to find is that I need to find that the sample mean is between 85 and 92. So here I will just firstly solve the problem 1, and then we will quickly move towards the problem number 2. Fine. So here what first I would do, I would just take a variable x. Okay, so I would just write let x is equal to one value from the original unknown population. Let x is equal to one value from the original unknown population. Fine. So, okay, this is done. Now what else I have? I would just write that here it is asking me to find the probability, right? So the probability question asks you to find the probability for the sample mean, right? So what is my question asking from me? So my probability question is asking me to find the probability. I would just write here, okay? Find the probability. Now here I'm just using a little bit of short form, right? Fine. So find the probability for the sample mean. Fine. So this is like what my question is asking from me. Next, what I have, I would just take another variable also, that is x bar. Fine. Let x bar is equal to the mean of the sample, the mean of sample of size is equal to 25. Okay, size is 25, right? And I have some other values, right? Since mu x, we have the value for mu x is equal to 90. Then what I have the value for sigma x is equal to 15, and even I have the value for n is equal to 25, right? So these are the values which I am having. So now what I would do, so I would just write these values in a proper manner, because these are the main values for my question, right? So I will just write here size. Okay, so sample of size. Okay, so I would just write here as sample size is equal to 25, and I would just put one comma here. I would just write here the value for mu x, which I am given, is 90. I would go down. Even I have the value for here I would just write the value for sigma x, whatever I have, that is 15, and the value for n which I have, that is 25. Okay, so I have these four parameters, these four values with me in this question. Now, from this question, what formula can I use? So basically in the previous video, that is for the central limit theorem, I just told you one thing here, right? This thing. X bar is approximately equal to n in bracket mu x comma sigma x upon root n. So do I have all of these values here? Yes, I have all these values here. So from like putting all of these values in this formula, what I can just compute from this side, I will just write x bar is approximately equal to capital N. What was the thing which we were like having there? So let me just open that thing once more here. That was mu x comma sigma x upon root n. Fine. So that was mu x comma sigma x upon under root of n. So I just put the values? Yeah, I can do that because I am having all of the values here. So I would just put a equal to sign here. So I would just like okay, I would just take this thing down. Okay, so right. So I would just write here as x bar approximately equal to n. The value for mu x, what's the value? For the mu x, we are having the value as 90 for sigma 15 and 25. 90, comma 16 divided by under root of 25. Right? So this is the like values which I am having. So it's at 16. Okay, no, it's not 16. It's basically 15. I'm sorry for my mistake. Let me just go down. Let me just quickly rub that thing. So here at my okay, where's my cursor? Fine. So I would just like run that thing, and one thing more, I would just okay. So it's 50. So x bar is approximately equal to n. In bracket I have 90 comma 15 upon under root of 25. Now what I need to find is here that I need to find the probability of it, like my x bar. The value for my x bar is basically greater than 85 and the value of like if this x bar is less than 92. I need to find this probability, right? So what's the problem in finding this probability, right? Because I have already discussed this thing in my question series which I was taking for you all. In that I have just done this problem, I guess in each and every video for approximate 4 to 5 videos I have just done this thing repeatedly. So now I am not going to do this thing today. Fine. So what you need to do is that if you just have any doubt in finding the probability for this thing, you just go and have a watch over that videos. Fine. So I will just directly write the answer here and you can just tally your answers after finding. So that is 0.6997. So that is the final answer for finding the probability that it is like basically the value for x bar is less than is greater than 85 and the value for x bar is less than 92. Fine. So this is the final answer which I just got here. I will just highlight that thing also. So I hope by the time you all have just like pause the video for a while and just find out the probability. You're not just copying whatever I'm just writing here. Fine. So you all must have done that thing. Let me go down here above, right. So this was my first question which I have just solved right now. Let me quickly explain this thing once more. So what was my problem one asking? It was asking me to find the probability that the sample mean is between 85 and 92. So I did the same thing. Firstly, what I did, I just take a variable that is x. So I just wrote let x is equal to one value from the original unknown population. Fine. What I need to do is that here I just find the probability for the sample mean. Yeah, I have done. I find like what was my question asking? My question was asking me to find the probability for the sample mean. Yeah, I done that thing. What next I have done? I have just taken x bar. Now x bar is one of my like variable that is the mean of sample size, and that was given me as 25. I was having the value of mu x that is 90. I was having the value of sigma x that is 15. And even I was having the value for n that is 25. Now what all these parameters mean and basically what is the like what do we like mean by the symbols mu, sigma, and what are these things denoting? So for that I have covered this thing in the previous video itself where I have just told all the theoretical things about the central limit theorem. So if you just want to have an idea over this, you can just go and watch that video. So I was just having all of these values that was sample size of 25, mu x was 90, sigma x was 15 and n was 25. So this was a formula which I have basically seen in my previous central limit theorem video. So we have just like I have just applied this formula because I was having all of the values which is in this formula, right? I was having the value for mu x, I was having the value for sigma x, even I was having the value for under root of n. So I just applied all of the values. The mu x was having the value as 90, sigma 1 x was having the value as 15, and even under root n was having the value as 25. So I just applied that thing, found the probability, and this is the final answer from probability. That is 0.6997. Fine, so this is my problem 1 solved here. Now moving towards the problem 2 quickly. So my problem number 2 says to me that find the value that is 2 standard deviations above this is above the expected sample mean. Okay, so I need to find a value that is 2 standard deviations above the expected sample mean. Fine, so this is an interesting question, and here you just get to know and get to learn a new formula also. Fine, I'll just write here as problem 2. Let me go down even. Let's quickly solve that question. And yeah, one more thing in the previous this problem number 1, if I just want to plot a graph for this, how will I do that? That is like very simple. So let me quickly draw that graph also for you here. I would just like take I would just not need this thing. I would just needing a straight line. Fine, because that is a normal distribution, right? So you all know that basically how we just draw a normal distribution. So let me just take the pen here. I would just take as red. And yeah, so basically this is how we just draw a normal distribution, right? So I would just like take it as 85, I would take it as 90. So it is 85, it is 95, in middle somewhat I have 90, so this is x bar. And what is this? This is the probability that x bar is greater than 85 and less than 95. So what I just wanted to find, I just wanted to find this middle value, right? That is like just present here, this one. So just let me highlight that thing also, so you can just get an idea that what I just needed to find. So I just wanted to find this value, that is the probability that x bar is greater than 85 and less than 95. So we have just found the value, and it was something what 0.699 somewhat like, right? 0.6997. Fine. Now let me quickly solve the problem number 2 here itself. I will just take the pen. Okay. Now my problem number 2 was asking me to find a value that is 2 standard deviations above, right? So what I would just do here, I would just take a variable value, right? And now here you can just have a one more formula, and that formula is mu x plus. Now this is the this hash of standard deviation. So this basically means the number of standard deviation which we just want to write here. So I would just write here as 2 because we want 2 above, right? And I would just put the formula, and this is in multiplication with this only, so I'm just writing it down. So it is, okay, just let me erase this thing. So sigma x upon under root of n. Fine, so this is the formula which I would be just applying here, finding that value. So I would just put the values here itself. So I would just write here value is equal to mu x value I'm having as 90. This hash of sigma standard deviations I'm having 2. Sigma x I was having as 15, and under root and n I was having the value as 25. Now you can just calculate this thing on your own, and you are going to get the answer as 96. So from here, what can I just say? Fine, from here what I can just write is that, so the value that is 2 standard deviations. So the value that is 2 standard deviations above expected value is 96. So from here what can I conclude? So the value that is 2 standard deviations above expected value is 96. So this was my question that was asking to me, right? That find the value that is 2 standard deviations above the expected sample mean, right? So here we had just completed one question on the central limit theorem, that basically how we are just going to apply the formulas in the central limit theorem question. So this was how you can just find out the values, you can just find out the questions. Fine. Now basically in the next video we are just going to take the second one, that is central limit theorem for sums. Okay, so this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi, and today we are going to see that basically what do we mean by central limit theorem for sum. So in the last video we have seen the central limit theorem for sample mean, and we have seen one example how to solve that question. So for now today we are just going to see central limit theorem for sum. That basically what do we mean from central limit theorem for sums, what are the formulas, what is the basic statement for this and what are the basic all the things which constitute it. Fine. So we are just going to see to all of these things for right now. So the topic for today is central limit theorem for sums. Okay. So let's get started with the things. And firstly, what I would do, I would just write some things here. Fine. So let me just take a particular color for this thing, and even just I will take red. Fine. Okay. So let's write the things here. What I would just write here, suppose x is a random variable. Okay, suppose x is a random variable with a distribution that may be known or unknown. Fine. So what here I just wrote as, suppose x is a random variable with a distribution that may be known or unknown. So this is a basically sentence which I have just written here, right? Let's say we are just taking a variable, random variable, that is x, and the condition is that may be known or unknown. No issues with that, right? So here this thing we have taken. So I would just write the same thing. What is the what does this mu x denote and what does the sigma x denote? So basically this mu x denotes the mean of x bar x. Okay, the mean of x. Fine. This capital X which I have just written here, that is a random variable. So suppose x is a random variable with a distribution that may be known or, okay, so instead of or, as I need to write or, known or unknown. So mu x is the mean for x. Now same thing I would just do for sigma x. What is the sigma x? Sigma x is the standard deviation. So it is standard deviation, or okay, I just need to give a little bit of space, standard deviation of x. Fine. So the mean of x, mu x is the mean of x, and sigma x is the standard deviation of, and yeah, it's looking like of x. Now it's fine. Okay, so this is done. Now what if I just draw a random variable? If you draw random sample size of n, if you draw random sample size of n, then what happens? Then as n increases, right? As n increases, the random variable sigma x, this is sigma and this is x, the random variable sigma x, which consists, as we are talking about the sum, right? So we are just taking it as sigma x, which consists of CONSI, which consists of sum, tends to be normally, okay, I would just write this thing down, which tends to be normally distributed. Now just have a look at what I have written right now. Let's see quickly that thing. If you draw random sample size of n, then as n increases, the random variable sigma x, which consists of sum, tends to be normal distributed. Now as we were having one formula for that x approximately equal to n, for that central limit theorem for sample mean, right? We were having that formula that side. So now here we have the same thing, but the formula differs a little bit. So x, sigma x. Firstly, so I would just write sigma x because it is central limit theorem for sum. Fine. Sigma x approximately equal to capital N. Fine. The capital N we have taken. Now what's the thing here? I would just write n multiplied by mu x, n into mu x, comma, under root of n into sigma x. What I have just written in the formula, sigma x, the central limit theorem for the sum is sigma x approximately equal to n. Now that is capital N. In bracket I have n into mx comma m, like mu x, for that's not m, I'm sorry for that. That's mu x comma under root of n into mu x. Fine. So this is the thing which we are just having here. Now what my central limit theorem for sum statements? Let's quickly write that thing. The central limit theorem, okay, the central limit theorem For sum, the central limit theorem for sums says that if you keep drawing larger and larger samples, and taking their sum, comma, the sums, let me go down, and taking their sums, the sums from their own normal distribution, will approach which approaches a normal distribution as sample size increases. So this is the statement for my central limit theorem for sum. Basically, it says that if you draw random sample size of n, then as n increases, the random variable sigma x. Okay, so this one is not. Okay, this one is that. The central limit theorem for sum says that if you keep drawing larger and larger samples and taking their sum, the sum from their own normal distribution, which approaches a normal distribution as sample size increases. So this is my statement for the central limit theorem of sum. So for some of you, this must be very boring that I'm just writing everything in front of you, because I just want you all to keep the notes of this thing very particular. So I am writing, and with me also you are writing. For some of you, this must be very much boring. You will say, okay, she's only writing and writing and writing. So like if it is boring for you, like I can't do anything in that. Fine. If you are having like interest in statistics, then you will like not at all feel any boring in writing of my notes, right? So here we have just written the statement for the central limit theorem. Now we have the random variable sigma x, right? So even for that sigma x, we have some separate formulas. The random variable for sigma, that was capital, right? And let me just make a sigma a little bit more fine. Okay, so the random variable for sigma x has the following z-scores, z-scores associated with it, okay, I would just like write all of the things here. So basically here I just write it that for. Just let me do enter and enter. Fine. So first I will just take, so sigma x. What is the sigma x? Sigma is one sum. Okay, x is one sum. What next I have? Next I have z-score, value for z-score. So that is equal to sigma x. Find sigma x minus n into mu of x upon under root of n into sigma x. So this is my formula for finding that z-score. Now what thirdly I have? I have n into mu x. Now what is this n into mu x? This is the mean of sigma x, right? The mean of sigma x. And what else I have? I have one more fourth thing. What is this? Under root n into mu x. What is this? This is basically the standard deviation of sigma x, right? The standard deviation of sigma and capital X, sigma x, fine. So these are all of the parameters which I have basically in my central limit theorem for sum. The central limit theorem for sum says that if you keep drawing larger and larger samples and taking their sum, the sum from their own normal distribution which approaches a normal distribution as sample size increases. So the random variables for sigma x has the following z-scores associated with it. Now what are these z-scores, right? Some of you must having the question from me that what are these z-scores. So basically I have already told these z-scores in my previous Octo video, so you can just go to my statistics playlist and there you can just search that like z-scores. You will get the whole idea and even some questions also for this z-score. You can just refer that thing, right? So sigma s is one sum. Z is equal to sigma x minus n into mu x upon under root n into sigma x. So n into mu x is the mean of sigma x and under root n into mu x is the standard deviation of sigma x, right? So this was about the central limit theorem for sums. So these are the formulas which you should keep in mind, and this was the statement for the central limit theorem for sums. Now next, in the next video, what we are just going to see, we are just going to see one question on the central limit theorem for sums. So this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi and today we are going to discuss one question on this basically central limit theorem for sums. Just let me quickly show you that thing once, that what we have discussed previously. So these are the things which we have discussed, right? That we have just seen about these formulas, right? That mu x was the mean for x, sigma x was the standard deviation, and we have seen all these formulas, right? I hope you all remember that thing, right? So we had even discussed that what is the use and basically what are the different types of formulas and all that things about this thing, right? Now today we are going to see one question on this, basically a proper question, okay? Just let me write your ask. Okay, so my question says that an unknown distribution has a mean of 90 and a standard deviation of 15. A sample of size 80 is drawn randomly from the population. Problems. Find the probability that the sum of the 80 values is more than 7500, and second is find the sum that is 1.5 standard deviations above the mean of the sums. So firstly what I'm just going to do here is that I'm just going to write whatever the things I'm just given here, okay? So I would just write here as solution. I would just write here let x is equal to one value from the original unknown population okay. Then what next? I am just going to write some more information about the like basically the question which we have just got right now. So I would just write the probability. Okay, the probability question ask you to find okay, to find a probability. I'm just writing P here, okay? So just take it as a probability full form, okay? As for the sum. Sum or basically it was like total, right? Sum or total of. I'm just writing that total of in the bracket, and here I'm just writing here as 80 values. Fine. So this is the whole information which we have up from this particular question, whatever we have like written here. Now, what next things I have just here. So now I'm just gonna give some particular symbols. Okay, so now just let me make the sigma little proper. Okay, so if this is basically equal to the sum of total of 80 values, right? So sigma x is basically denoting that thing. Now what I have some more things here. Now what I'm just given here three data: mean and then standard deviation, and sample size also I'm just given as 80. So I'm just going to write all of these things right now, okay? So I would just let me go downside here and just let me have some space for writing here. Here I would just firstly write as mu of x, fine. So that would be 90 for me, as we have just seen earlier that it is given as 90. Now what next I have? Next I have sigma x. So sigma x would be 15 for me. So that is 15. Now what next? Well, like what third I have here? Third I would just write here n is equal to 80 because the value for the sample size is 80, right? I have just shown you that thing right here. So here we have seen this thing. Okay, just let me highlight that one. So this is my highlighter, and I will just do that thing as a highlight so that you can just get the proper idea that what I'm just trying to tell you here right now. Okay, now I will just take my different color and then we'll just start solving the problems on the particular note. Fine. So I have just taken here as highlighters. Let me take it to the pen. pin and then this and then this. Fine. Now here what I'm just getting, just let me go down for a while. Right. Now here what can I just say? I can just say that sigma of x is approximate to n. And what is the value for n? So it is 80.90. That is multiplication, right? That is not the point. That is multiplication, okay? Comma, under root of 80 multiplication 50. Now what I have just written here, just let me go to the previous section and just let me show you that thing here. Yeah. So this thing. So I have just taken the sigma x is approximate to n and then n into mean comma is under root of n into standard deviation. So while taking only this thing, I have just written the whole values here. I just put the values, nothing else. Okay. So you can just like take it as this form. Okay. What next I have? I would just write here that mean of sums, okay, mean of sums is equal to n into mu times of x. So this is the basically mean of sums, okay, I need to find the mean. So I would just write mu into x and I would take the total sample size whatever I am having, right? So n into mu of x. Now what next I have? I have 80 into 90. Right, so this is the whole idea. I will just multiply, so that I will be just getting here as 70 to 100, right? So this is the whole idea about writing these things. Now what next I have here, I will just write as standard deviation, okay? Standard deviation for sums, okay? I will just write here as for sums. Now in that case, what we're just going to do, right? I'm just going to write under root of n into sigma of x. This is the basic denotation for that, right? So I would just write here the values itself. So it is 80.15, right? I'll just not solve it further. If you just want, you can do that. But in my case, I'm not just going to do that thing, fine? What next I have? I have sum of 80 values. I am just given that also thing in my question. I'm just like got that thing as the hint in my question, that is 75. Just let me quickly show you that thing. So here you can just see that the sum for 80 values is more than 7500, right? So I just took it as 7500 for right now. Done. Now moving towards the very first part of this question. What we have to do here. Firstly, I will just write what I need to find here is that. Firstly, I need to find the probability of sigma of x is greater than 7500. Firstly, I need to find this probability, right? Because we need to find out this thing. So what can I just make here? Firstly, I can just make one graph, right? I can just make one graph showing this thing here. Okay, I would just do one thing. I would just take a different color and even I would just take some lines also. So I would just take red and I would take the x and y. So I would just do that thing. Sorry, I don't need x and y, right? I only need a single line. So I would just take the single line and yeah, like this. And now here I would just make that graph and I would just take it from here and I would just make it of a form of like this. Okay, so this is the basically graph which I have made. Now here I would just plot a line, one line, okay, like this. Now what I can just do here is that here I can just right here I can just give some values as let's say it is 7200 and this is 7500. Okay, I would just color out this part. So just let me do that thing. I would just color out this part because what I'm just going to do here is that I'm just going to give it out the probability, right? Now I would just again take my, let's say I would just take that purple color itself only, right? I would just do that thing. And yeah. Now what does this portion basically belong? So it belongs to the probability that sigma of x is greater than 7500, right? So this is the whole idea about making this plot, and yeah, you all know that basically how these things are made, right? I'm not just going to take this in very detail right now, fine? Now what next I have here, I would just write one formula. I would just write normal CDF, okay? Now what is there? So basically whenever we just want to write this thing, what we do, we just put the brackets. Now here we just take some values and something like that. I would just write here as lower value. I would just put here as one column as upper value. I would take one more as here mean. Okay, sorry, just let me write it. Okay, I just need to take the color once more. I just don't know what happened. Right, so I would just write here as sums. Okay, and now what I would just write here, I would just write, I'm just going to write the short forms, okay? I'm not just going to write full spellings. So standard deviation of sums. So that is also completed here. Now what can I just do? I can just put all of the values this side and calculate the things. So now in this case, I'm not like basically I'm not going to put all that things in calculator. You can just do that things on your own, fine. So I'm just writing the final answer. So P is basically equal to X and X is greater than 7500. So probability of this is 0.012 cents. So when you're just gonna put the values and calculate. So in the case you're just gonna get this this output only, because I have already told all of these things previously. So I'm not just gonna repeat that right now here also, fine. This is done. Moving towards the second part. Now basically what my second part asked to me. So it basically asks us find the sum that is 1.5 standard deviations above the mean of the sum. I need to find then some value of the sum that is 1.5 standard deviations above the mean for the sum. So what I'm just going to write here is, firstly I would just write that what I need to find. So I would need to find sigma of x where z is equal to 1.5. I am just going to get that value, right? So I would just write here once more that sigma of x is equal to n into mu of x plus z into under root of n into mu of x. Fine. So these, sorry, not mu here. I would just write it as sigma. So sigma of x. Fine. Just let me go down a little bit. Let me shift down. And yeah, here I would just put the values, right? That is 80 and then 90. And I would just write it as 1.5. Even under root of 80 and even here as 15, right? And when you're just going to calculate all of this, in the final output which you're just going to get 7401.2, right? So this is the answer which you are just going to get here when you're just going to calculate these values, right? So I hope you just got the idea that basically how you're just going to solve these types of questions if you basically get that, right? So here we have just solved both of the parts, and in the one we have just made the graph, and second we have just done that in the calculation. I hope you just got the idea for how to doing these things. Okay. So now we have just completed this particular topic. From the next videos we will just move on to some other topics. So this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now today we are just trying to see a topic, and that is law of large numbers. Now this is one more topic which just come under that section of basically central limit theorem, right? Previously what we were doing, we were just doing that central limit theorem, and under that section this one law is there, that is law for large number that comes. Now today we are just going to see that basically what is this law. And after that what I'm just going to tell you is that I'm just going to take one example, take one question that basically consists of 4 parts. So we are just going to solve 2 parts in this particular video and the rest 2 parts in the next video, right? So this is the procedure which we are just going to follow for doing this thing, right? So I would just not waste a lot of time here while talking, and let's get started and do the things right here, fine. So my first thing which I would just discuss here is the law of large number. Okay, I will just write the heading also. So yeah, law of its large numbers. So it's large and then here it's numbers, fine. So we are just going to see that basically what does this law of large number actually means, right? So I would just write the statement which is there for this law of large numbers, and from that only we will just get an idea that basically what this law of large number, and like what we can just conclude from this, what we can understand from this, right? We are just going to learn that thing, right? So let me just write here the law of large number. I'm just writing the short form for numbers, okay? The law of large numbers says, and just let me go down so that I can just like write a little bit of neater handwriting, okay? The law of large numbers says that if you take samples of larger and larger size, okay? The law of large numbers says that if you take samples of larger and larger size from any population, okay, from, and just let me go more down, from any population. So I'm even writing the short form of population also, okay? So it's population basically. Then the mean, what does the mean? We just give it a like denotation of is a bar, right? Is then a line above, we just call it as bar. So then the mean x bar of the sample tends to be closer to mu. Right? So this is the statement for the law of large numbers, that the law of large numbers says that if you take samples of larger and larger size from any population, then the mean x bar of the sample tends to be closer to mu. Right? So this is a sentence which is there for the law of large numbers. Now, what I just said, that we firstly will be seeing that what is the law for that large numbers, and then we will be moving towards the question for today, right? But before that, I would just ask you one thing, and even just tell you one thing, that I hope that just you are all like writing the things with me, right? Because I'm just not writing this for myself, I'm just writing these things right here so that you can just take a proper notes of each and everything whatever I'm telling. If I'm only and only speaking, then you will not get that proper idea that what I'm just telling, like trying to tell you, trying to like make you understand, right? But if I just write something, then you will just get a fair idea that what I am trying to say, and you can just make your proper notes itself, okay, right? So that is why I'm just writing it. So I hope you all must be writing with me, and if you have not started writing yet, so just go and open notebooks and start writing. What you all are waiting for, right? So let me just repeat the statement once more. The law of large numbers says that if you take samples of larger and larger size from any population, then the mean x bar of the sample tends to be closer to mu, right? So this is the you can say the statement for the law of large numbers. Now here is the question for the day, and the question says that a study involving stress is done on a college campus among their students. The stress score follow the uniform distribution, with the lowest test score equal to 1 and the highest equal to 5. Okay, using the sample of 75 students, find first the probability that the mean stress score for the 75 student is less than 2. Okay, and B, the 90th percentile for the mean stress score for the 75 students, right? So here what I need to do is that I need to find these two things, firstly A and then B, right? Let me just take a particular highlighter, so I can just like highlight the important things whatever I just here. Okay, so I just thought that important is the stress score follow the uniform distribution with the lowest test score. So my lowest test score is equal to 1, right? And this one, and my highest is equal to 5, right? This thing, fine. So this is the, and what is the sample size is total 75. So these are the three important points from my question what I am just having right now. Okay, now what I need to do is that I need to solve this question. Just let me take a pen and I would just start solving the question. Fine. Now here firstly what are the common things which I can just write while seeing this sentence, the first question. Okay, leave these sub parts. Okay, leave them, right? If I just leave these sub parts, then from this question which I'm just getting here, what are the things which I can just include here, right? Let's quickly just see that thing firstly. So I would just write here as solution and just, yeah, fine. So my solution is firstly I would just take a variable x. Okay, so I would just take a variable x and I would just say let x is equal to 1 stress score. Okay, 1 stress score. And if you're just following my videos from the very starting of the statistics playlist, then you will not be needing me for this question, right? You will be able to solve this question on your own only, right? You will not like require me to solve the question and make you understand. You will do that thing on your own. So I would just suggest that do see all the things from the starting only, right? Don't just skip and see the things here. Fine. Okay, I was given that x is equal, I just let that x is equal to 1 stress score. I am giving the value of n, right? I am having the value for the sample size, that is 75, right? Now what next I have? Okay, so here I can just write since the individual stress score, and yeah, I need to just go down, I guess. Yeah, stress, I'm just writing it from here. Stress score follow a uniform distribution. Okay, follow a uniform distribution. This is the thing which is written in question. I'm just not writing anything new here. Okay, so I just wrote it that since the individual stress score follow a uniform distribution And yeah, here I would just include that x approximate equal to u, and here in the bracket I would just write 1 comma 5. So what were 1 and 5? I just highlighted those things here. Just let me take my cursor here. I just highlighted those things, that the lowest test score is equal to 1 and the highest is equal to 5. So that thing only I just wrote here, x approximate 1 comma 5, right? And what else? I wrote n is equal to 75. So we were given that using a sample of 75 students. What else I was having? Yeah, I just wrote the sentence that since the individual stress score follow a uniform distribution, right? So we are just given this thing also in the question. So you can just check out the second line of this question, that stress score follow the uniform distribution, right? So all of the things are just given in the question itself, right? So I'm just trying to explain you the solution, that how you should proceed, okay? And here I would just write, so now a would be having the value as 1 and b would be having the value as 5. So I would just write where a is equal to 1 comma b is equal to 5, right? So a and b values are given in this bracket, fine. So from here, what are the things that I can just calculate, right? So firstly, I can just calculate the mu x, right? So for calculating the mu x, the formula was a plus b divided by 2, right? So I am having the value for a. Even I am having, just let me erase it for a while and just let me write in a clearer handwriting so that you can just see that, right? Okay. So the formula for calculating that was a plus b by 2, right? So I am having the value for a and I am having the value for b itself. So I would just quickly put those values. So it's 1 plus 5 divided by 2. So then 6 divided by 2, and that is 3, right? So from here I can just get the value for the mu x. Fine. What else I can just get now? I can even calculate the sigma x. Okay, standard deviation for my value from x. Now what is the formula for that? We had already seen. So it was under root b minus a whole square divided by 12. Yes, this was the formula, right? Now I'm just going to put the values and basically I'm just going to find the final answer. So it's 5 minus 1. Okay, so value for b is 5 and the value for a is 1, right? And I would just write here under 12. So when you're just going to compute and find the final answer, it would be 1.15. Yeah, you can just do that thing on your own. Fine. Okay. So this was the common thing which I have just done here for this particular question, right? I have not taken any particular part, right? Till now I have not chosen a part that I'm going to follow the part A or part B or anything like that. So I just computed the things what I can just find from the information that I am given in the question, okay? So in that I was just given the lowest score, the highest score. So here you can just take a note, take a point that why I'm just doing this. So from here, if you just get some question like this, in which you are just told that the lowest score is this, highest score is this, if they do not tell you the things directly, if they are telling you the things indirectly, so how you are going to proceed that question, okay? How you are just going to solve that question. So that thing I have just explained you right now, okay? Fine. Let me go down here. So that mu x and sigma x is now computed. Now I can just take the things. So I would just write here for my problem 1 and my problem 2, let x bar, I would just write here as capital X, okay? Let x bar is equal to the mean stress score for the 75 students. So I had just taken a particular variable and I had just written that let x bar is equal to the mean stress score for the 75 students, fine. And what else I can just write? So x bar is equal to n, and here I can just write 3 comma 1.15 upon under root of 75. So these are the values which I got. 3 value is for my mu x, which I just computed that side, right? This 1.15 is from my sigma x, which I computed, and this is my under root of n. So on n is my total sample. So in that case, I was having the n as 75, right? So from this, we can just conclude all of these things. And yeah, I just mentioned the thing that how did I just put the values, fine. Now let's quickly move towards the very first question of this part, right? So my first question says to me to find the probability that the mean stress score for the 75 students is less than 2. Okay, I need to find that the mean stress score for 75 students is less than 2. Okay, I need to solve this question. Okay, so I would just write here as problem 1 and let's begin. So I would just write it that what I need to find the probability. Okay, I would just write P outside. Probability of x bar less than 2. Fine, I need to do that. So before just doing that, I would just make the graph for it. Okay, so I would just make the graph here itself. I had to go like very down and I would just take one of any color. Let me just take any highlighter, so that would be more easier, right? So my graph would something go like this. Okay, we know that the graph for this distribution, like we make the graph for the distribution like this only, right? So I had just done that thing only. I just made this graph and let me just take a color so that now I can just highlight the things. So my x line, and from here it is that curve. I know that it is looking very bad, but we need to manage in this only right now. I would take the color and okay, fine. So what is this? This is my, here I would just write as 2, this is 3 and let's say this is 4. Okay, let me just go down because I just think that because of the image that is not properly visible, right? Now what does this graph basically shows us, right? So this graph basically shows us the probability, right? The probability which we need to find. It shows us that thing. So I would just put the arrow sign here and here I would just write probability of x bar is less than 2. Right, so here I just made that graph to show this thing, right? We can just like take the things visually also while doing these types of questions, right? So let's say I just wrote here probability of x bar is less than 2 is equal to 0. So this is the probability that would come. Now how to compute that probability, I'm not just gonna tell this thing right now because we have already done several questions on that. Okay, now I would just not waste time by repeating the same things. So if you just want to go and see that basically how to find the probability, so you can pick any of the questions. Okay, you can pick any of the questions from my videos and you can just watch. So basically almost in 90 to 95% of the videos for the questions we had already solved how to find the probability. Fine. Next, what I can just find the normal CDF, right? I can just find the normal CDF from the data which I am just given here, right? So I would just write normal CDF and then I would just put the bracket. Okay, just one second. Fine, I would put the bracket here. Fine. Now here I can just write the values which I am just having here, that is 3 comma 1 point that was 1.15, right? That the value which we have computed for the standard deviation, right? That was 1.15. this was in, and yeah, what was it? So these were the mean and other the values, right? So this is the thing that we can just compute it from here. So what can I just conclude here? I can conclude, so the probability, okay, I will just write the full spelling only. So the probability that the mean stress score, is less than 2. Oh, I'm just so sorry for that. Just one second, yeah. And just let me go down. Is less than 2. So the probability that the mean stress score is less than 2 is about 0. Fine. So here I just finished up my first question, that was find the probability that the mean stress score for the 75 students is less than 2, right? That question I have just solved. Now moving towards the second question, we will be seeing the second, third and fourth, these three parts of this question in the next video, right? So now here I hope that my main motive was to explain you. My main motive was not that I will tell you how to find the probability. No, because we already know all that things. My main motive was to tell you that using these three lines, how you can just compute, how you can just like take and find out that what are the things which you can just take it from here, right? Let's say that x, value for n, mu x, sigma x, right? So these are the things which you can just take it from here, right? So I hope you just got the idea to how to just solve these types of questions, and even we are just left with 3 more parts in this question, so I would be covering that in the next video, right? So this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi. So in the last video what we have seen the part number 1 for this question, right? The question was basically this was the question which we were taking and we had seen the first part for this question. Now in the today we are basically gonna see about the second, third and fourth parts. Okay, we are just gonna see that basically how to solve this B, C and D, these three parts of this particular question. So just let me quickly revise the question, that what was the question asking from us. So it was saying a study involving stress is done on a college campus among the students. The stress score follow the uniform distribution with the lowest test score equal to 1 and the highest equal to 5. Using the sample of 75 students, find the probability that the mean stress score for the 75 student is less than 2. So we have completed the part number 1, right? Now the part number 2 says the 90th percentile for the mean stress score for the 75 students. So we need to compute the 90th percentile for the mean stress score of the 75 students. Fine. So what were the things that we just computed from the question? So we had taken the small x and that is equal to, let's say x is equal to 1 stress score. We were knowing the value for n, that is 75. Okay, so we were given that value. Fine. So it was that since the individual stress score follow a uniform distribution x equal to approximately u 1, 5 where a is equal to 1, b is equal to 5. Okay. Fine, so we just computed the values for mu x and sigma x. Okay, then we just solved the very first question. Now let's move towards the part number 2, problem number 2 of this particular question, right? Now, what I need to find is that I need to find the 90th percentile. So here I would just write let k is equal to 90th percentile. 90th percentile. Fine. I need to find that. Before that, I would just make the graph for it. So what I need to find is that, let me just go a little down so that, yeah, see what line did I have made. Okay, I need to go down, I guess, yeah. And I need to just use the eraser. It will not just work from the controls. It's fine. Right. So what we were just doing, we were just making the graph for it, right? That how we are just gonna make that thing. So if you are just like, as I just mentioned previously also, and now also I will just mention the same thing, that if you're just following my previous graph, then in these questions you need not, like, you will not need my help. Okay, you will just do all the things on your own and very correctly also, right? So this is the probability for x bar is less than k and which is equal to 0.90. So we were having 90th percentile, right? So that in that case it is 0.90. And here I would just write as 3. Let's say this is, okay, I would just take a little, yeah, let's say this is k, okay, and let's say this is x bar. Fine. All the things I just made. I need to just go down. How did I just come here? Fine. Okay, that is finished. So here what I just need to do is that I need to find k. I need to find the value for k where probability of x bar is less than k, which is equal to 0.90. Now basically how to find this k, we had already seen that how to find this probability previously, right? So I would just not repeat that steps here again. I would just write the final answer. The final answer for k you would be getting as 3.2. Now go to any of my previous questions. Basically you can just follow the questions for the percentiles, and in that I had already told you how to find the percentile if it is given that thing, right? So the value for k would come as 3.2, right? So from here I can just conclude the 90th percentile. I can just write the 90th percentile for the, and just let me now go down, the 90th percentile for the mean of 75 scores is about 3.2, right? So this is the value which you will be getting when you have just found the value for k, that is 3.2. Fine. And from here what we can just find, we can just find the inverse normal. Okay, so INV NOR in bracket I would just write the value 0.90. This 3 was the value for mu x, mu x, and 1.15 value was for the sigma x which we have founded, and this was under root of n, right? So when you're just going to solve, this is equal to 3.2. Fine. So this is basically finding out the percentage. So I have not mentioned the steps here because we had already seen that the steps many a time, right? So there is no need for repeating that things again and again and making the videos long, right? So I just not repeat that steps again here, right? Now moving towards the problem number 3 and problem number 4. So problem 3 and problem 4. So for this we need to take something different. So for problem number 1 and problem number 2, we had taken x bar is equal to the mean x bar is equal to the mean stress score for the 75 students, right? Because we were just given the mean stress score in that, but now here in the question number C and D, you will not find the mean stress score word anywhere. So that the problem number 3 asks me the probability that the total of the 75 stress score is less than 200. And problem number 4 asks me the 90th percentile for the total stress score for the 75 students, right? So now it is asking me the total stress score. So in that case, we are just going to take the sigma, right? So for problem number 3 and problem number 4, here I would just denote this sigma x. Okay, now sigma x is equal to what I would just give the values here. So sigma x is equal to the sum of the 75 stress. So sigma x is equal to the sum of the 75 stress score. I would just write here as score. So just let me quickly erase this small x and let me make it to the capital one. So yeah, and this one. So here the sigma x is equal to the sum of the 75 stress scores, right? So in this I have just written in the alphabetical format. If I just need to denote it, if I just need to use it write it using the symbols, so I would just write here as sigma and then x, right? So my sigma is looking a little bit of different. I just need to make it as a normal of sigma. Yeah. So sigma and then capital X. So sigma capital X was the sum of the 75 stress score, right? So sigma x is equal to, that means approximate equal to n. And now here I'm just gonna add the value. So 75 dot. Now this dot is not the decimal point. This is of the multiplication, right? Now just don't be confused in the multiplication and in the decimal. So 75 into 3. So what was my 75? That was the value for n. 3, what was the 3? 3 was mu x. That was my mean. So here I would just put a comma. Now I would just write underscore 75. That was underscore of n. Sorry, under root. Sorry, that's under root, not underscore. So under root of 75, that is the value for n inside the under root. Again, I would put that multiplication sign. This is a dot, not that decimal. Okay, just keep that thing in mind. And here I would just write the value for sigma x. So that is 1.15. I hope by the time you all must be familiar with the notations and all that things very carefully, right? Because we have just used these things many a times in our videos. I have just repeated the same things, right? So by the time you all must be familiar that what is this mu x, what is the sigma x, what is this root n, what is this n and all that things, right? Now here comes the problem number 3 which we need to solve right now. So let's quickly move down and let me take a little bit of a space this side, and now I'm just going to write the problem number 3 here. So just let me write that problem 3. Fine. Now what is my problem 3 asking me to find? So my problem 3 is asking me to find the probability of and I just need to remove this sigma and make it clear. So sigma x is less than 200. Quickly go to the question. Just let me quickly show you the question so that you just do not face any problem. So what is my problem number 3 asking for me? The probability that the total of the 75 stress score is less than 200, right? So there, this is the reason that I just wrote here, probability of sigma x is less than 200. Fine. Now here firstly I can just write the mean of the sum of 75 stress score is. So here I can just multiply the 75 from 3, right? So 3 was the stress score, sorry, mean which we have found it previously, and the 75 was the n, right? So n into mu x, and so that is gonna result me as the final multiplication as 225. Fine. Not now what next I can just do? I can just do the same thing for the standard deviation also. So I'm just writing a short form for standard deviation. So standard deviation of the sum of 75 stress score. Now I'm just not writing these whole sentences for me because I need to practice. I'm writing these things for you so that you can just get a proper idea that how to solve a question for the statistics if you just get this question somewhere, right? So you need to just write these steps and maintain the proper steps, maintain the proper the thing how you should just solve the question, okay? So standard deviation of the sum of 75 stress score. Now here is under root of 75. Now multiplied by 50. Sorry, that was 1.15, right? So now just don't be confused in this dot and the decimal thing, right? Firstly, and like between this and this under root 75.1, this is the dot, and now here I am just putting 1.15. So this point is the decimal one, right? Don't be confused in that thing. So if like to remove the confusion, listen to my words very carefully, whatever I am just speaking right now. So that will be resulting is the multiplication, and it will be 9.96, right? That's over. Now how to find the probability? I'm just not gonna again repeat that thing. So you can just find out, and that would be approximately equal to 0. Fine. Now I can just make the graph also for this thing right here, okay? Now how to just make that graph here? So just let me draw this line here, and yeah, line is something like this. Yeah, it is okay. And you all know that how we just draw the graph. So just let me make it my graph here, and here I would just, let's say here I would just put the arrow, and what basically it is representing, the probability of sigma x less than 200. And here I can just give the values. So let's say it is 200, it is 250. Okay, so it is 2, not 250, it is 225. Just let me 225, and this is sigma x. Fine. Now what I can just like conclude it from here. So the total probability, okay, the probability. So I'm just writing a short form for probability. I'm just not going to write the whole spelling, okay? The probability that the total of 75 scores, the probability that the total of 75 scores is less than 200 is about, I'm not writing finally, right? I'm just writing about, is about 0. Now what next I can just compute from here? So from here I can just compute my normal CDF, right? So I can just write normal and the CDF. Now here inside this I can just write the values whatever are needed. So now 75, now this 200 is the starting value, right? Then so that is the probability should be less than this much. So that is that 200, and this is my 75 dot, it is dot, okay, not the point sign, this is dot. So 75 was my n and multiplied by mu x, and it is under the roots n, and it is multiplied by 1.15, right? So by the time you just be okay with the notations and where it is dot and where it should be the decimal, you should be knowing that thing, right? Now, so this is over for this question, that is problem number 3. Now, I'm just not going to solve the problem number 4 again because it is the same as the problem number B. Fine. So you need to just, in problem number B, it was the mean stress score, and D, it is the total stress score. You need to find that thing. So I'm not going to solve that thing here, okay? You need to solve that thing, that question on your own, and report the answer in the chat box, whatever you just got that thing, fine? So this is basically how you can just solve out the questions if you're just given the question for finding the mean and for finding the total. Basically you are just given a question for solving the uniform distribution, then this is the procedure which you should maintain. Now it is not that thing that you only find the mu h, you find the sigma x, and you just do not write this thing, because I was not writing these things for myself. I was writing these things to explain you each and everything very, very carefully. And I was giving you a procedure that basically this is the best procedure how you can just solve a particular question, right? So you should always solve the questions like this only, so that you will never face any problem while solving the questions. Fine. So I hope I just made everything very clear to you about these questions, that basically how you are just going to solve these questions, right? So this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi and hope you all are doing well. So today we are going to discuss one more question on central limit theorem, right? So now just let's quickly understand that what does the question says to us. So the question says, suppose that a market research analyst for a cell phone company conducts a study of their customers who exceed the time allowance included on their basic cell phone contract. The analyst finds that for those people who exceed the time included in their basic contract, the excess time used follows an experimental distribution with a mean of 22 minutes. So here I am just given this thing, that is mean of 22 minutes, right? Now there are three sub parts for this particular question. Okay, these are the three parts. Firstly, let's not go into that thing because like before going into that thing also we have several things to include here, right? We have several things to write, so let's just quickly write those things. So yeah, here I would just start writing the solution, and here in this question I basically missed one line, so I would just write that line first here. Okay, so here I would just write, consider a random sample of 80 customers. Okay, so here I just forgot to put that line. So I'm just writing that. So of 80 customers who exceed the time allowance included in the basic cell phone contract. Okay, in the basic cell phone contract. Okay, fine. So basically just saying, consider random sample of 80 customers who exceed the time allowance included in the basic cell phone contract. Okay, this was a line which I just missed with a question. Okay. Now from the question I have mean of 22 minutes, right? And even I have the random sample of 80. Now from these data which we are having right now, what we can just conclude, what are the things which we can just add on here. Okay, let's quickly see that. So here what I'm just going to do, I'm just going to take let x is equal to the excess time used by one individual. Now just listen to this word very carefully, that is one individual. Okay, let x is equal to the excess time used by one individual cell phone customer who exceeds his contract time allowance. Okay, who exceeds his contract time allowance. Okay, so this is the idea about this, what I just taken a variable that is x, and I said let x is equal to the excess time used by one individual. Now this individual is a very important word which you should keep here in mind. Okay, one individual cell phone customer who exceeds its contract time allowance. Okay, this is okay. Now what I would just write from here, I can just write several things from here. So I would be writing, let capital X, where capital X is approximately equal to exponent of 1 by 22. Now basically what is this? So we have already seen this in the previous videos, right? We have seen that basically what is this. So I'm just not going to explain this to you right now. So what was the mu? So mu is 22, and even the standard deviation is also 22. Fine. Now that is okay. Now what I can I can just more write here. So here I can just say let x bar. Now let x bar is one more variable. Okay, so I've just taken one more here. So let x bar is equal to the mean excess time used by a sample of n is equal to 80 customers, okay? N is equal to 80 customers who exceeded their contracted, and let me just go down so that it is like visible to you also clearly, who exceeded their contracted time allowance, okay? Time allowance. So from that, what we can just say, we can say x bar is approximately equal to capital N, in bracket it is 22 comma 22 by under root of 80, right? By the, now from where I can just say this thing, so by the CLT, central limit theorem for sample means, okay, for sample means. Okay, now this is the whole idea about this, the question which you are having. This is the whole idea about that question. Now what is the next motto which we need to follow here is that, and next is that I have several parts in this question, right? I just need to solve that parts. So A, B and C, these are the three parts which I am having here, okay? Now what my first part says to me, it says find the probability that the mean access time used by the 80 customers in the sample is longer than 20 minutes. This is asking us to find probability of x bar greater than 20. Now what x bar have we taken? We have taken the x bar as the mean access time used by a sample of n is equal to 80 customer who exceeded their contracted time allowance, right? So it is asking you to find the probability that x bar is greater than 20, okay? Now from which we will find, so we will be using the central limit theorem for finding this one, okay? So in that case I will be using the central limit theorem. So here I will just write problem number 1, okay? So and what I need to find is that I would just write here, I need to find probability of x bar greater than 20. Fine. Now how to just find a probability for x bar greater than 20? This thing we have already seen, right? You all are very much familiar with that thing. So I'm not just not going to solve the whole question here. I would just write the final answer, and you can just match that answer from your question, from your answers, whichever you are getting, okay? So it is 0.7919, okay? And if I just write here using normal CDF, we have already seen one question like this, right, previously, using normal CDF. So in bracket I would be including 20 comma okay, let's not go into, okay, I'm sorry, let's not go into normal CDF for now. First just let me quickly make that graph with, okay? I will just remove it for a while here, just remove this, fine. And here I would just take the red color. Find the probability of x bar greater than 20, and this is the one. This is the thing. Now from here what I can just write? I can just write the probability is 0.7919 that the mean access time used is not 2. I will just remove it, okay? I will just not use the erase right now because let's not use that. I'm just writing access time used is more than 20 minutes, okay? More than 20 minutes for a sample of 80 customers. For a sample of 80 customers who exceeded their contracted, and I will just come down, time allowance. Now if I just want to make the graph for the same thing, then how I'm going to just do that thing? So you all basically know that thing very clearly, that how we just do that thing, do the graph, like how we just make the graph. So I would just show that thing once more, and I'll just make that graph once more here. So straight line, and then what I'm just left with, I need to make this bell shaped, okay? And now here I would just give some several points. Let's say this is 20, okay? This is 22, and this is the probability that x bar is greater than 20. And I would just like color that part here so that you can just get a proper idea that okay, this is the part for which we were taking out the things. Okay, so I would just like color it for a while here, and yeah, so that is now okay. So I hope you just got the idea that basically how you can just solve the question in this. Okay, now basically this is how you just solve the questions in this probability and in this for the central limit theorem. Okay, this is the proper question for using the central limit theorem for mean samples. So here we have seen for the mean samples, right? Further we have two more subparts, so in that we can just see for the sums and all that things. But I hope you just got the idea that how these questions are solved, right? And basically how to apply how to like approach for these, how to solve these things. So I would just repeat it that consider a random sample of 80 customers who exceed the time allowance included in the basic cell phone contract. Let x is equal to the excess time used by one individual cell phone customer who exceeds its contract time allowance. Okay. So x is approximately equal to exp 1 by 22, mu is equal to 22, and sigma is also equal to, and then we have taken x bar equal to n, and then we have just find out the probability, right? So this is like how you just solve the questions for this. Okay, so I hope you got the idea how to solve the questions, right? So this is all for this video, children. Thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now today we are going to complete the rest two parts of this particular question which we have taken, and yeah, we are just going to solve these two parts today. Okay, the part number B and the part number C. Okay, so these are the two parts which we are going to solve today, right? So let's today move forward, and before that just let's see the question for a while, that what was the question previously which we have taken. So the question was, suppose that the market research analyst for a cell phone company conducts a study of their customers who exceed the time allowance included on their basic cell phone contract. The analyst finds that those people who exceed the time included in their basic contract, the excess time used follows an exceptional distribution with a mean of 22 minutes, right? So this was the data which we were having previously. So firstly, we have find that the asking to find a probability that x bar is greater than 20. We have found that thing, right? Now today we are going to see the second part. Now what my part B says that suppose that one customer who exceeds the time limit for his cell phone contract is randomly selected. Find the probability that this individual customer excess time is longer than 20 minutes. This is basically asking you to find the probability that x is greater than 20. Fine. So basically it is asking you to find a probability that x is greater than 20. Okay. So this is the second B part of this question. Let me just go down here. And now just let me do here enter, and let's start the B part. So here I would be just writing as number B. Fine. So it is asking me to find the probability that x is greater than 20. Okay. So now here you can just use the exponential distribution. Okay. Let's first read once more the question, that what it is basically saying. So it is asking me to find a probability that this individual customer excess time is longer than 20 minutes. Fine. Longer than 20 minutes. Okay. So find probability that x is greater than 20. Now how to just find the probability that you all know, right? So x is greater than 20 is equal to, now if you just want to find this from using the exponential, so I would write e to the power, and in the power I would just write 1 divided by 20. 22 is the mean, okay, which we are having for this particular question. And I would just multiply it by 20. Okay, multiply it by 20. And here I would just close it. And like this. Or even you can just say that for this even you can just write as it is like e to the power, and here I would just write minus 0.0454 multiplied by 20. Okay, so basically this 1 by 22 is having the value of this. Okay, so I just divided that, and you can just take it like this also. So when you're just going to compute the final answer, so the final answer which you would be getting is 0.4029, and basically this is the probability that x is greater than 20. Now just let me quickly read the question once more, that suppose that one customer who exceeds the time limit for his cell phone contract is randomly selected. Find the probability that this individual customer's access time is longer than 20 minutes. This is asking us to find probability of x greater than 20. Fine. So this is basically how you're going to solve this question. Explain why the probabilities in A and B are different. Now, the next question which is asking to us is that now explain us that why the probabilities for A and B both are different. Now here you need to give a reason. Fine. Let's start with the things, and we just write something, or even we just compute some things, right? So firstly, I can say the probability that x is greater than 20. What probability we have found? So we have found 0.4029. This was the probability which we have done when x is greater than 20. And the probability that x bar is greater than 20, so we have seen it in the previous video. Let me just quickly go above and see that what was the probability. So the probability was 0.7919. Okay, so here I would just write 0.7919. This was the probability that basically x bar is greater than 20. Now, it is asking me that basically why these probabilities are not equal to each other. So here I would just write the probabilities, B-I-L-I-T-I-E-S. The probabilities are not equal, here I would just write because we use different, and I would just come down here. The probabilities are not equal because we use different distributions to calculate the probability, and here I would just write the short form. Okay, now just don't be confused. So distributions to calculate the probability for individuals, INDI, individuals, and here I would just come down for individuals and for means. Okay, and for means. Okay, so this is the idea about solving this question, right? Now, let's say here I have one more question. Just one second, just let me go above for a while. And here what was it? Considered and included in, okay. Now let's say here if I just say I have one more question here. I need to find the 90th percentile for the sample mean access time. Okay. Now let's say I have one more problem. So I would just write the question with black color, let's say. So okay. Now what is my problem 2 here? So my problem 2 is, let's say, find the 95th percentile. Find the 95th percentile, okay? Find the 95th percentile for the sample mean. For the sample mean access time. For the sample mean access time of 80 customers, and I would just come down for a while here, for 80 customers where it's who customers who exceeded their basic contract time, contract time allowance, and even draw the graph also. I'm just not writing that, draw the graph also. So let's say I just got this question to solve. Now how am I just gonna do that thing? Okay, so let's quickly read that question for a while, that what it is actually saying to us. Fine. So it is asking me to find the 95th percentile for the sample mean access time of 80 customers who exceed their basic contract time allowance. Now basically we all know that how to solve the percentile questions, right? So I would just take a different color here, and let's say that color is red. Okay, I would just write my solution here. So here I would just take a variable, let k is equal to 95th percentile. Let k is equal to 95th percentile. Okay, now here I need to find k when probability of x bar is less than k. Okay, I need to find that thing. So I would be just converting that 95th percentile. So here I would be getting 0.95. Okay. So now here you can just use this inverse normal one, inverse NORM, this one, and here you can just put the value, that is 0.95, and mean is 22, and mean divided by total sample, so that is 80. And when you're just going to compute this thing, so you're going to get the answer, that is 26.0. Now you can solve that on your own. I'm not basically going to solve that. Okay, just let me write that 0 clearly. Fine, so this is the answer which you are going to get, that is INV norm, which is equal to 26.0. Now let's see if we just want to find, like, make the graph for this also. So you are just going to firstly make a straight line here, and then you will be making this bell shape. Fine, this bell shape, and here in the middle somewhere you will be writing 22, and this would be your probability. Okay, this would be a probability that x bar is less than k, and that is 0.95, and here somewhere you will be locating your k. Okay, and this would be x bar. Fine. So this is basically how you can just solve the question. And if I just need to write the conclusion of this, so what can I just write? The 95th percentile. I can write the 95th percentile for the sample mean exists for the sample mean. For the sample mean, okay, it's not that this exists, it's okay, sample mean EXC exists, time used is about 26.0 minutes for random samples, of 80 customers, and like all the afterwards thing whichever I have just written in the question. I will just not repeat that thing right here. Okay, so it was for 80 customers who exceed the basic contract time allowance. Okay, so for them it is 26.0 minutes, right? So what else you can just conclude from here, right? So these are the things which you can conclude. Now I can even see one more thing here, that 95% of such samples, would have means under 26 minutes. Okay, 95% of samples would have means under 26 minutes, and you can even say that only 5% of such samples would have means above 26 minutes. So only, I would just come down here, only 5%. Only 5% of such samples would have mean above 26 minutes. Fine. So this is the whole idea, that basically how you can just solve this questions for central limit theorem. And even here I just took one more example for finding the percentile also, right? So this is how you can just solve the questions, and I hope you just got the idea. And if some question comes that like this one, the third part, which was explain why these are different, A and B are different. So in that case, you can just give a proper explanation like this, that probabilities are not equal because we use different distributions to calculate the probability for individual and for means. Okay, so these types of explanations you can give, right? So I hope you just got the idea that basically how to solve these types of questions if you're just gonna get that questions, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So previously what we have discussed in a statistics video, we had seen a question and basically we have done that question. Just let me quickly show you that question which we had done. So yeah, this was the question which we had previously seen, and we had just done this question right at the previous time from the like concept of central limit theorem for sample means, right? We had just applied the central limit theorems, and even we had find the probability, and even we had just found the percentile also, right? So these were the things which we had seen previously. Now today basically what we are going to see is about the confidence intervals. Now today we are going to start one new topic, and the name for that topic is basically confidence intervals. So just let me quickly write that here. So it's something like confidence intervals. Okay, so this is the topic basically which we are going to study, that is confidence interval. So like when I'm just going to tell you that actually what this means. So before just telling you that confidence interval what it actually is, so I would just like mention here two things that you should just keep in mind while the topic, whenever like we are studying about the confidence intervals, it is just keep in your mind these two things which I'm just going to tell you right now. Okay, so firstly is that confidence level, here I would write confidence level is a random variable. Okay, so confidence level is also a random variable, right? So what is actually random variables? These all things we had already seen previously. Okay, so I'm not just going to repeat that thing right now. So what is actually confidence level is a random variable. Okay, I would just request you to keep this first thing in mind, and the second thing is that it is a let's say I'm just writing it is a parameter. Okay, let's say I'm just naming it as parameter for now. Okay, I'm just not writing the full name. I'm just writing it is a parameter that is fixed. So before I just whenever I'm just going to introduce you right now to confidence level, I'm just going to tell the formulas, I'm just going to tell the definitions. So before that thing, just keep these 2 points in your mind very properly, that confidence level is a random variable and it is a parameter that is fixed. Okay, now whatever I'm just going to tell you right now, just listen to me very carefully, be properly attentive while seeing the video and while studying that whatever I'm just telling you. And even I would just request you to make your own notes also, right? So I'm just writing these things for you so that you can also have a note of all these things at your place, right? So confidence level is random variable and it is a parameter that is fixed. Fine. Now let's move towards the definition for the confidence interval, that how we'll just define this. Okay. So now I will just start writing, and with me you also just start writing a confidence interval is another type. A confidence interval is another type of estimate. Okay, it is another type of estimate. We had seen previously many types, right? So this is another type of estimate, but here we have one condition. But instead of being just one number, but instead of being just one number, and here I would just come down. Okay, it is an interval of numbers. It is an interval of numbers. So this is where you can just define that what actually a confidence interval is. So a confidence interval is another type of estimate, but instead of being just one number, it is an interval of numbers. Okay, so basically what happens in confidence intervals, we have an interval of numbers. It is not that there is only one single number. No, it is not the case in the confidence interval. So in confidence interval, what is the case is that there are interval of numbers. Now what does actually we mean from interval of numbers? Let's say you are having numbers from 2 to 4, all the numbers from 2 to 4. So that is the interval of number, that from 2 till 4 you are having all the numbers. So this is actually what is called as an interval of number. And even I will just let you know the proper definition also for the interval of numbers. So I will just change a color here for a while so that you can just differentiate in definitions also. Okay, so here I would write the interval of numbers. Okay, so that you can just have a proper definition for interval of numbers also. The interval of numbers is a range of values, calculated from a given set of sample data. Okay, so interval of numbers is actually a range of values which are calculated from a given set of sample data. Fine. So this is actually what is the definition for interval of numbers. You can just like tell anyone if anyone basically asks you that what actually you just meant from the term that is interval of numbers, because this interval of numbers is the term which we had added in the definition for the confidence index, right? Confidence interval. So whenever you're just gonna tell the definition for confidence interval, this term that is interval of numbers, that will actually come here, right? So now for that you can just actually tell that the interval of numbers is a range of values calculated from a given set of sample data. Fine. Now that is okay. Now what else? What else I just need to tell here, tell to you about that confidence interval. So here I would just write the confidence interval. The confidence interval is, and let me just come down here, let me just like have some space. The confidence interval is likely to include an unknown population parameter. So the confidence interval is likely to include an unknown population parameter. So basically whenever we are just gonna like find the confidence interval or use this confidence interval, so in that basically there would be like one more thing included, and that is actually what is the population parameter. Fine. Now here I would just let you know some formula for that population, this confidence interval. So I would just again change my color for you. I would just take as green right now. Okay. Now here I'm just telling you something to remember, so just like keep that thing in mind, and also like keep that thing in your notes also. Okay, so here it is, remember that a confidence interval is created for an unknown population parameter, and here even I would just write as unknown. Okay, just let me quickly erase that, because for an unknown population parameter. So this is the first thing which you should keep in mind, that remember that a confidence interval is created for an unknown population parameter. Like, now what are actually population parameters? Like population mean. Okay, so here this population parameter actually includes the population mean, and that is actually mu, right? So like this is the one example. So remember that a confidence interval is created for an unknown population parameter like population mean. So whenever you are just gonna create the confidence interval, okay, so that is actually created for the population parameters like population mean, population standard deviation, and all that things, correct? Now here I would just include that parameters. So confidence interval. Okay, so confidence interval for some parameters, now as I defined earlier about the parameters, right? So confidence interval for some parameters have the form. Now they have a form also. Okay, so I'm just telling you about that form here. So confidence interval for some parameters have the form, and here what I would just do, I would just again take a different color for now, and here I would just take this one, and I would just put the bracket. Okay, now in this bracket the first parameter is post estimate. Now actually what are all these terms? So basically you will just get these things, like what are these and how to use, like as the time comes you will just get all these things whenever you're just going to do some questions. Okay, so post estimate minus margin of error, and here you will put a comma, and here even the second one is post estimate plus margin of error. So these are the some form of the parameters which we have here, okay, in the confidence interval, and the bracket gets closed. So post estimate minus margin of error, comma post estimate plus margin of error. So here we had written that remember that a confidence interval is created for an unknown population parameter like population mean, and confidence interval for some parameters have the form, and this is the form for that parameters. Okay, so these are the like some common form for the parameters. Now one just thing here, that what is this margin of error. Okay, now just quickly let me tell you about that margin of error. So the margin of error depends, the margin of error actually depends on the confidence level, or, and just let me come down. Okay, the margin of error depends on the confidence level or percentage, percentage, or percentage of confidence. Okay, so now the margin of error, what is actually that? The margin of error actually depends on the confidence level and the percentage of the confidence. Fine. So here it was about that actually what confidence level is. So just let me quickly take one more time that whatever I have just told you right now, and for that I would just take a marker, let's say here, and okay, this one is okay, fine. So there were two things which I in the starting before telling the definition for the confidence interval. I told, now please listen to me very carefully because I'm just giving a whole summary whatever I have just told you right now. Okay. So before giving the definition for the confidence intervals, I told you two things about confidence interval to keep in mind. First one is that confidence level is a random variable. Okay. And second is it is a parameter that is fixed. Right. Then I told you about the definition of confidence interval. So a confidence interval is another type of estimate, but instead of being just one number, it is an interval of number. Now, okay, I'm just like erase this color and I will just take the yellow only. Yeah, here. It is actually the interval of numbers. So just this is the thing which you should keep in mind and like note it for a give it a high note, that basically a confidence interval is another type of estimate, but instead of being just one number, confidence interval is an interval of numbers. Then we discuss about that what is actually an interval of numbers. So the interval of numbers is a range of values calculated from a given set of sample data. Fine. Then we discuss the confidence interval is likely to include an unknown population parameter. Okay, and then we just discuss that what are that parameters. Remember that a confidence interval is created for an unknown population parameter like population mean and all that things. And at last we just discussed a form. So the confidence interval for some parameters have the form, and here we have that form, that is post estimate minus margin of error and comma post estimate plus margin of error. So on the above one it is minus and on the down one it is plus. And the margin of error depends on the confidence level or percentage of confidence, right? So here I just told you that actually what is confidence interval and what are the forms that actually this confidence interval follows, and what are the parameters which you have here, what is what is the interval of numbers and all that thing I just discussed here, right? Now what in the next video we'll be seeing some examples and some more things in this. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So today we are going to see some more parameters, some more definitions, some more topics in the confidence interval, and after that we are going to see one example also, right? But I would just want to revise previously that what we have done in the last video. So in the last video I introduced you to confidence level, right? That actually what is confidence level, and basically then we had discussed about the interval of numbers, right? That what are interval of numbers. Then we had moved towards some points which you need to be remember for the confidence interval, and then we had just discussed one like form for the confidence interval, right? That was post estimate minus margin of error comma post estimate plus margin of error. Okay, so now we'll be starting from this point only today. So what I will be just doing is that I will be opening one new file here, that is this one, and right now here from here I will just start here. So just let me quickly take the color, and let's say I'm just taking the color as black here. Fine. Now what is actually, so here I would just write one thing, I would just like let you know one thing here, that margin of error. Okay, previously we had seen that what is margin of error, right? We had just used this term previously, correct? So now here I just want to tell you one more name that is there for the margin of error. So margin of error is called as, now is called as basically is called as the error bound for a population mean. Okay, for a population, I'm just writing the short form for the population mean. So margin of error is also called as the error bound for the population mean. Okay, so this is the second name for the margin of error, and that is basically the just one second, let me take the highlight. Yeah, so the margin of error is also called as the error bound for a population mean. So this is also a thing which you can just call for the error bound for a population. Okay, so you can just keep this thing in mind. Right, now what I have, so now when I just change the name for this, so the form which we had seen previously, that form was, just let me quickly show you that form once more, because we had seen in the starting, yeah, this one, post estimate minus margin of error comma post estimate plus margin of error, right? So now we can just give some symbols to these. Okay, so I'll be now giving some symbol to these values to the form which I have just written right there. So what I will be taking, I will be taking a different color so that it differs a little bit. So here I will be putting the bracket. So first was post mean, right? So I would put here as x bar. Okay, that was minus, and that was actually the margin of error. So in place of margin of error, I can just write the short form for error bound, this one which I had just given the name, that is error bound for a population mean. So we can just give it a short form of as, let's say, EBM. Okay, this is a short form for error bound for a population mean. So here I can just write that short form EBM, comma x bar plus, and here it is EBM. Fine. So this is basically the short form of the form which we had seen previously, right? There we had given the English names to this. Basically, this was the post mean, and this was the this was what? This was the margin of error, right? It was again the post mean and margin of error. So here we had given the symbols to it. Okay, this is fine. Now I just want to let you know one more thing, that basically what does this margin of error actually depends on. Okay, so here I would just write the margin of error. Okay, so we had just seen about the margin of error. So the margin of error depends on DE, and here I will be writing depends on confidence level. Okay, so the margin of error depends on the confidence level. So I am just writing the short form now. I'm just not using the whole name. Okay, so the margin of error depends on confidence level, right? This is done. Now what actually we can just say for the confidence level, what we can just say for this confidence level. Okay, what is it? So here I will be now telling you about the confidence level. So the confidence level, okay, the confidence, previously we had seen only the confidence interval, right? Now we're just going to see the confidence level. So the confidence level is the percent of, and I'm just putting the percent sign. Okay, I'm just not writing the whole. So the confidence level is the percent of confidence interval. Okay, here I'm just writing as confidence and then interval. Confidence intervals that contain the true population parameter, that contain the true population. I'm just using a short form for population. Okay, true population parameter when repeated samples are taken. Okay, when, here I would be writing when repeated samples are taken. Fine. So this is actually what a confidence level is called. So confidence level is the percent of confidence intervals that contain the true population parameter when repeated samples are taken, right? So I hope you just got the idea right now that what actually are confidence level. Okay, now basically we had one more thing here. Okay, now what we have actually, that is actually a probability. Okay, now here I would be just taking a different color for a while, and that is, let's say, this one. Correct. So now here I would be writing that there is another probability. Okay, now there is another denotation, another symbol for a probability. So for that I'm just writing here there is another probability. So I'm just writing a short form. There is another probability called alpha. Okay, so alpha, like I would just write it as alpha, and in the bracket I would even make the sign for the alpha. Okay, so there is another probability called alpha. Now what it is basically related to, okay, what it is basically used for, right? So I'm just writing the like symbol. So alpha is related to the confidence level. Okay, is related to the confidence level, comma, alpha is the probability. This is alpha. Okay, alpha is the probability that the interval, I've just come down here for a while, that the interval does not contain the unknown population parameter, does not, and here I would just write does not contain the unknown population parameter. Okay, so in the previous video only we had just discussed about the population parameter, right? We had just seen one example, and then we had also discussed about the population parameters. So this is actually what this alpha is. So alpha is the probability that the interval does not contain the unknown population parameter, and there is one relation between the alpha and between the like confidence level, and that is alpha plus CL is equal to 1. So this is the relation which is between the alpha and the confidence level. So that is alpha plus confidence level is equal to 1, right? So I hope we just got the idea about some more terms for this confidence interval. So now just let me quickly take a recap, because after this we are just gonna like see the question, okay? So till now, if you just have not heard me very carefully, so now also this is the correct time. You can just hear me very carefully whatever I am saying, okay? So firstly, we had seen that the margin of error is called as the error bound for a population mean. Okay, and we had given it a short form. You can just call it as an abbreviation, and that is EBM. Correct? Then the form which we had seen yesterday, we had converted that form into the symbols, right? So the symbols is actually x bar minus EBM, comma x bar plus EBM. Then we had seen that basically on what parameter does the margin of error depends. Okay, so we actually found that the margin of error depends on confidence level. And now what actually is confidence level? So the confidence level is the percent of confidence intervals that contain the true population parameter when repeated samples are taken, right? So we had seen actually what are the confidence level. Then we had seen one more part of the probability, and that was called alpha, right? There is another probability that is called as alpha. So alpha is related to the like confidence level, okay? Alpha is related to the confidence level. And alpha is the probability that the interval does not contain the unknown population parameter. Okay, so it is that probability that the interval does not contain the unknown population parameter. So the relation between alpha and like confidence level was alpha plus CL is equal to 1, right? So we have discussed about the theoretical things right now. Now just let me quickly move to the question for today. Yeah. So this is basically the question. This is a question, you can just treat it as an example, a very easy example, okay? Now, what is my actually question asking me? So it is saying that suppose we have collected data from a sample, okay? We know the sample mean, but we do not know the mean for the entire population. The sample mean is 7 and the error bound for the mean is 2.5. Now, if I just want to find that form, okay, that form which we had seen previously, how will I be just doing that thing? So for that, what actually I have two values here, okay? I know x bar, okay? I know x bar is equal to 7, right? And even I know that EBM, okay, EBM, that is error bound for the mean, that is 2.5. I basically have these two values, right? So now what was the form for the confidence interval? So just let me quickly write here. So the confidence interval, we had already seen the form right now in the very starting. The confidence interval is, and what was that actually? So that was x bar minus EBM, comma, x bar plus EBM, right? This was the one. So what I would be doing, I would be putting the values here. So that would be 7 minus 2.5, comma 7 plus 2.5. So after calculation, what I would be getting here? So after calculation, I would be getting the output, that is 4.5, comma 9.5, right? These are the values which I just got here. So after calculating the value, so I just got, so what we can just say, this is the confidence interval. So the confidence interval is 4.5, comma 9.5. Now basically, just one second, right? So now basically from here we can just say one thing, we just conclude one thing. So that is basically, if the CL is 95%. Now just please listen to me very carefully, because I am just telling the most important part, okay? If the confidence level is 95%, then actually what we say, then we say that, now if you just got the confidence level as 95%, if you just want to explain the person that actually what it is, right? So what you will be saying, so if the confidence level is 95%, then we say that we estimate with 95% confidence, we estimate with 95% confidence, we estimate with 95% confidence that the true value of the, and here it is value, okay, that the true value of the population mean is between 4.5 and 9.5. Okay, just let me quickly write that. 4.5 and 9.5 downside is between 4.5 and 9.5. Okay, so whenever the confidence level is 95%, then actually what we can just say is that we estimate with 95% confidence that the true value of the population mean is between 4.5 and 9.5. Okay, so this is basically how we just solved a very simple question, right? Here we were just given everything. What we simply need to do is that we simply need to apply that form which we had seen and simply calculate the values. Okay, so that was x bar minus EBM comma x bar plus EBM, and we just computed the values 4.5 and 9.5. So at even we just concluded that we estimate with 95% confidence that the true value of the population mean is between 4.5 and 9.5, right? So now I hope you just got the ideas about some more parameters, some more definitions in the confidence interval, and even you have got an idea that how to solve a question in confidence interval. If you just go, if you just get one question and they ask you to find the confidence interval, so how you will be solving that, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now basically in the last video we had seen that actually what is a confidence interval, right? We had seen that what actually this term means and basically what are the things that are associated with this term, right? Now today is the turn for seeing that basically how to calculate the confidence interval. So basically for calculating the confidence interval, there are several steps situated, right? There are several steps which we need to follow for like calculating the confidence interval. Okay, so today we'll be defining all that steps which you need to calculate the confidence interval. Fine. So just let me quickly take one color. Let's say okay, red only. So here I will just put the heading for a while. That heading is basically, it is calculating the calculating the confidence interval. Okay, so this is the topic for today that we are going to discuss, and that is calculating the confidence interval, right? So basically we had already seen previously that what is this confidence interval. Let me quickly open that particular file where we had discussed about the same thing. Yeah, right, this is the file, right? We had discussed about the confidence level. Okay, we had discussed about the confidence level and even we had discussed about the confidence interval. Now basically how to calculate these things, basically I will just let you know that thing today. So just let me quickly open that section number 19. Right, let's get started with the things for now. So I would just like take a different color right now. Let's say black. Okay, I would just start writing here. Okay, now just pay attention towards the thing that I am writing here. Okay, so to construct, here I would be writing, to construct a confidence interval, to construct a confidence interval estimate for an unknown population mean. For an unknown population mean, we need data from a, okay, just one second, yeah, from a random sample. Okay, so here I have written that to construct a confidence interval estimate for an unknown population mean, we need data from a random sample, right? So basically whenever we just want to construct a confidence interval, okay, so basically in that case I always need the data from a random sample. Fine, this is okay. Now what about the next thing that we are going to see here is that, so next I will be writing the steps, basically the steps to construct and interpret and interpret confidence level R, and interpret the confidence level R. Fine. Now here I'll be just describing the steps that you need to follow while finding basically the confidence interval, right? I would just take a color and just let me now close it, right? So I would just come down here for a while and I would just like specify the very first point, and the first point is that calculating. So just please make sure that you are writing all these things with me. You are making the notes for these things, right? So I would be just writing calculating the sample mean. So what is the denotation for sample mean? So x bar, right? So calculating the sample mean x bar from a sample data, So first step is that calculating the sample mean, that is x bar from a sample data. But there is one thing which you need to remember here is that, so I would just write here, remember, okay, remember in this section we already and I would just come down. Remember in the section we already know the population standard deviation, that is sigma, right? So the very first point is that calculating the sample mean x bar from a sample data. Fine. Now this is basically a note which will be following in the whole video for this, and afterwards when we will be solving the question for this, then also we'll be following the same thing. Okay, that is why I just put a note. So like if you just don't want to remember it for now, leave it, no issues with that. Fine. So my very first step is that I need to calculate the sample mean, that is the x bar from a sample data. Fine. Now moving towards my second step. So what does my actually second step says to me? My second step says find the z score, that is z scores. Okay, find the z scores that corresponds here I'm just writing that corresponds to the confidence level, Okay, so this is my second step, that is find the z scores that corresponds to the confidence level. Okay, my first step was to find the mean, right? My first step was to calculate the sample mean. My second step is to find the z score that corresponds to the confidence level. Fine. Move towards the third. Now my third step says to me to calculate the error bound. Okay, here I would write, my third step says to me, okay, I would just like correct the spellings for a while here. So I would just write calculate the EBM. Now basically what is the full form for EBM, that I'm just not gonna say. I would just show you that thing because we have done that previously. Okay, so EBM full form for that is error bound for a population mean. Okay, error bound for a population mean, that is the full form for EBM, right? So Here it is. Just one second, let me open that file. Calculate the EBM. Okay, so in bracket I would be writing error bound mean. Okay, so my first step was to calculate the mean. My second step was to find the z-score. My third step is to calculate the error bound mean, that is EBM. Fine. Now moving towards my fourth step. My fourth step is to construct the confidence level. Okay, so here it is construct the confidence level. My fourth step says to me to construct the confidence level. So this means that here we need, this is the step that the fourth step where we need to plot for the confidence interval, where we just need to make a plot to construct the confidence level, right? This is my fourth step. Now moving towards the fifth and the very last step is that, so last step says to me that write a sentence. Okay, write a sentence that interprets and I would just calm down so that I can get a space, right? Write a sentence that interprets the estimate in the context, of the situation, in the context of the situation in the problem. Fine. So write a sentence that interprets the estimate in the context of the situation in the problem. So here this is the last step where what we just need to do is that we need to write a sentence that interprets the estimate in the context of the situation in the problem. Fine. So these are the basically 5 steps which you should follow while finding the confidence level. These are the steps which you will be following. That is, first one is calculating the sample mean, that is x bar from a sample data. So in this step what you basically need to do is that you basically need to find out the sample mean, that is x bar, from a sample data, the data whichever you are just getting, right? So for that data you just need to find out the mean here, right? Now moving towards the second step says us to find the z-score that corresponds to the confidence level. So how to just find out the z-score, that thing we have already seen, right? In the previous videos we had already done several questions also, and even we had seen the full concept also, that how to find the z-score, right? That is z-scores. So second step is to find the z-score. Okay, just let me quickly take a highlighter, so okay, that even I can just highlight the things so that we're able to differentiate very clearly. So the first step says to me to calculate the sample mean. Okay, so I would just highlight the sample mean x bar. I don't know what I'm just highlighting. Yeah, this one. Just one second. Fine. So the first step is to find out the sample mean. Now second step says me to find the z-scores, right? So find the z-scores that corresponds to the confidence level. Fine. I need to find out the z-scores that corresponds to the confidence level. My third step says me to find the EBM. Now what is this actually EBM stands for? So EBM stands for the error bound mean, right? We had already seen that thing previously. Now what my fourth step actually says to me, it says to me to construct the confidence level. Okay, I would just not highlight this one, I would just highlight the word, that is construct. Okay, so my fourth step asks me to construct the confidence level. Fine. And what does my last step says to me? My last step says me to write a sentence that interpret the estimate in the context of the situation in the problem. So my last step says to me to write a sentence. Fine. So these are all the steps which are associated, where you can just follow and use all of these steps for calculating the confidence interval, right? So to construct a confidence interval estimate for an unknown population mean, we need data from a random sample. This is the first thing that you should keep in mind, that you need the data from the random sample, right? So here we just completed all the steps to construct and interpret the confidence level, right? So I would just stop here for a while, and from the next videos I would just take one particular step and explain that how to do the things in that step, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So in the previous video, we had seen that basically we had seen the steps for constructing the confidence interval, right? We had seen that what were the steps for constructing the confidence interval. So now today we are going to take the second step, and that is how to find the z-scores for the confidence level. Because I'm just not taking the very first step for the mean, because mean is very simple and we are doing this thing from the very starting of the statistics series, right? So now I'm just not going to repeat that thing. So in that case, basically I am going to take the z-scores, fine. So second step we are going to start with, and that one is actually finding the z-scores that corresponds to the confidence level, right? This is the one which we are going to take today. So here it goes my new section 20. Fine, so I would just quickly write the heading that what we are going to do today is that I am going to write this thing that finding z for the standard, finding z for the standard confidence level, confidence level, fine. So finding z for the standard confidence level, this is the thing that we are going to do today, fine. Now basically how do I just find the z for the standard confidence level? So here I would just start writing some important things. So just make sure you just take a note of that things, right? So I would just start here. So here I would just write the confidence level, the confidence DENCE, right? The confidence level, that is CL, right? This is the short form for the confidence level, and that is CL. We all know that thing, correct? Confidence level CL, what is this? Is the area in the middle, is the area in the middle, MIDDLE, middle of the standard normal of the standard normal distribution, of the standard normal distribution, and that is CL is equal to, okay, I will just write this thing in a new line of the normal distribution. CL is equal to 1 minus alpha. Do you got something? You remember something from this statement which I just wrote right now, that is CL is equal to 1 minus alpha. So we had studied a relation, and that relation was CL plus alpha is equal to 1, right? We had studied this relation previously. So in that case, basically what is happening here, this alpha is only going to another side. Other than that, this absolutely remains the same. So from here, basically what I am trying to tell you is that the confidence level, that is CL, here the short form, right? The CL is the area in the middle of the standard normal distribution. So confidence level is like, you can say this, you can just like say it is an area, okay? It is an area which is in the middle of the standard normal distribution, right? So formula for finding the confidence level is CL is equal to 1 minus alpha, right? That is okay. Now basically here what alpha is, okay? So I would just like take a different color so that it differentiates a little. So here I would be start writing. So alpha is, okay, so alpha is that so alpha is the area, that is split, and I would just calm down, okay? So alpha is the area that is split equally, okay, that is split equally between the two tails, okay, comma, I'm just writing, okay, I just let me quickly make this tails correct, tails, comma, each of the tails contains an area, each of the tails contains an area equal to alpha by 2, fine. So what is alpha now? Which here I just above like write one formula, right? That is CL is equal to 1 minus alpha. So in this thing, what is actually the alpha? Okay, so alpha is the area that is split equally between the two tails. Each of the tail contains an area equal to alpha by 2, fine. This is what alpha is basically denoting here. Now talking about the z-score, right? So I would just again take a different color. So here it is. The Z score, Z score, or you can just call it as Z score, that has an area, to the right of the alpha by 2, to the right of the alpha by 2 is denoted by. Now basically whatever the things we are having, we have a denotation for all of these things, right? We particularly have a symbol that differentiates each and every concept here, right? So the Z score that has an area to the right of alpha by 2 is denoted by, okay, is denoted by. Now here for that denotation we will be writing Z. Firstly we will writing the Z for the Z score, and then just below that you will be writing alpha by 2. Okay, in the denominator for this we'll be writing alpha by 2. So this is basically how you just denote this Z score. Okay, it has an area equal to the right of the alpha by 2 and is denoted by Z, and here downside it is written alpha by 2, right? This is about the Z score. Now if I just want to solve one example, take one question for this, so how I'll be solving that. So let's say I just take an example here. Fine. So my example says to me that when I'm just given a confidence level here, okay, when CL is equal to 0.95, then what will be the value for the alpha? Okay, so this thing we can just find it on our own. So CL is equal to 1 minus alpha, right? So CL we are given that is 0.95. Okay, that is 0. Just let me quickly erase that thing here. Okay, 0.95 is equal to 1 minus alpha. I would just come down. Okay, just let me quickly close this thing, and I would just come down here. Fine. So it would be 1 would come this side and alpha will be here only, and then the minus sign. So it would be, just let me quickly erase this for a while from here, and just let me quickly go above once. Here it was CL is equal to 1 minus alpha, right? So okay, just let me quickly erase that thing for a while, right? So when example is when CL is equal to 0.95, then what will be the value for alpha? So alpha will be 0.05, right? Because when the addition, it is very simple. Why I just don't know why I was just writing that thing. Let me explain you this way only. That when we were just writing the things, that CL plus alpha is equal to 1, the value for both becomes always equal to 1, right? So in that case, if CL is given as 0.95, so alpha will be 0.05 only, right? Because we just want the 1 here. Fine, that is okay. So now what I can just, like, more things can I just write from here. Now if we just want to find the alpha by 2, okay, we had just seen alpha by 2. Let me go above and show you that what was that thing actually. So alpha is the area that is split equally between the two tails, right? Each on the tails contains an area equal to alpha by 2. Okay, so in that case I will be calculating here as alpha by 2. So I would be getting 0.025. You can just calculate that thing on your own using the calculator. So even you can just do this thing manually also. Fine. So this is basically how you will be just getting these values. Now just come down here. So while, now here I would just write while Z of A, or you can just call it as alpha, A by 2 is equal to Z of 0.025. Yeah, this is the value which we got for alpha by 2, right? So I just wrote that value here, make it as alpha, right? So what I can just conclude from here is that, the area to the right of 0.0, okay, not 0.025, I would just like denote here Z1. Okay, so Z was 0.025 is 0.025 and the area to the left. Now when you just want to find the area to the right, what we just do? We just do alpha by 2. First we find the value for alpha and we simply do alpha by 2. Now if we just want to find the area on the right, on the left hand side, for the right hand side we just do alpha by 2. If you want to find the same for the left hand side, so what we do? So for the left of Z, okay, I will just write complete the whole statement. Z 0.025, or to the left of Z, and in denominator it is 0.025 is. So you just like minus the value, subtract the value for the alpha by 2 with the 1. for finding the area to the left. Okay, so 0.025 and that is approximately 0.975. Right, this is a subtraction for both of these. So the area to the right is 0.025 and area to the left is 0.975. Right, so I hope it has got the idea that how to find the z value, how to find the value for the z. Right, so this was the thing that we have done today, that was finding z for the standard confidence level. Fine. So we had seen one formula here. After we had seen about the alpha by 2, and then we had just simply seen one example, right? So I hope you must be clear with that, basically how we just proceed with the first step for finding the z, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So previously what we had seen the procedures for finding the confidence interval, right? Just let me quickly open that section for you. Just 1 second for like that. Okay, so this was basically how we'll calculate the confidence interval. What are the steps for doing all that things, right? So in that we had seen the second step. Okay, the first step we already know that how to find the mean. Okay, so I have not taken that step. So the second step was z-score. So we had already seen that z-scores in the previous video, right? Now today basically we'll be seeing about finding the EBM. Okay, the full form for EBM is error bound mean, right? So you'll be seeing this third one, the fourth one and the fifth one, all the three in today's video, right? So finding the EBM, constructing the confidence level. So this is basically constructing a graph, okay? And at the fifth, basically writing a sentence that interprets the estimate in the context of the situation in the problem. Fine, so we'll be seeing all these three things today. So let me quickly open one new file here. Yes, right. So let's start with the things for today, and just let me quickly choose one color for writing. And yeah, here we go. Now I would just request you to please pay proper attention, because if you had seen the previous video, in that video I had told, and if you're just not going to pay attention to today's video, then basically you will not be getting all the steps for calculating the confidence interval. Okay, right. Now EBM, full form from this for this error bound mean, right? Error bound mean. This is actually we have already seen. Now basically for what it is actually used. Okay, so here I'll be writing the error bound formula, for an unknown population. As we all know that this basically EBM works on the unknown population, right? We already know this thing. So the error bound formula for an unknown population mean, okay? We basically have some population parameters, right? So in that basically population mean is one of that population parameter, right? We all had discussed these things previously in the videos also, right? So population mean, and which is denoted by mu, right? Mu is the symbol for the denotation of population mean. I would just write one more condition: when the population standard deviation, okay, so population standard deviation is another parameter for the population parameters, right? So symbol for standard deviation is sigma. So I'm just writing that sigma here, right? Is known as, and now here it is basically known as EBM, right? So here I will be writing EBM. Now what's the formula for finding the EBM? So for that I would just take a different color so that it is properly visible about the things, right? Now Z is basically what we had already seen this thing in the Z scores, that Z is actually the Z score, right? Z. Right, so here in this denominator for Z, I would write alpha by 2. Okay, so this was a denotation for the Z scores, right? We had seen the left portion and even the right portion in the Z scores video, if you remember that, right? So that thing I'm just taking here, and what I am just doing is that I'm just multiplying it by sigma upon under root of n. Okay, now sigma is basically my standard deviation and n would be basically the population or some random variable, random value, whatever it is given. So n is basically referred to as the total population. Fine, that is done. So this is the formula for calculating the EBM. Fine. Now what next we have here? So next thing we have just discussed about the error bound formula, that how to just find out that thing. Now second comes basically the constructing of the confidence interval, right? So how will we do that thing? So that will be done, 1 second just. Fine. So here I will be writing the second heading, and that is basically for us, that is constructing the confidence interval. Okay, now we'll be basically seeing that how to construct a confidence interval. I would just come down here, right? Now basically what does it actually tell us, right? Before like learning that thing, that basically how to make this thing, we just need to know that what actually it tells us, right? So for that I will be just writing here the confidence interval estimate. Okay, the confidence interval estimate has the format. Now format we all know, and since from the previous 4 to 5 videos, since the topic when I started is confidence level, confidence intervals, till that point, from that point only I am just telling you the format. So the format is basically x bar minus EBM comma x bar plus EBM, right? We had already seen this thing. Fine. So just let me tell you, the confidence interval estimate has a format, and the format is actually, so x bar minus EBM, okay, EBM is error bound mean, okay, comma x bar plus EBM. So in the first one it is basically x bar minus, and on the second one it is basically x bar plus, right? This is the format for the confidence interval estimate. Now basically what does the graph, and basically how to just make that graph, right? That thing just come here, main thing. I would just write the graph gives us the picture of entire situation. Okay, basically whenever we just make some graph, so from that graph only we just understand the half or more than half part of the solution, that what we are actually going to do and what is going to happen in the solution, right? That is why basically in statistics graphs are preferred mostly. Okay, you have seen, even if you have just studied with me from the very starting of this basics or statistics playlist, so there you have seen, if I am solving any of the questions, so it is compulsory that I will be making the graph for that thing, right? I always make the graphs for any of the question, even for subparts of the questions also I make the graphs, because the graph gives us the picture of the entire situation, that actually what is happening and like what else you need to do here in this question, right? That is why basically we just plot the graph. So here I would just write, now basically what is the condition here? So CL is the confidence level, okay? CL plus alpha by 2 plus alpha by 2. Okay, so this will basically result us in the format of CL plus alpha is equal to 1. Okay, CL plus alpha is equal to 1. Right. So this is the basically format which we use for finding and for making the graphs as well. Okay, the graph gives us the picture of the entire situation, and basically CL plus alpha by 2 plus alpha by 2, and whenever you're just gonna calculate that thing, so it will result you this final output, final condition, or you can just final relationship between CL and alpha. Okay, so CL plus alpha is equal to 1. Right. Now basically it's the turn for making the graph. Now I would just request you to listen to me more carefully, okay? A little bit more carefully. So I would just like firstly take a different color so that it is like properly done, and I will just make a line here. Fine. Okay, my line goes like this. Okay, like this. Okay, it's fine. It's fine. Okay, and just let me quickly calm down a little bit so that, yes, right. And now we all know that it is a bell-shaped, right? Bell-shaped graph, right? We had already studied in the very starting, not in this topic, even before this topic only we have studied, right? So this is something which is called as bell-shaped, and like I don't know it is very properly made or not, but actually this is actually what a bell-shaped is, right? Now in bell-shape, basically for finding this CI, we just like divide it like this, okay? Now this middle portion which you are able to see, okay, before that just let me quickly put one point here. This is the x bar. X bar is actually my mean. Fine. So at this point, what will be there? At this point, my format will be X bar plus EBM, error bound mean, right? X bar is my mean plus error bound mean. And on the other side, basically on the left side of the X bar, it would be X bar minus EBM, right? So make sure to give the very proper things here, that on the right hand side, it would be X bar plus EBM, okay? And on the left hand side, it would be X bar minus EBM, right? Now what else I just have here? So this portion. Now what is this portion actually? This portion is actually alpha by 2 for me. Right? This portion is actually alpha by 2. What about this portion? This portion is also alpha by 2. Right? Now what about the middle portion which I have here? So what is this middle portion for me? So middle portion is CL is equal to 1 minus alpha. Now from where the CL is equal to 1 minus alpha actually came? So right now just I told you one condition, that is CL plus alpha is equal to 1, right? So simply I just took alpha on the side of 1. So simply this equation comes, that is CL is equal to 1 minus alpha. Now just let me quickly highlight the middle portion which we had just made right now, this portion, right? So this is the portion in which you will be writing CL is equal to 1 minus alpha, this portion. Okay, just let me quickly highlight that so that it is properly visible even to you, right? Yeah, this one, right? So here this portion is actually called as my CL is equal to 1 minus alpha 1, right? And on the other sides of both of these things, it is basically the alpha by 2 and alpha by 2, right? So just let me now quickly take that color once again so that I can write. Fine. So this is basically how we just make the graph in the CL, right, for the constructing of the confidence interval. Now basically we are left with the very last thing, and that is basically how to write a proper format of the like last situation, last answer which we get, right? How to write that proper format, right? So let me just quickly write that thing here or here so that you can just like take a note of that thing. So just let me quickly take that different color, black one, right? So here my next topic is writing the interpretation. Writing the interpretation. INTERPRETATION. Right. So it is basically writing the interpretation. Now here I'm just listing some things. So just make sure you have a note of those things. Okay. Fine. So here I am writing the interpretation. My first thing. Okay. The interpretation should clearly state the confidence level. Okay, the first thing which you should keep in mind is that the interpretation which you are just going to write, okay, that interpretation should clearly state the confidence level. Okay, this is the first thing. Moving towards the second one. Now second is basically, okay, not the second, I would just put one comma and I would just write here only, right? I'm just not making some different points here. I would just put a comma. Okay, just 1 second. Right, here I would just put one comma and I will start writing here. Fine, so basically I would just put a comma, and then after that what you need to do is that you need to explain what population parameter, okay, we have population parameters right now. I just mentioned about them, that are basically the population mean, the population standard deviation, right? Parameters. Explain what population parameters is being estimated. Okay, is being estimated. You can say population means whatever. Okay, and what about the last point? And should state the confidence interval. Okay, the first one was the confidence level, and now it should state the confidence interval. Okay, confidence interval, and in bracket it is CI. Fine. So this is basically what are the things which you should include in your basically interpretation. And if you just want a proper format only, that basically what are the things that I should how should I write? So I'm just telling you that thing. So put one semicolon. So here you can just write that in the form of that we estimate with dash percent confidence, okay, I'm writing a short form for confidence, okay. We estimate with that dash percent confidence that the true population mean, is between this and this, right? So this is the correct format in which you should be writing that we estimate with dash percent confidence that the true population mean is between this and this, right? So this is basically how we just like write the things, how we just like okay, just let me only go above for a while, right? So first one I had just explained that basically, okay, right. So at the very first I just explained about the EBM, right? That what is actually EBM and what is the procedure for finding that. After that, we had just seen that how to construct the confidence interval, right? And at last we had seen that how to write the interpretation, how to write a proper interpretation, okay? So at last, here I just gave you a proper format also, that if you just want to write the proper format one, okay, so what thing you should actually follow, right? So I hope you just got the idea that basically how to find the EBM, how to find the confidence interval, how to plot the graph, and even how to just write the interpretation, right? So we will stop here for a while. So this is all for this video. Till then, thank you. Till then, take care and thank you. Hello everyone, my name is Shambhavi. Hope you all are doing well. So in the previous video, we had seen that basically what is the whole procedure for finding the confidence interval, right? Now today we'll be seeing an example that basically how to solve that confidence interval, right? Now here the question is, okay, before that question, let me just quickly take you to the previous slide and where I can just show you how to find the confidence interval. Okay, so this was the z-score and here we are. So calculating the confidence interval. To construct the confidence interval estimate and all these things were written. So first step is that we need to find out the sample mean, right? This is the very first step. Moving towards the second, that we need to find the z-scores. Moving towards the third, we need to find the EBM, that is error bound mean. At the fourth, we need to construct the confidence level, and at 5, at last we need to write the sentence, right? The interpretation, that what you have actually done here, right? So these are the things these are the steps basically which you should follow while finding out the confidence interval, right? So my question says to me that suppose scores on exam in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points, okay? I have the standard deviation value here, okay? A random sample of 36 scores is taken and gives a sample mean of 68. I even have the value for the sample mean. So find the confidence interval estimate for the population mean exam score. And my problem is that I need to find a 90% confidence interval for the true population mean of a statistics exam scores, right? Now, please listen to me very carefully because now I am just going to solve this question and let you know that basically how we solve these types of questions, okay? Right, let's start with the solution here. So firstly, let's write the things that what the things we are having from, like we just conclude from this here. So the first thing is that I have the value for x bar. Okay, so x bar is 68, right? So from getting the x bar, what I can just actually find is the EBM, right? EBM is equal to z of alpha by 2 into sigma upon under root of m, right? So even I have the value for sigma, so sigma is equal to 3, right? And even I have the value for n. So for n, I have the value of 36. So in the previous video only, I mentioned that n is a random sample, right? I mentioned that thing, right? Okay, so these are the things which I have from this particular question. And now what I need to find is about the very first step is finding the EBM, right? And even I know that the confidence level is 90%, that is in bracket I can just write as CL is equal to 0.90, right? We just know this thing because here it is written that find the 90% confidence interval, correct? Okay, Let's move forward with the things for here. So from here I can just say that Cl is equal to 0.90, right? So from here I can just add one more thing. So alpha is equal to 1 minus Cl, right? We had seen this thing in the previous video that we can just like we have a condition that Cl plus alpha is equal to 1. This one is the condition. Let me just quickly write it with the some different color. So it is Cl plus alpha is equal to 1, right? This is the condition that we have basically. Right, so if I just take Cl to another side, it will become the negative 1, right? So alpha is equal to 1 minus Cl. That thing only I just wrote here, okay? So let me just quickly take that previous color only from which I was just writing. Alright, so now alpha is equal to 1 minus Cl, right? I can just put out the values here, that is 1 minus 0.90. So from here, what value do I get for Cl? So Cl is equal to 0.10, okay? From here I just got the value for Cl and that is 0.10. Fine. And now if I just want to find out the alpha by 2, okay, so what I would do, I would write 0.10 by 2. So that is what? 0.05, right? 0.05, that is the value. Now what next do I have here? Next I have basically I need to find the z of alpha by 2. Okay, so that is equal to z of 0.05. So we have seen in a G scores, right, that z of alpha by 2 is equal to z of basically alpha value here of alpha, right? So that only thing which we like just wrote it. Let me quickly take a eraser and make it in a, okay, let me just quickly write this with a different color so that it is like basically we are able to see that what is the thing. So z of alpha by 2 is equal to z of 0.05. Okay, this is the thing which we just write here. Now from here what I can just say, I can just say that, let me quickly take that previous color only. So here we are and the purple one, right? So from here I can just say the area, okay, the area to the right of z 0.05, okay, is 0.05, okay, and the area to the left of z of 0.05, let me just quickly calm down here, and the area to the left of z of 0.05 is 1 minus 0.05 and that is equal to 0.95, right? So here from here we just got the area to the right of this and the area to the left, right? Now what are the things that I can just like calculate and estimate from here? So from here I can just now calculate the things and just let me really calm down here, right? So now from here I can just write z of alpha by 2 is equal to z of 0.05, which is equal to 1.645. Now basically you can just calculate this thing and find out this value, right? From now I can just find out the proper EBM. So EBM is equal to 1.645 multiplied by, now this is a multiplication sign, okay, this is not my decimal one, multiplied by 3 upon under root of 36, right? So when you are just going to calculate this whole value, so you are going to get the output as 0.8225. Okay, this is the value which you are going to get. So just verify that on your own, right? Now, so here from here I can just find out x minus EBM and x plus EBM also, right? So x bar minus EBM is equal to, that is 68 minus, so x bar was 68, the mean was 68, right, for the question. So 68 minus 0.8225, right? So from here you can just find out the answer and that is 67.1775, okay? And x bar plus EBM, this is the another thing which you can just find out from here. So that is actually 68 plus 0.8225. Okay, now just let me quickly calm down here. Let me quickly calm down, right? That is 0.8225. So from here you can just find out the addition, that would be 68.8225. Okay, 68.8225. Right, so this is basically for how you can just find out the values. Now, what it was asked, it was even asked me to find out the confidence interval. Find a 90% of confidence interval for the true mean of statistics exam scores, right? This was also the thing which we needed to find. Let me now just come down here and let me just quickly take the different colors so that it looks a little bit different here, right? So my first point is here, the 90%, okay, the 90% confidence, the 90% confidence interval is, and here we just got the values, right? First value is 67.1775, that was x bar minus EBM, right? And my second one is here x bar plus EBM, so that is 68.8225. Okay, so this is basically how I can just write the 90% confidence interval is. So for the first format we were having x bar minus EBM, and for the second format from like after the comma we were having x bar plus EBM. So I just did the same thing. Now only we are just left with the very last step, that is we need to write the interpretation. So I will be using the same format which I just told you in the previous video. So from here I will be writing we estimate with 90% confidence, we estimate with 90% confidence that the true population mean exam score, that the true population mean exam score for all statistics students, for all statistics, and I would just come down here, okay, so that I can just like write properly. Score for all statistics students is between 67.18 and 68.82. Okay, so this is basically the like range in which between 67.18 and 68.82. So at last I just wrote my whole conclusion, whole estimation, that we estimate with 90% confidence that the true population mean exam score for all statistics students is between 67.18 and 68.82. These were the values which we had find here, that the 90% confidence interval is between this and this range, right? That is x bar minus EBM and x bar plus EBM, right? So this is basically how we just solve how we can just like solve a question for finding out the confidence interval, right? So I hope I just made this thing very clear to you, and even you had just practiced the question with me, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So in the previous video we had taken one question and we had just basically solved this question, right? We had just like had one question and we had just like done the things and seen the procedure that how to find the confidence interval and even solve that question, right? So just let me quickly show you that question here, right? And even let me just zoom in so that it is properly visible, and yeah, here it is, okay, right? Now, basically, this was a question that we had taken, that suppose scores on exams in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. Actually, basically, in this question, we were given the mean, we were given the standard deviation, and even we were given the sample size, right? We simply need to find out the confidence interval. So, for the finding that we had like previously seen the steps, so we had just done that thing here, okay? Now, here actually what we had done, we had taken the confidence interval as 90%, right? We had just taken the confidence interval as 90%. Now, if I just want to change this confidence interval, then what will happen? Right, then basically will there be some effect on the answer, or basically will there be any effect on the area or something like that? Will something happen or not, right? So basically today we are going to see that if I change the confidence level or sample size, then what will happen, right? So just let me quickly put the heading here, and yeah, here I will just take one marker, okay. Now I would just ask you to listen to me very carefully, because here basically we are going to move one step more further in this confidence interval topic. Right, so I would just put my topic here, and that is basically The name for that topic which we are going to discuss today is changing the confidence level or sample size Okay, so this is basically the topic which we are going to go today, that is changing the confidence level or sample size. So for this I already have one question for you, so let me quickly show you that question here. Fine. Now the question actually says to me that suppose we change the original problem by using a 95 confidence interval. So my question says here is that find the 95 confidence interval for the true population mean statistics exam score, right? So previously we had actually solved the 90%, right? We had actually seen that how to solve the 90% confidence interval. Now if I just change that confidence interval from 90 to 95%, then what will happen here, right? So here I would just like start solving the things for now, and let's see that basically at what final answer we just come here, right? Okay, so I would just start writing here. To find the confidence interval, I would just write the short form for confidence interval, that is CI. Okay, to find the CI, I would just like write here you need the sample mean. Okay, now firstly here I am just writing all the things that we just simply need to find the confidence interval, right? We just need the sample mean, that is x bar, and the error bound mean, right? You remember the EBM, this one, right? So we basically need these two things only for finding the confidence interval. If we are having these two these two answers and these two values with us, so we can easily just find out the confidence interval, right? Because it is x bar, so like the formula for that is x bar minus EBM comma x bar plus EBM. So here x bar is actually the mean and EBM is the error bound mean, right? This is the format for which we use for finding the confidence interval, right? So if we are having only these two things, so we will be able to find out the confidence interval, that what is the confidence interval. So in our case we know x bar, so that is 68, right? Above we had seen the question that basically the x bar was 68, right? Now we even know the EBM, right? So the formula for finding out the EBM is Z alpha by 2. Z alpha by 2, like alpha by 2 will be in the denominator for Z, right? And this is multiplied by, okay, just one second, yeah, multiplied by sigma upon under root of n. So sigma is basically my standard deviation and n is basically my sample size, right? These things we had already discussed in the previous video, so I hope you all remember these things very clearly. Fine. Now, so here I am given my sigma also, so that is basically 3, right? And the value for n is also given, and that is 36. Fine. Now, here I just want to find out the confidence interval for the 95%, right? So if I just like convert that into the point, so that will just come here. So I would just write here the confidence level, okay? The confidence level is, and here I would just write 95%, and in the bracket it would be CL is equal to 0.95, right? So CL is equal to 0.95. This is the value which you just come here. The confidence level is 95% and CL is equal to 0.95. Fine. Now I just got the value for CL and that is 0.95. So now which format or which relation I can just apply here. So I hope you just remember the relation which we have used in the previous video, and that was alpha is equal to 1 minus CL, right? You remember that this was one of the relations which we are having between the alpha and the confidence level, right? So here I will be applying the same. So from here I can just get the value for alpha. So alpha is equal to 1 minus 0.95. Okay, so the value for alpha will come out from here as 0.05. Right, so for finding the EBM, I just got the value for alpha also, okay, that is 0.05. Now if I just want to find out the alpha by 2, because in Z in denominator that is alpha by 2, right? So I would just write alpha by 2 is equal to 0.05 divided by 2, right? So when you're just going to do the division of this, so you will be getting the answer as 0.025, just like divide it all on your own, fine? So that is 0.025. So I know the value for alpha, that is 0.05. I know the value for alpha by 2, that is 0.025. I know the mean, that was obviously given to us in the question, right? Now if I just want to write it in the form of the z, right, so how would I be just doing that thing? So here I would just write z of alpha by 2. Just let me quickly come a little bit here, right? Z of alpha by 2 will be equal to z of, and in the denominator it would be 0.025, right? So z of alpha by 2 is equal to z of 0.025. So from here I can just say this thing, right? Now what is the next step that we need to find is that we need to find out the area to the right and to the left. So to the right we had already got the area. Now is the turn for finding towards the left of the area, right? So what I would just do, I would just come down here, right? Let's start writing the things. So here I will be writing the area to the right of z of 0.025 is 0.025, right? 0.025, and the area to the left of z of 0.025 is 1 minus 0.025, right? We basically like subtract it from 1, and whatever the answer we just get, that will be the area for the left, right? So that is here 0.975. Fine. So this is basically the area to the right of z of 0.25, z of 0.025 is 0.025, and the area to the left of z 0.025 is basically 0.975, right? So this is the value which we had just got here for the area. Fine. So now here I can just calculate the things. So z of alpha by 2 is basically z of here 0.025, and that will be resulting as the output in 1.96. Right, and if I just want to now find out the error bound mean, so now that will be very simple because we know all the values. So the value for z.025 is 1.96. I would just keep it here, and I would just like multiply it by first one was the sigma, right? Above we had just write the sigma, and under the here in the denominator we just simply needed to write the sample mean. So that is under root 36. So after calculating it, you will be getting the final answer as 0.98. Okay, this is the step after when you will solve it. You will be getting the final answer as 0.98. Now, moving towards the format, so that was x bar minus EBM, right? So x bar we were having the value for x bar as 68, and the value for EBM is 0.98 that we have recently found out, right? So after the subtraction of both of these values, I'm just going to get the output as 67.02. 67.02. Right. This is the value which I'll be getting for x bar minus EBM. Right. And what about the x bar plus EBM? So x bar plus EBM is equal to 68 plus 0.98, and that would be 68.98. Right. Now let's go above for a while and see out that is there any difference in the x minus EBM and x plus EBM values. So my values are here, right? So when we had taken the 90% confidence interval, okay, so in that case I was having the x bar minus EBM value as 67.17. Fine. Now when I have just taken it as 95%, now I am having the value as 67.02, that is for x bar minus EBM. And when I have taken the 95% for x bar plus EBM, I am having 68.98. And when I have taken the value x bar plus EBM for the 90%, then I was having 68.82. Right? So yes, there is a difference in the values. Let me just quickly write the final estimation as we just write, and then let's see that what are the things, other things, okay? So just let me write that. Here I would be just writing that we estimate, right? You remember the sentence which I just gave you in the previous videos. We estimate with 95%. We estimate with 95% confidence that the true population, I would just write the short form for population, okay? We estimate with 95% confidence that the true population mean for all statistics, exam scores scores is between, and let me really calm down, and here I would just write exam scores is between. Now what was the interval that we were getting? The interval was, okay, I would just remove this bracket, no need of this. So interval was 67.02 and 68, okay, 68.98. This was the interval that we were getting. So that was basically 67.02 and 68.98. Okay, so this is the final estimation that we have got. Now from here what we can just conclude, why I have just like found out the 95% confidence interval also in this one. Okay, why I have just done that. So just let me take a different color so that I can just write the things for here. Fine, just let me come down here. Yeah, here. Now let's compare the 90% and 95% confidence interval. Okay, the 90% confidence, the 90% confidence interval. Now what was the value for the 90% confidence interval? So I remember, so that was something about 67.18 and it was 68.82, right? So I remember that thing. So the 90% confidence interval is this much, right? So this is the first thing. Now what talking about the 95% interval, the 95% confidence, the 95% confidence interval is, now what is 95% confidence interval? So that is 67.02 comma 68.98. okay, this is the 95% confidence interval, right? Now actually from here what we can just say is that, from here we can just say that 95% confidence interval is wider as, okay, just let me quickly write here, is wider as 0.95, as 0.95 area is larger than 0.90. Yes, that in mathematics, basically in mathematics, this is very true that 0.95 is greater than 0.90, right? So the 95% confidence interval is actually having the 0.95 area, right? And the 90% confidence interval is having the area as 0.90. So 0.95 is bigger, right? So that means the 95% confidence interval is wider. Wider, that means it is basically wider than the 90% confidence interval. So let me go to that place where we had just found out the area. We have written it somewhere. Right, so here we had just used that thing, that is 0.95, right? Here also we had just used that, and in above one, the previous one, it was here. Yeah, here basically this one, right? Here we had just used, right? So this is basically how you can just say and how you can just find out the difference between the 90% confidence and a 95% confidence. So from here you can just say that in both of these, so 95% confidence interval is wider because it has a larger area than the 90% confidence interval, right? So I hope now you just got the point that basically first thing which you can just like learn from this video is that how you can just find out the confidence interval one more time, right? Second thing is that if you just change the value for the confidence interval, then what will be the effect on the final answer which you are gonna get, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically in the previous video we had seen that basically if we just like change out the confidence interval, then what will happen, right? Now today we are actually going to see that if we change the sample size, right? Let's say whatever is the actual sample size, if we change that sample size to anything else, any other value, then what will happen? If we just increase the sample size and even if we just decrease the sample size, then actually what parameter will be affected, right? We are just going to say this thing. And before that, I would just like to give you the summary for the last one which we had seen, okay? So I would just like write here summary and put here summary for effect of changing the confidence interval. Okay, what was the effect of changing the confidence interval? Final summary for the previous one. From this only you can just have a division also, that what we have done in the previous video, right? So I would just write that thing here. I would write that increasing increasing the confidence level. Okay, increasing the confidence level increases the error bound. Okay, increases the error bound. So as we just increase the confidence interval, so the error bound is also increased. And what happens basically? The CI is a confidence interval, right? CI becomes wider. We had seen that when the confidence level was higher, that was 95%, right? In that case, the error bound was also higher and the confidence interval has also become wider, right? We had seen this thing through the area that when we have just increased the confidence level, so that has been come and the area has become the widest, right? So in that case, basically, as soon as you are going to increase the confidence level, so the error bound will be increased and the confidence interval will become the wider. Right now, second thing. So as soon as you're going to decrease, okay, DEC, and here I would just write DECREASIN, right? So decreasing the confidence level. So as soon as you're going to decrease the confidence level, it decreases the error bound. Okay, decrease the confidence level, decrease the error bound, and CL will become actually, so I would just write here, put a comma, and here, sorry, that is CI, okay? Yeah, so confidence interval will become narrow, okay, narrow, right? Any double R, it is OW, fine. So as soon as you are going to decrease the confidence level, so in that case, basically the error bound is also decreased and the confidence interval becomes narrower. Right, so these are the two conditions that we had seen in the previous video for the effect of changing the confidence level, right? Now, today we are going to see the change in the sample sizes. So just let me quickly come down here. I have the question for you for this one, changing the sample size, and I'm just using the same question which we had seen previously. So let me just quickly show you that question also. Right, so my question says that suppose scores on exams in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. Okay, a random sample of 36 scores is taken and given a sample mean of 68, right? Find a confidence interval estimate for the population mean exam score and find a 90% confidence interval for the true mean of the statistics exam scores, right? So this was the question that we had seen previously, right? Now we are just going to change the sample size here only. So previously the sample size that I am having, note it down from here, that I am having a sample size of 36, right? Now see my question here that is given, right? So it is asking me to reuse the original confidence interval. Okay, I would just use my original confidence interval, that is 90%, right? Now it is asking that what happens to the error bound and the confidence interval if we increase the sample size. Okay, now it is asking me to analyze the error bound and the confidence interval. If we increase the sample size, what will happen to both of these factors, right? And it is asking me to use a value for n as 100 instead of 36. Fine, the first one is that it is asking me to increase. Second one, it is asking me to decrease the sample size to 25. So here I have two cases. Fine, so before that two cases, what I would just write, I would just write the required things that are here. Fine. So I would just write the value for the mean. So x bar is 68, right? Now what about my error bound? Okay, just one more time, yeah. So what about my error bound mean? So formula for that is z here would be alpha by 2 multiplied by sigma upon under root of n. Right, this is the value that, this is the formula that will be having, right? Now my sigma is equal to 3. The value for sigma I am having here as 3, right? And what about my confidence interval? So my confidence interval is 90%. It is like especially mentioned above that the confidence interval, sorry, not the interval, confidence level. Okay, my confidence level is 90%. Fine, that is basically, I will just come down. Let me come down here. The confidence level is 90%. So from here I can just say that CL is equal to, okay, I would just write down because here it will be looking like a mess up. So CL is equal to 0.90. Right, and what about the Z? So for Z I am already having the value. So Z for alpha by 2 is equal to Z of 0.05, and previously what was the value? Let me quickly go above and let's see that what was the value here. Right, so that was 1.645. This one, have a look here. Okay, 1.645, correct? So let me just quickly write that thing here. So it is 1.645, right? So these are the things that we already know about this thing, right? About these are the things that were already given. Now, quickly moving towards my very first part of this question. So I would just take a different color, right? Okay. Okay, so now it is my solution part A. Now in this part, basically I am given the size of 100, right? So n is equal to 100 for this part, right? So if we increase the sample size, n is equal to 100, right? What will happen? Let me come down here. Oh, okay, how does this 4 actually write? I don't know, right, basically. Right, so here I am just writing when n is equal to 100, so I would just write okay, for n is equal to 100, I would just calculate the EBM. So EBM is equal to Z of alpha by 2, right? And in bracket, it would be it would be sigma upon and the root of n, right? So as soon as you're gonna put the values here, so value will be 1.645 multiplied by 3 upon under root of 100. Right, so as soon as you're just gonna solve this thing, so you are gonna get the output as 0.49. Let's say it is 0.49. Okay, 0.49 is the value which you are going to get here. Let's say it is somewhat 35 or something like that only. Fine, 0.4935. Right, so this is the EBM when you are getting when your n is equal to 100. Fine. Now, basically, what about the second one? So my second solution asked me to decrease the value for this n, right? So it is basically n is equal to 25 here, right? So basically when n is equal to 25, so my EPM is equal to z of alpha by 2 multiplied by sigma upon under root of n, right? So in that case 1.645 multiplied by sigma is, the value for sigma is 3, right? And value for under root n is 25, under root 25. So after calculating this, you will be getting 0.987 something as the output, right? So these are the two outputs which we just got here. So okay, let me just like take the cursor so that I can show you, right? So here when I had just taken my first condition, that is when n is equal to 100. So in that case, my EBM came as 0.49, right? And now when I have just taken my n is equal to 25, so my EBM came as 0.98. So from here what you can say as soon as your sample size is increasing, the error bound is decreasing. Have a look here. When you took the n is equal to 100, this condition, n is equal to 100, okay? In that case, basically what EBM you got? You got 0.49, right? Let me calm down here. And when you took n is equal to 25, that is a smaller n value, then you got the error bound here as 0.98, so that is increasing, right? So this is the thing that we can just like conclude out from here. So let me just quickly write out the whole summary for this thing. Let me take a different color. Fine. So for summary, what I can just include here is that in the summary one, I can just include the first point. Okay, the first point says that increasing the sample size causes, and I will just come down so that I can just write it easily. Okay, a little bit up. It is too much down, right? Okay, just 1 second. So increasing the sample size causes the error bound. Increasing the sample size causes the error bound to decrease, right? This we had just seen that thing right here, that as soon as we had just increased the sample size, so the value for the error bound has been decreased, right? That we had seen. D here, ES here, that is okay, right? Making the, and if the error bound will decrease, so that will result in the making of CI, that is confidence interval in the narrower direction. Narrow direction means it will make it narrow. Okay, so as soon as you increase the sample size, your error bound decreases and your confidence interval becomes narrower. Now, so moving towards the second point. So here I will just take the second point. So second point is decreasing the sample size. Okay, as soon as you're going to decrease the sample size, the thing that comes here is that the error bound increases, right? That also we had just seen right now. So the error bound increases. So here I would just write here error bound increases, and what happens to the CI? And CI becomes making the CI wider. CI is my confidence interval, and my CI becomes wider whenever I am just going to decrease the sample size. The error bound increases and the CI becomes wider, and whenever I am just going to increase the sample size, then error bound decreases and CI becomes narrower. Right, so I hope it has got the idea that what is the relationship between the sample size, between the error bound and between the CI. Right, so this here we just like saw one question in that we had just taken one larger value of n and one smaller, and then we had just calculated the EBM, and that is error bound mean, and just come to this final conclusion that as soon as you increase the sample size, the error bound decreases and your confidence interval becomes narrower. Fine, and as soon as you decrease the sample size, the error bound increases and your CI, that is confidence interval, becomes wider. Right, so now I just hope that it is very clear to you that if you just like basically what is the effect of the change in size on the other factors also of this part, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically today we are going to see some more methods for finding the error bound and the sample mean. Right, so in the previous videos we had already seen that what we actually mean from error bound, what we mean from sample mean, right? We had already seen all these things. Now today I'm just going to tell you some more methods. Like there is a method that actually goes from backwards. Okay, today I'm just going to tell you that method for finding the error bound and the sample mean. Right, so I would just put the heading once and then we'll start the writing. And so here I'm just writing that working, as I mentioned that it is backwards, right? So in that case I'm just writing here working backwards to find the, so basically what I'm just going to find here today, so I'm just going to find the error bound and the sample mean, okay? To find the error bound and sample mean. Okay, so for sample mean I'm simply writing SM. Okay, let me just quickly write it full. Right, that is sample and then here mean. Right, so basically today we are going to see one method that actually works backwards to find the error bound and sample mean. Now basically what are these? I'm just not going to repeat that today because we had already discussed this thing previously, right? Now first I would be telling you that what are the requirements for working on the backwards to find the error bound and sample mean. Okay, first I will let you know that what are the requirements for that. So here I'll be writing that if we know the CI, now CI basically stands for confidence interval, right? We had already seen this thing also, that how we can just find out the CI, right? So in that case I'm just writing if we know the CI, so here I'll be writing we can work backwards. We can work backwards to find both. Now basically both actually refers to the error bound and the sample mean. Okay, I'm just not writing that very clearly, but I'm just telling you that what is actually needed for working the backwards to find the error bound and basically sample mean. So we just can here, if we know the CI, that is confidence interval, then we can just find out these things working backwards, right? Now basically firstly I will let you know how to find the error bound, and after that I will let you know how to find the sample mean. Okay, so for that basically what I will be just doing is that I will be putting one heading. So my heading for first which I'm just going to discuss today is basically finding the error bound. Okay, so I'm just going to write here finding the error bound. Okay, this is the thing that I am going to discuss right now here. After that I'll be taking the sample mean. Right, now basically when I just talk of finding out the error bound using the working backward, if I just find out, so in this also basically we have two ways. Okay, we have two ways for finding the error bound working backwards, right? Let me just quickly discuss both of them with you. So basically here the first method which I'm just going to discuss is that, so I'm just going to write that, so I would just make sure, so basically wherever you're making a notes, make sure to write these things there because it is very important. You should also know the different ways for finding something, right? So I'm writing for finding. So basically from the upper value for the interval, okay, whatever we are having the upper value in the interval, right? So from the upper value for the interval, what I will be just doing is that I would be subtract the sample mean. Okay, that is, I'll be subtracting the sample mean. Okay, so where is my cursor here? Subtract the, and here I'll be writing sample and then mean. Right, so this is the first thing that you can follow, that from the upper value of the interval, subtract the sample mean. Okay, let me quickly write that sample mean once again, because I can just write that there itself. So no need to just make one new line for that. Okay, so subtract the sample, and here I would be just writing here as mean. Okay, so this is the first way which you can follow, that from the upper value of the interval subtract the sample mean. Right, and talking about the second, so here I'm just writing or, and my second procedure, which is actually here for finding the error bound, it says that from the upper value, okay, from the upper value for the interval, okay, whatever the interval we are having, so in that whatever is the upper value, then I'll put a comma, and here I'll be writing subtract the lower value. Okay, subtract the, I would be writing here lower, and I would just come down so that I can just write here value itself. Subtract the lower, and here it is value. Okay, so these are the two methods which we can follow for finding out the sample mean. The first one says that from the upper value for the interval, subtract the sample mean. Okay, or second says that from the upper value for the interval, subtract the lower value. Only the difference is that in the first one you can subtract the sample mean, and in the second one you can subtract the you can subtract the lower value. And then basically what is, then you can divide the difference, either of the methods whichever you are following. This last step which I'm just writing here, then divide the difference, that follows for both of them. Okay, so if you're applying the first one or the second one, that totally depends on you, but it is mandatory to apply this last rule which I'm writing here. Okay, so it is, then divide the difference by 2. Yes, then divide the difference by 2. So this is basically the step which you need to follow at last, and it is mandatory for both of the conditions. Either you subtract the upper value with the sample mean, or you subtract the upper value with lower mean. That's your choice. But this last step which is written here, that is then divide the difference by 2. So this is you need to follow at each case. Okay, so these are the ways which you can follow for finding out the error bound. Okay, these are the two steps. Right, so first one I would again repeat, from the upper value for the interval, subtract the sample mean, or from the upper value for the interval, subtract the lower value, then divide the difference by 2. Right, these are the two which you can follow for finding out the error bound. Now for finding out the sample mean, what are the steps which you need to follow? So my heading would be finding the sample mean. Right, finding the sample mean would be my heading for now. Okay, now basically what are the steps which you can follow for finding sample mean? So for sample mean also we have two steps. Okay, either of them you can use. So my first rule says that subtract the error bound from the upper value of the confidence interval. I'm just simply writing CI here. Okay, I'm just not writing the full form. So for finding out the sample mean, my first step says that subtract the error bound from the upper value of the CI. CI is my confidence interval. Or even we had one second option also, so I would just write or here. And second value says that procedure says that average the upper and lower. Okay, 1 second. Yes, it says that average the upper and lower endpoints. Endpoints, do you like understand, right? The points which are at the very end. So average the upper and lower endpoint of the confidence interval of the CI confidence interval. Right. So these are the two ways which you can follow for finding out the sample mean. Just give me 1 second. Let me quickly take the cursor. Right. So for finding the sample mean, these are the two ways which you can refer. The first one is subtract the error bound from the upper value of the CI or average the upper and lower endpoint of the CI. Right, so I have told you the procedures, two procedures for finding the error bound as well as for finding a sample mean. Now, if we just jump towards one example for this, so let's even see one example also. So I have one question here. Fine. So this is the question that I have, and here we'll be finding the error bound and as well as the sample mean. I do not know that what is actually question asking to us. Let's see that what is actually question asking to us. So question says that suppose. Okay, calm down. Let me just 1 second. Yes. So my question says that suppose we know that the confidence interval is this and this. Okay, we are having the value for confidence interval. Okay, and we want to find the error bound. Okay, the first thing is that we need to find the error bound. We may know that the sample mean is 68. Okay, sample mean is 68. Okay, fine. Or perhaps our source only gave us the confidence interval and did not tell us the value of the sample mean. Okay, so basically here firstly I'll be finding out the error bound, and after that basically what I'll be doing is that I'll be even finding out the sample mean. Even it is given, but here afterwards one thing is mentioned, or perhaps our source give only the confidence interval. Then how you'll be finding the sample mean? So everything I'll be just telling you here. Okay, so let's do the question here, and what I'll be just doing is that I'll be writing here solution. Fine. Now, firstly, what I'll be just doing is that I would be writing here that calculate the error bound. Okay, firstly, I'll be calculating my error bound. And what is my condition? My condition is that if I know the sample mean. So here I'll be writing if I know sample mean, because in this question I am given the sample mean, that is 68, right? So I'll be calculating the error bound if I know the sample mean. Okay, so basically here what I'll be doing is that I'll be writing 68. Now 68 is my sample mean, right? And that is my error bound mean, that is my EBM, right? Error bound mean. Fine. Now basically for finding out my EBM, what I'll be doing is that I'll be writing 68.82 minus 68. Now basically what is the 68.82? So this is the second value which I am given here in the confidence interval. I'm just like subtracting it from the upper value. So what was there in the section, okay, what was there in the error bound when I just told you? So just again have a look that from the upper value of the interval subtract the sample mean. This rule I am following, okay, that from the upper value of the interval subtract the sample mean. So here my interval is the 67.18 and 68.82, right? So I'm just subtracting the upper value from the sample mean, and sample mean is 68, right? So from here I'd be getting 0.82. Okay, this is my first step. And what if I don't know sample mean, and if I don't know sample mean? My first case was that if I know sample mean, and my second case is that if I do not know sample mean, then what will I be doing? Again, go back to that slide where I just explained you about that. The second case was from the upper value of the interval, subtract the lower value, then divide the difference by 2. Okay, I would be doing the same thing. So come back here. I would be writing here EBM, that is my error bound mean. Okay, subtract the upper value. So my upper value is 68.82. Okay, with the lower value. My lower value is 67.18. Let me go to the question and let you see. Okay, 67.18, right? So subtract the upper value from the lower value and then divide it by 2. Okay, then also I'll be getting 0.82. Divide that on your own, right? So this is basically how we can just find the error bound if we know the sample mean or if we do not know the sample mean, right? Now my second option that comes here to me is that I need to find out the sample mean. Okay, if I know the error bound, I need to find the error bound, right? If I know the sample mean or not. Second part is that I would be calculate the sample mean. Okay, calculate the sample mean. And in this also I'll be again following both the cases for which I have given you the way that how to find out. My first way is if we know the error bound. If we know the error bound. So if I know the error bound, then in that case, basically what was the idea? The idea was that I need to subtract the upper value of the interval with the error bound, right? This was the very first thing which I told you for the mean. Let me show you that thing. Okay, so here it is subtract the error bound from the upper value of the CI, okay, that is confidence interval. So here I'll be doing the same thing. So x bar is my sample mean, okay, x bar is my sample mean, and in that case I'll be writing here 68.82 minus 0.82. Now basically 0.82 is my error bound, okay, so I'm just subtracting that. So here I'll be getting the answer as 68. Yeah, that is okay. And second thing, if I do not know the error bound, if I don't know error bound, yes, this was also one of the case, right? If I do not know the error bound, then what to do here? Again, my procedure would be same. I need to now basically instead of subtracting, I would be adding the upper value and the lower value of the interval. Here is my okay, average the upper and lower endpoints of the CI, right? So firstly I'll be adding them and then be dividing by the 2, because that is the average, right? So here x bar is equal to my upper okay, let's say upper or lower, anything we can take, because here we are doing the addition, okay? So 67.18 is a lower interval, and 68.82 is the above interval, and right, and for finding out the average I will be dividing that by 2. So here I would be getting the answer as 68. Just find that on your own, okay? Here I would be getting the answer as 68, right? So I hope now you just got the idea that how to find out the sample mean and error bound, okay, with the working of backwards. So this was basically how we can just find out the this was the topic, working backwards to find the error bound and sample mean. So this is how we can just find out the error bound and the sample mean, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically today we are going to say that how to calculate the sample size n. Now basically today we are going to see one new formula for calculating the sample size, right? Sample size is basically denoted by n, right? So basically we are seeing all these things from the very starting of this inferential statistics. Right, so what I'll be just doing is that I'll be making some modifications on the formula, that is error bound mean. Okay, I'll be making some modifications into that formula, and that after the modifications of that formula will surely lead to the formula for calculating the sample size n. Okay, so firstly what I'll be just doing here is that I'll be firstly putting up the heading here. Okay, so heading for today is basically calculate the sample size n, right? This is a topic which we are going to discuss today, calculate the sample size n. Now as I mentioned that I'll be making some modifications into the formula of basically error bound mean, okay? So before doing that, let me just quickly write down something here so that you can also have the notes of that, and I will be just writing the formula for the error bound mean as well. Okay, so this is the thing that I'm just going to do here right now. So basically what I'll be just doing here is that I'll be writing the error bound formula, for a population mean, the error bound formula for the population mean when the let me just come down here so that I can just write that properly. Okay, so the error bound formula, okay, the error bound formula for a population mean when the population standard deviation, okay, when the population standard deviation is known as, okay, deviation is known as, we basically know that what is population standard deviation, right? We already know this thing. And even we know basically what is the formula for error bound, what is it actually, and what is population mean, that also we know, and population standard deviation we are familiar with this term also, right? So we had already discussed all these things in the previous videos, right? So is known as. Now I'm just going to write here the formula that here we have. So for finding the error bound mean, okay, the short form is EBM, right? So EBM is equal to, now here it is Z alpha by 2. In the denominator I'll be writing alpha by 2, and here this dot actually represents the multiplication, right? And I will be writing here sigma upon under root of n. So this sigma is actually denoting my standard deviation, and this n is actually denoting the size of my sample. Right, so we are just familiar with this formula right here. Now, if I just want to make the formula for the sample size, that is n. Okay, now basically what I'll be just doing here, firstly I'm just taking a different color and I'm just writing that what actually here the terms means. This sigma is actually standing for standard deviation. Okay, if you are just not familiar with that, I will just give you a quick revision of that. So here it is, sigma is a standard deviation. Okay, and this n is actually my sample size. Okay, my sample size, that basically what is the size of the sample that we are taking. And this Z actually stands for my Z score, and this ABM you all know that is my error bound mean. Right, I would just again take a different color here so that now I can just write out the formula for finding out the sample size n. Right, so for that basically I'll be writing here that formula for sample size. Okay, we're just gonna find that thing, right? Formula for sample size is, and what I'll be just doing is that I'll be coming down to my next line. So formula for sample size is n is equal to, that is z square sigma square upon EBM square. Now simply just have a look from the previous formula that what changes do I have made here. Only the change that I have made here is that I had simply taken this n to the other side. Okay, simply taken this n to the other side. So EBM has come under this root, and simply when I would just square this whole side, so it will basically give me the final result as n is equal to z square sigma square upon EBM square. So this is nothing new. Only what I have just changed is that I had simply changed the positions of the n and EBM. That is all. Enough that I have just done that. Like other than this, I have done nothing here. Okay. So n is equal to z square sigma square upon EBM square. So z is again the same, that is z square, sigma is again that only, that is my standard deviation, and EBM stands for my error bound mean, and this actually n stands for my sample size that I need to find out here. Right, so this is done here, and what else I can just say from here. And okay, I'm just going to write that in this formula. So basically in this formula, let me quickly let you know one more thing here. After that we'll be moving towards the question. Okay, so I'm just going to write here that in this formula, and now basically what is this z actually referring to? Z actually refers to my z of in denominator, it is alpha by 2. Okay, it is the same, nothing has been changed here. Simply this small z which I have just written here, that is actually referring to z, and in denominator it is alpha by 2. Right, so this is the thing that I just have to follow here, and this was the formula, that is n is equal to z square sigma square upon EBM square. Right, so what I was just doing here is that I will just take a highlighter and highlight that so that you now do not forget about this formula, that what it is actually. Okay, I will just highlight this portion here for a while, and yes, fine. Now basically I'll be taking you towards one question that will be solving that question and seeing that basically how to find out this n. Okay, so that question here I have. Okay, so this is my question that I'm just talking about, that we'll be needing to find out the n here. Okay, now basically here directly it is not given that you need to find n, so you need to just understand the question, and from that you just need to find out that okay, what I actually don't need to find out from here. Okay, so my question says that the population standard deviation for the age of full college students is 15 years. If we want to be 95% confident that the sample mean age is within 2 years of the true population mean age of full college students, how many randomly selected full college students must be surveyed? Now, just when I just read this question, if you listen to me very carefully, so you have got the idea that basically here it is directly not asking to me that I need to find the n, that is sample size, right? I do not like it is it is not mentioned here directly that I need to find n, but read out the very last line which is mentioned here, that is how many randomly selected full college students must be surveyed. Right, so this is actually which is called as n, right? Because in for n what we say that it is a sample size, right? We just take one sample size, and n actually refers to the population on which we are surveying, correct? So basically at last it just asked me to find out that how many randomly selected full college students must be surveyed. So this is the idea which you should follow. for finding out the n. Now basically how to find out the n. So I hope firstly you have just got an idea that you will not be getting directly that you need to find n. Here you need to just have a look over that and you need to analyze properly and come to a conclusion on yourself that actually what is it asked in this question. Right, now moving towards the solution for this question, what I will be just doing is that I will be writing some first I will be writing all the things which I am given in this question, right? Because I have some values here in this question. So here firstly I will be writing from the problem. This is my problem question, right? So from the problem, we know that. Now basically here I have the values. I have the values for sigma. Okay, now how can I just say that? So okay, let me come down here. Okay, sigma I am having the value as 15. Read out the very first line of this question, that the population standard deviation for the age of fertile college students is 15 years. Right, so I am given the standard deviation for the age of fertile college students here, right? So that is 15 for me. So from here I just get the answer that okay, I am having sigma, that is my standard deviation as 15. Right, moving towards the next thing that I have here, and the next thing that I have here is error bound mean, and that is given here as 2. So let me show you that where it is given. So it is said that if we want to be 95% confident that the sample mean age is within 2 years of the true population mean age of fertile college students. So here I am given my error bound mean, that is EBM, that is 2 years, right? So I have just written that thing also here. Now what next do I need to do here is that, okay, now here I'll be writing, okay, I will just take one new color so that it is like a different thing is made, that I'm just solving a question right now here. So here I'll be writing Z, okay. Now this Z is equal to Z of 0.025. Now how can I just say this? And this is equal to 1.96. Now basically how did I find it? How just I directly wrote that? Because here the confidence level is 95%. Because here I'm writing because confidence interval, okay, sorry, level, okay, confidence level is 95%. This thing we are given in the question, right? Just have a look again above in the question. I'm given that if we want to be 95% confident, right, 95%. So I'm just given that thing here. So from that I just found out directly that how to solve this, and you all know, right? Now what I'll be just doing here is that I'll be quickly applying the formula for finding out the n which we have studied, right? So n is equal to, and here I'll be writing z square sigma square, and it in the downwards it was EBM square, right? So I know the value for z square, I know the value for sigma square, even I know the value for EBM square, right? So for z right now we have just calculated, and that was 1.96 whole square, right? And secondly basically I know the value for sigma, and that is 15. So that would be 15 whole square, and the whole would be divided by EBM square, that is error bound mean square. So error bound I am having here as 2, so that will be 2 square. And the final answer which I'll be getting here after the calculation, so that would be 216.09. Okay, and we all know that how we had found. So we had found using the equation which we had said in the previous slide, right? So this is the value for finding out the n, like we had just found it out n. Now basically from here we can just conclude, and here we can just write that okay, here I'll be writing use n is equal to 217. Why? Because always we basically round off the answer to the upper value, okay? Whatever the next highest integer we are having, we just round off the value up to that. So here I'm just given 216.09, so I can just round it out of round off up to 217, right? So what conclusion can I just make from this thing which I just got here as an n value? What conclusion can I make here? So conclusion that I can say here is that I can say 217 foothill, and I will just write a college in short, okay? 217 foothill college students should be surveyed, okay? So it would be should be surveyed, VEYED, should be surveyed in order to be in order to be 95% confident, in order to be 95% confident that we are within 2 years, and I will just come down here, okay, that we are within 2 years of the true population mean age of foothill college students, Now, basically, this was the last writer which we all should write whenever we are just writing any, solving any question. So we should always make sure to write a habit that you need to write up the last write-up, that what conclusion you had just found out from this thing and what answer you had found out and all the things about that, okay? So I just simply wrote that thing here, that 217 Foothill College students should be surveyed in order to be 95% confident that we are within 2 years of the true population mean age of Foothill College students. Fine, and from here I just found out the value for my n, that is 217. The real value was 216.09. But I have simply rounded off that value so that I can just come to a proper integer value. And as we all know that we always round off the value up to the higher integer. Right, so that I have just done this thing here, right? So now I hope that you must be getting an idea, you must have an idea that how to solve the questions if you are just asked to find out the sample size, that is n, how to do that, and how to just rectify from the question that what actually you need to find out from here. Right, so this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically our today's topic of discussion is student T distribution. Now this is another topic which we are having in the statistics, right? Now in the previous topics for a long time we had actually discussed about the confidence interval, standard deviation, all those things we had just discussed, Z-score, right? Now we are starting out with a new topic for now, and that is student T distribution. Right, now basically what is it actually? Let me firstly explain you. After that I would just take on to you basically that where it is used. After that we'll be just discussing about the formulas and the other things. Right, so let me start writing here. So I would just tell you that basically for what it is used. Right, so I would just write here students T, and I would just in short form I would just write distribution. Okay, I'm just writing it in short form. So students T distribution is any member of a family, of continuous probability distribution, so here I'm just writing continuous, just let me come down here, okay, of continuous probability, and I will just write here probability distributions of continuous probability distribution that arise when basically we are calculating. Estimating means calculating, right? When estimating the mean of a normally distributed population, of a normally distributed population, right? So this is actually what is the definition for students T distribution, right? Just let me quickly write here population as well. And now I would just revise the definition once again so that you can just have an idea of this. Right. So basically here it is written that students T distribution is any member of a family of continuous probability distribution that arise when estimating the mean of a normally distributed population. So first thing that we can just say from here is that students T distribution, right? It is basically any member of a family of continuous probability distribution, right? And second condition that when basically what is the condition at which it arises? So the condition is that it arises when estimating the mean of a normally distribution population. Right, so this is the thing which we can just say about the students T distribution as an intro for it. Right, now second thing which I just want to tell you here, that basically how just we write that thing and how just we know it. right? So for that I would just take a new color here so that it is a little bit differentiable. Okay, so now basically here I start, and here I write if you basically. Now first thing is that if you draw a simple random sample, we all know that what is a random sample, right? So if you draw a simple random sample, right? For random samples we had already covered this thing in the previous video, right? So if we draw a simple random sample, let's say of size n, okay, I'm just taking at, let's say of size n, I'm simply taking a small n here, okay. Now basically from a population, right? So the random sample is always drawn from a population. So I'm just writing that thing here. Let's say if you draw a sample simple random sample of size n from a population that has approximately, I'm just simply writing approx here, okay, just treat it as approximately as well, that has approximately a normal distribution with the mean mu. We all know that basically we denote the mean with the mu, right? So here I would just write the correct spelling, distribution with mean mu. So I'm just writing it even a denotation here, which is basically important. So I would just write here mu, okay. And unknown population standard deviation, and that is basically denoted by the sigma, right? So here I've just write that thing also, and unknown. So for standard deviation, I'm simply writing here as ST, okay. No need to just write the full form because we're just learning this thing from the very starting, right? And unknown standard deviation, I'm just writing the denotation, that is sigma, fine. And basically now if I just want to calculate the t score, okay, and basically if comma calculate the t score. Now basically some of you must be thinking, now we have heard about the z score, now what is this actual t score? So just wait a while, just have a little patience. In this video only I'm just going to tell you that actually what is t score also, right? Just wait for 2 to 3 minutes for that. So calculate the t score, and with that basically I would just write out the formula here, that t is equal to, so that is x bar minus mu and divided by, and here I would just write s divided by under root of n. Right, so here whatever I have just written, it is like clear to all of you that basically what are the terms that I have written here, right? So so the formula is this, and basically now from here I would just put a comma, and I would just even write that then if this is the formula, then the t score, okay, the t score which we are actually talking about, then the t score follow our students t distribution, okay, follow our students and dash, and here I would just write t, and distribution, for distribution I would simply write this here, okay. So that is basically this t score is follows students t distribution, and with, now what is one condition here? That condition is that with n minus 1 degrees of freedom, okay, with n minus 1 degrees of freedom. Now for degrees of freedom also I would just let you know that thing in a while, okay, degrees of freedom. Now firstly let's discuss about that t score which I was talking in the starting. So just that t score, okay, which I have just written here. So t score has the same interpretation, okay, t score has the same interpretation as z score, So from here what I can just say is that the t score and the z score are actually same to each other, okay. Now basically there is no very much difference between them, right? So it is t score has the same interpretation as z score, right? So this is the thing. Now second thing that comes here, okay, just let me again just go down from here so that I can just write next thing. Now next thing that comes here is that basically what it measures. So it measures how far x bar is from its mean mu, okay. It basically measures that basically how far is x bar is from its mean mu, right? And what about the number that I have mentioned, that was n minus 1. So for that I would just write here the number. Now what the number n minus 1 is called as, it is basically is called as degree of freedom. It's called as degree of freedom, right? So this is basically what we have about the students T distribution. Now just let me quickly read it out and explain you each and everything. So basically, if you draw a simple random sample of size n from a population that has approximately a normal distribution with mean mu and unknown standard deviation sigma, then calculate the t-score. So this is the formula for the calculation of the t-score, okay? Then the t-score follows a student's t-distribution with n minus 1 degrees of freedom. Right, now if we are given, as I mentioned, that what is the condition on which this works. So basically if I draw a simple random sample, okay, let's say size for that is n, basically from a population. Now then that will basically have approximately a normal distribution, right? And the mean would be mu, and basically it will have some unknown standard deviation. So from that, if I just calculate out my t-score, so t is equal to x bar minus mu upon s upon under root of n. Right, now then the t-score which I have calculated will actually follow a student's t distribution, and that would be having n minus 1 degrees of freedom. Right, so this is the whole idea about what I have just written. After that, I have told about that what is a t-score. So t-score has the same interpretation as z-score there, okay? After that, basically what does it measure? So it measures how far x bar is from its mean mu, okay? And after that, the number n minus 1 is called as the degree of freedom. Right, so these are the things which I have here for the student's t distribution. After that, it has basically two important properties. Right, so I've just tried that two important properties here. So properties, I'm just talking about the students t-score, okay? Sorry, students t distribution, not about the t-score or anything else, okay? So just let me quickly put out the first property, and the first property is that the graph for the student's t distribution distribution is similar to the standard normal curve. Okay, just let me come down so that it's similar to the standard normal curve. Okay, so basically the graph which we plot with the help of a student's t distribution, okay, which we plot for it, it is basically similar to the standard normal curve, right, which we have basically here, okay? So this is the very first property for the student's t distribution, right? Now second property for the student's t distribution is that the mean for the students, here I would just again write that same term, students t. I will simply write this here, okay? Just 1 second, fine. Right, so the mean for the student's t distribution is 0. Now basically if we're just going to calculate the mean for the student's t distribution, so that will always be coming as 0 here, okay? And the distribution is symmetric about 0, okay? And the basically distribution which we'll be making, that will be symmetric about 0. Right, so these are the properties which we have for the student's t distribution. The first property is that the graph for the student's t distribution is similar to the standard normal curve, okay? And the second property is that the mean for the student's t distribution is 0 and the distribution is symmetric about 0, right? So basically I hope you must have got a clear idea that actually what is the student's t distribution, and basically what are the properties and what are other terms which we which we're having here, and what is the definition for this. Now after in the next videos, basically whenever we just see the examples for this, then it will be more clear to you that basically what we mean by student's t distribution, and basically so how to solve out the questions for that, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically in the previous video we had seen about the student state distribution, right? We had seen that basically what is this topic and what are the things that we have in the student state distribution. After that we had even seen two properties about the student state distribution. Now today we are going to see some further properties and even the notations for the student state distribution. Right, but before that, basically, let me just quickly give you a revision that what we had done in the previous video, so that you can just correlate with today's video also. Okay. So, student state distribution is any member of a family of continuous probability distribution that arise when estimating the mean of a normally distribution population. If you draw a simple random sample of size n from a population that has approx a normal distribution with mean mu and unknown standard deviation sigma, calculate t score. T is equal to x bar minus mu upon s upon under root of n. Right, so these were the things that we had discussed. And the first property that we had discussed was the graph for the student state distribution is similar to the standard normal curve, right? And the second property was that the mean for the student state distribution is 0 and the distribution is symmetric about 0. Now moving towards the third property of this student state distribution, I will just write here as third. Okay, let me write it with new color only because today we are starting a new video. Right, so basically now I'm just going to tell you about the shape of the student state distribution curve. Okay, so I would just write that the exact shape of the student's T, and I would just write here distribution as DIST. Okay, there's a short form, right? So the exact shape of the student state distribution depends on so basically what is the factor firstly on which it depends? So it depends on the degrees of freedom, right? As I have mentioned in the previous video, as today I'm even mentioning that it depends on the degrees of freedom. Let me just come down so that I can see and write properly. Right, so it is degrees of freedom. Right, now I'm just going to tell you that what if the degree of freedom increases, then what is the effect on the student state distribution graph and all that things. Okay, so I would just write here that as the degrees of freedom, I'm just going to talk about this degrees of freedom, right? So as the degrees of freedom increases, okay, as this value actually increases, the graph, okay, the graph basically which we are making for the student state distribution, so the graph becomes more, let me even come down, the graph becomes more like the graph of standard normal, like the graph of standard normal, and okay, this is O, okay, make sure standard normal distribution, right? So basically what I've just told here is about the degrees of freedom, right? Okay, just give me 1 second right here. So basically if the exact shape of the student state distribution depends on the degrees of freedom, and it basically correlates as the degrees of freedom increases, the graph becomes more like the graph of a standard normal distribution. Now we all know that basically how the standard normal distribution graph look like, right? We had already seen these things in the previous video, so I'm just not going to repeat this thing today. Okay, I hope you have basically seen out the previous videos as well. Now this was the third property which we have discussed right now. Moving towards the fourth property, what I could say here is that I would start writing about the student state distribution. Okay, student state distribution has more probability. Okay, has more probability. I would simply write PROB. Okay, so student state distribution has more probability in its tails. Okay, okay, than the standard normal distribution. Now basically you had a look over this and in the previous video and today as well, that basically we are somewhat comparing that things for the student state distribution with the standard normal distribution, right? So we just write here than the standard normal, and here we just add a distribution, right? Standard normal distribution. Now, basically, what is the reason that it has a more probability in tails? What is the reason for that? So I would just write here because the spread, okay, because the spread of students, let me come down this side. Okay, the spelling for spread is wrong. Just make that correct on your side. Okay, SPREAD. Make it SPREAD. So because the spread of students T distribution. Okay, students T distribution is greater than the spread of spread of standard normal distribution. Right? So this is the reason that basically, let me just like hold on the cursor. So this is the reason that the student's T distribution has more probability in its tails than the standard normal distribution, because the spread of student's T distribution is greater than the spread of SPREAD, spread of standard normal distribution. Right. So these are the four properties that we have here. Now moving towards the next thing which we can say is how to denote all these things, right? Basically, what is the notation for a student's T distribution and all those things, right? Let's discuss that thing. So here I would just add on that the notation for the students T distribution. Okay, so the notation for the students T distribution is, and in the bracket I would just write here that using, now basically I'm just using that T as a random variable. Okay, using T as the random variable. Okay, I'm just using this T as a random variable here. Okay, so the notation for the student T distribution is, okay, let me just change out the color here so that I can just differentiate the things a little bit. So the notation is basically, we just simply write T. Now this is basically what I'm just treating it here. I'm treating it as a random variable. So T basically belongs to small t and df. Okay, this is one. This is a denotation. And where basically df is equal to n minus 1, and that n minus 1 is actually the degrees of freedom, which we were talking in the previous video, which was related to the student T distribution. Right? Now, let's have a quick example for this thing. So I would just write here as example. Now let's see if I have, okay, I will just write here this thing. If we have a sample of size n is equal to 20. Let's say I have a sample of size n is equal to 20 items. Let's say, okay, this is the example which I have taken. Then basically, we calculate the degrees of freedom. Then we calculate the degrees of freedom. Let me just come down this side. Then we calculate the degrees of freedom as, now what is the formula that we use? So I had already mentioned that df is equal to, okay, let me just make that df clearly, as I will just put this here, and that is df is equal to n minus 1. Right, now what is this actually n here? This n is actually 20 minus 1, and that will be resulting me here as the answer, which is 19, right? And basically, and we write the distribution. Now distribution, I am just writing that distribution. Okay, now basically I just told you the denotation for the distribution, right? And we write the distribution as T, capital T basically belongs to small t, and here as 19, right? This is small t and 19 is basically the denotation for my student's T distribution that I just right now told you, right? So this is basically how we just denote the student's T distribution. Let me just give you a quick overview over this. So I had taken an example that if let's say we have a sample of size, basically n is equal to 20. Let's say I'm just given this, okay? I'm just given any size, and if someone comes and asks me to calculate the degrees of freedom, right? If someone asks me to calculate the degrees of freedom, so in that case basically here what I can just apply the formula is, I can apply the formula that is df is equal to n minus 1, right? Df is equal to n minus 1, and n basically I am having here as 20, right? So that 20 minus 1 is resulting with the answer as 19. Now right now above here, just let me hold the cursor here. Above basically I told you the denotion, right? Where it has gone, yeah, here I just told you the denotion for the students T distribution, right? Let me just highlight this thing so that you can even like remember that afterwards also, this thing. And this was finding the degrees of freedom, right? So basically as I just mentioned that, okay, just one second, let me take the pen here. Okay, as I mentioned about the like thing that basically how to denote that. Okay, so that thing can be done here, which I had just written, and we write the distribution T basically belongs to small t and 19. Right. So this is basically what we had studied about the student distribution. So it is any member of a family of a continuous probability distribution that arises when estimating the mean of a normally distribution population. Okay, this is the first thing. After that, if I draw a random sample of size n from a population that has approx a normal distribution, just one second, um, right, which has basically a normal distribution with mean mu and unknown standard deviation, then we calculate the t score, which is t is equal to x bar minus mu upon s upon under root of n. Then the t score follow a student's t distribution with n minus 1 degrees of freedom, right? So t score has basically same interpretation as the z score, and it measures how far x bar is from its mean mu. The number n minus 1 is called as degree of freedom, right? So these were some things which we had already discussed regarding the student state distribution in the previous video, and here are the properties that the graph for the student state distribution is similar to the standard normal curve, and the second is that the mean for the student state distribution is 0 and the distribution is symmetric about 0. And this is basically, if you just get a simple question, so this is basically how you will be solving that simple question, that if you are given a sample size and if someone asks you to find out the degrees of freedom. So you'll be simply applying df is equal to n minus 1, n would be the size of your like sample which you have got, and you simply subtract 1 from that side. Right. So basically I hope that you have a fair and a clear idea that basically how to solve these types of questions and what to apply, what are the properties, and even what is student state distribution. Right. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically in the previous video we had discussed about the student state distribution, right? We had seen that what is student state distribution, what are the properties onto that, and basically many things we had seen. Let me quickly give you a quick revision of the same which we had discussed in the previous video. So here we are. So we had discussed about that the student state distribution is any number basically it is any member of a family of continuous probability distribution that arise when estimating the mean of a normally distribution population. Right, this was the thing that I told you regarding the student state distribution. After that we had discussed several things about it, and the properties which we had discussed was a graph of the student state distribution is similar to the standard normal curve. Right, second property was the mean for the student state distribution is 0 and the distribution is symmetric about 0. And even we had discussed about the shape of the graph for the student state distribution, right? So these were the things that we had discussed today. Now today basically we'll be dealing with one question, we'll be seeing one question regarding the same. Okay, so here is my question that I have. Fine. So my question says, to just read out this question very carefully, okay? It says me to suppose you do a study of acupuncture to determine how effective it is in relieving pain, okay? You measure sensory rates for 15 subjects with the results given below. Use the sample data to construct a 95% confidence interval for the mean sensory rate for the population from which you took the data. So this is the data downside which we are given for the values. This is the data, okay? Now basically it is asking me to use the sample data and construct a 95% confidence interval for the mean sensory rate for the population from which you look the data. Now basically what it is actually firstly asking me to solve out. So I will just write here as, okay, so let me close it. I will just write here as solution. Okay, solution. It is basically asking me I will just write that thing even here as well. It is asking me to find the CI, that is confidence interval. So for finding out the confidence interval, what will be you will be needing basically? So I would just write here, you need the you basically need the sample mean and the error bound mean, right? So for finding out the confidence interval, we need the sample mean and EBM. We had already studied about the confidence interval in very detail in the previous videos, right? So I'm just not going to repeat that what it is actually. So I'm just letting you know that for finding out the confidence interval, you actually need out to basically find out the sample mean and the error bound mean, that is EBM. Right. So now if I just ask you to find out the sample mean for this data, so I'm just gonna not going to show you that thing manually, that how to do that, because it is very much clear to you, and we had done this thing like I just say that we can just done this thing in each and every video of the questions. Right. So I would just find out the X bar, and that will actually come out to be 8.2267. Right. Just find that on your own and just verify it using here. Right. That I have done. So after this, basically what I can just say, S is equal to 1.6722. Okay, and what about the N I have? N I have the value as 15, right? So these are the three things which I can find out from the data which I am given here, right? Now basically what I can just write here, we have discussed about the student state distribution, that is it is DF, right? DF is equal to, and that is N minus 1, right? This N minus 1. So N I am having the value as 15 and minus 1. So here I'm just getting the answer to be 14, right? That I have done. After that, what I just want to find out is that, okay, I need to find out the confidence interval, 95% confidence interval. So basically from here, I can just say that the confidence level is 0.95. I just need to find out the 95%, right? So what for basically converting that, I can just say out that is confidence level is 0.95, right? That I have done here. After that, basically, I would just write, so basically, so alpha is equal to 1 minus CL. This is the formula which we had studied previously, right? We had already seen about this thing, that alpha is equal to 1 minus CL. This CL is basically my confidence level, right? So that would be, I would subtracting be here. So that is 1 minus 0.95, okay? So the subtraction I would be getting here as 0.05. So that is the value for alpha which I am having here, right? Now if we just want to find out alpha by 2, so what I would be just doing, so alpha value is 0.05. I would just divide it by 2. So after that, I'll be getting the answer as 0.025, let's say. Okay, this is the output that I would be getting here. Fine, right? And what we can even just find out from this alpha, so I can just write off G is equal to T alpha by 2, right? And that I can just give a value as 0.25, value like this, right? That is okay. Okay, just let me close it. Fine. These are the things which I can have from this data, right? Now, what I can just say from here is that, okay, I can just say that the area to the area to the right of T of 0.025. Okay, just let me correct it if I have written. Okay, this point will not come here. Let me just quickly take out the eraser here and let me just erase this thing. And now again, let me quickly take out the red color from here. Right, and it is basically, it is 0.025. Okay, it is 0.025. Just take that. So the area to the right of T 0.025 is, that is 0.025, that we had find it out right now. Okay, and I would just write that, and the area to the left of T of 0.025 is, and for that what I would just do is that I would subtract 1 minus 0.025, okay, and that will basically result me the output as 0.975, right? This is the thing that I have just got out here, and I would just close it here. Let me come down even, right? After this, what I can just do here is that I can even take that T of alpha by 2 is equal to T of 0.025, right? This was the value, and that is equal to 2.14. Now you can just this thing calculate on your own. I'm just not going to tell you because we had already discussed this thing in a previous video. That is why always I recommend the videos to watch in a proper manner, because the questions which we are going to solve today and even in the further videos also, they will always contain some a previous concept as well. Okay, so always make sure to revise the previous concept and even just watch out all the videos in a proper manner. Right, now from here, if I just want to find out the error bound mean, so what is the formula for finding out? That is T of alpha by 2 and multiplication S upon under root of n. Right, this is the formula which we have for finding out the error bound mean. Right, so I have all the values now with me. Now basically I have all the values. Right, let me just come down here. Even let me start writing. So EBM is equal to, here I will just write EBM is equal to 2.14. For 2.14 I have the value, and I would just put one multiplication sign, and the value for S I was having 1.6722. Okay, and I would just having under root of n. So under root of n value, that was my sample size, that was 15 for me, right? So after calculating all of these things, whichever like we have written here, after the calculation of this, you are gonna get the answer as 0.924, right? You can just find out the answer and verify it from your side. So here if I just want to find out x bar minus EBM, if I just want to find out this thing, so I could just write 8.2267. This was x bar, right? The mean which we have found it above. Let me quickly go above and show you, right? You just have a look here, that is x bar. Okay, so that I have already found it. So x bar minus EBM, so just 8 minus 2267 minus, and right now I just found out my EBM, that is 0.924. Right, so after the subtraction, you'll be getting the answer as 7.3. And if I just find out the x bar plus EBM, because the EBM is of the form x bar minus EBM, x bar plus EBM, right? So if I just do that thing, so again I would just write 8.2267, and instead of the minus sign, just put here plus, and the value will be same, that is 0.924. So here I would be getting the answer as 9.15. Okay, this is the answer that I would be getting. So what I can just see from here is that I can see the 95%, I can see the 95% confidence, the 95% confidence interval, I can see the 95% confidence interval is, and the values that I have got right now, it is 7.3, 9.15. So the confidence interval is x minus EBM plus x, x plus EBM, right? This is the form in which you just find out the confidence interval. So here I have just found it out that, so x minus EBM is 7.3 and x plus EBM is 9.15. So I just got that. So if I just want to write out the final estimation for this thing, so what I can just add here is that we estimate with 95%, we estimate with 95% confidence, and I would just come down here, we estimate with 95% confidence that the true population, mean sensory rate. This was the thing that was asked in the question. Okay, sensory rate is between 7.3 and 9.15, right? This is the final estimation which I can just add on here, write up, that we estimate with 95% confidence that the true population mean sensory rate is between 7.3 and 9.15. And this was the thing that we were asked to solve here, right? That means what we need to do is that we need to use the sample data to construct a 95% confidence interval for the mean sensory rate for the population, right? This was the thing that we need to do. So firstly, we had quickly find out the mean. After that, we had found out the S and then the N. Right, after that, I simply found out the DF. So from that, I can just find out the confidence interval. And for after the confidence interval, I can find out the alpha value, that is alpha is equal to 1 minus CL. So after finding the value for alpha, I can just write it as alpha by 2, and there I can just find the value for T. So the area to the right of T 0.025 is 0.025, and the area to the left of T of 0.025 is 1 minus and is 0.025, that is basically 0.975. After that, I just found that after that it was my last job to find out the EBM, that is my error bound mean. So I can just write T of alpha by 2 multiplication S upon under root of n. This is the formula that we actually follow for finding out the EBM, right? So I just done that thing. After that, I even needed to find out the confidence interval. So my main motive was to find out the confidence interval, right? So I have just done that thing. Here I have found out the confidence interval, that is x bar minus EBM, x plus EBM. And here I simply write out the last writer, which is we estimate with 95% confidence that the true population mean sensory rate is between 7.3 and 9.15. Right? So I hope this must be very clear to you that how you can just like solve a question using the student state distribution and the confidence interval and the EBM concept. Right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically now today we are going to discuss about the confidence interval for a population proportion. Now this is a new topic which we are going to start today. So let me quickly give you an overview that what we had discussed previously. So even in the previous video we had seen about the student distribution. This was a topic that we had taken, right? And we had seen one example for this question. So for today's topic, let me just quickly take out the black color and let me start writing the topic for now. And okay. And that topic is basically confidence. So it is confidence interval for a population proportion, for a population, and after this population it's proportion. Right, so I would just request you all even to just note down this on your notebooks or whatever you're just making your notes. So confidence interval for a population proportion. Now in this topic, basically, first of all, I would let you know that how to guess that let's say you have got a question to deal with, right? You have just got a question to solve now. Now I would just let you know very first thing that how will you recognize that okay you are dealing with a proportion problem. Proportion problem in the sense that this population proportion. Right, I would tell you this thing that basically how would you get to know that okay you are dealing with a proportion problem and now how you just need to proceed further, right? This is the idea that we are gonna discuss today in today's video, the real idea. Fine, so I would just come down here. Let me just quickly take one another color and let me start writing the topic for now. Okay, so the topic for now that we are going to discuss is that how do you know you are dealing with a proportion problem that I just told you right now, okay, that you are dealing with a proportion. So basically there are some things that we need to have a look upon, and if that things are present or that things are not present, some things like that, so then from that we can just add on here and say that okay it is a proportion problem. Okay, so there are some criteria on which it is basically based. Now let me tell you that how and what are the criteria on which it is based. So moving towards the very first thing, that first of all what you need to check about is that I would just write that thing even here. First, you need to check the underlying distribution is binomial or not. The basically distribution that you had taken. So I would just take here as I would just let it be as underlying. Okay, let me just write this word here. First, the underlying distribution is, so I would just write here distribution is binomial. First thing you need to just check is this thing. The underlying distribution is binomial. Okay, now basically here no need to just worry about and mention about the mean and average and all that things. The thing is that you need to check that the distribution that you have taken, that is binomial, right? Now if this is the thing, then after this what you need to do is that you need to say that if capital X, let's say X is random variable, okay, let it be like that only. So let's say if X is a binomial random variable, as I mentioned that it is a random variable, so I would just add here binomial as well, because firstly we had checked the distribution is that binomial or not, right? So if X is a, I would just write binomial random variable, then basically what we can just say from here, what are the things that we can add on, what are the representation that we can give. So for that I can just write down here that then x approximately equal to, so approximately equal to sign, and this x is basically my binomial random variable which I had just mentioned right now. So then x is approximately equal to capital B, and that is capital B is referring to my binomial, okay, and in the bracket it would be n comma p. So n comma p is a particular range which you can just say, okay, it's a particular range, fine. So basically these are the things which you have to keep in mind. It is not over it. Basically we have more things to add on here, but right now I just understood that firstly you need to check out the distribution is binomial. After that you need to find out the random binomial variable for that. Okay, that is done till now. Now basically here I'm just going to let you know that what actually n means and what actually p means. So I will just put one comma and I will just write here where n is equal to number of trials. We remember that this binomial thing is in the trials as well, okay? We just apply it in the probability terms, right? So n is equal to number of trials. And what about p? So I would just, okay, I would just put one, I will just put one and here. And what is actually this p? So this p is the probability. I will just simply write prob instead of probability, okay? I'm just using the short form. So the probability of a success, okay, SUCCESS. So these are the terms which we have here, that where n is equal to number of trials and p is equal to the probability of a success, right? So as I mentioned, x is approximately equal to capital B, and into that B I have put two terms in the bracket that were n and p. So n is basically referring to the number of trials which we have here, and p is basically referring to the probability of a success, right? Now basically to form a proportion what we need to do is that, okay, so I would just write here to form a proportion. Proportion is basically that thing which I just mentioned above, right? To form a proportion, what we need to do is that firstly we need to take x, capital X, the random variable. What is this x actually? Now this is the random variable, variable. Now for what is this a random variable? So the random variable for the success, for you can just say for the number of successes, the random variable for the number of successes, okay, yes, SUCCESS, that is ES, right? So x is the random variable for the number of success. Let me come down first of all and let me just get some space for me. Okay, the number of successes, and what we need to do is that we need to divide it, and basically I need to divide it by n. Okay, I just need to divide it by n, right? So this is the thing that I can just have it from here. So basically take x as a random variable for the number of successes and divide it by n. These are the things which come here actually, okay? Now let me again come down and add on some more things here. Okay, now what is basically n, that I already told you. Again I'm just repeating, that is the number of trials. So I would just write here the number of trials, okay? I just again repeat that. So it is n is the number of trials, and what about the random variable? So I would just add on here the random variable, p dash, we just call it as dash, okay? P dash is that proportion. Okay, so when you're just going to find the proportion, so in that case basically we represent that as p dash, okay? So the random variable p dash is that proportion which you are going to find out, right? So I hope I'd been very clear to you about all the things which I mentioned. Let me just quickly go above and give a quick revision of the things that I have written here. So the very first thing is that you need to check out that whether the distribution is binomial. Okay, if yes, then what you need to do is that you need to take a binomial random variable, let's say x, okay, and then basically that x would be approximately equal to b, and in bracket it would be n comma p. Now what are these n and p? So n is basically the number of trials and p is basically the probability of success. Now if you want to form a proportion, okay, let's say you want to form proportion, then basically take x. Now x is that random variable for the number of successes, okay, and divide that number by n, okay, And what is that n? N is basically the number of trials, and then the random variable p dash is the proportion. Right? I hope I just made this thing very clear to you regarding that how you can know that basically you are dealing with a proportion problem. Right? Now, what next comes here is that I will be telling you one formula here, that is p dash. P dash was my proportion, right? With that a random variable for the proportion. So p dash is equal to capital X upon n. Okay? So basically what is this capital X refers to? I would just write that thing here. So capital X is my binomial, that is my binomial random, I would just add on there binomial random variable, right? We had just seen this thing above as well. And what about this small n that I have? So this small is n is basically the number of trials for me, right? That even we had seen. So I will just add on that thing here, the number of, and it is basically the trials. Right? Now, what can I just say one more thing from here? That basically, let's say I had written here p dash, right? Now, this p dash is basically sometimes denoted by p hat. Let me show you that how we just write. Okay, let me take one different color here, and I would just go on for, let's say, this one. So I would just write the thing here that sometimes random variable that is like this, sometimes random variable is denoted by p hat small, that is my capital P that we had already taken, and this cap sign. Okay, we just even sometimes use this in vector as well, right? I cap, j cap, k cap. So this is same cap which I had put here. We can even just call it as p hat also, or you can just call it as p cap also. Right? So basically these are some things for that we have for this, basically how you'll be checking out that it is a proportion problem or not. Now we had several conditions and several criteria in this, and basically we had several formulas also. So that all we'll be discussing in the next video. Right? So for now I have mentioned about how we'll be checking this thing, and even I had mentioned one formula, that is p dash is equal to x upon n, and where basically that x is my binomial random variable and n is basically the number of trials, and sometimes basically this p dash is even represented as p and then hat. Right? So I hope I just made this thing very clear to you regarding the proportion problems. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So even in the previous video we had seen regarding that basically about the confidence interval for a population proportion. Right? This was a topic that we had seen in the previous video, and we had discussed about a lot in that. Now, even I had told you about how do you know that you are dealing with a proportion problem. So I told you several criteria. From that you can just say that okay, you are dealing with a proportion problem or you are not dealing with a proportion problem, right? That thing I have previously mentioned. Now, today I have some more cases here. Now, I have defined here p dash, and basically that was equal to x upon n, right? X was basically my binomial random variable and n was the number of trials. Now, I have several conditions that if the value for n is large, p is small, and all those things I have, right? So now that I will be discussing that with you. So for that, let me just quickly choose one different color and let's begin up with the topic for you. So I have a condition here that when n is large, basically the value that is n is basically my number of trials. Let me just go above and show you this thing. Here I have written even in the previous video that n is equal to the number of trials, right? So when the value for n is large, okay, if I am having the value for n is large, and my second condition which applies to the same one is that, and p is small p, okay, I have written this, and p is not close to, and p is not close to 0 or 1. So p was basically my success, right? Let me show you that thing where I have just added on. Yeah, p was my probability of a success. Just have a look over this line which I have underlined. Okay, so p was my probability of success. So now my condition is that if the value for n is large and p, that is my probability for a success, is not close to 0 or 1, then what we can use, what formula to use in that case? Okay, just one second. Right here. So I would just write here that we can use the normal distribution. We can use the normal distribution to approximate the binomial. Okay, we can basically use the normal distribution to approximate. I would just write approximate here, to approximate the binomial, right? That is, here we have taken as p dash. Fine. So if this is condition that basically the value for n is large and even the value for p is not close to 0 or 1, then what you can do is that you can use a normal distribution to approximate the binomial, right? Now for that, what formula can I just have a look over that? So x is basically approximately equal to n, and in the bracket it would be n multiplied by p. This is dot, that is multiplication sign. I hope you all know, right? And even I just put one comma sign and come under root n dot p dot q, and I would just put the bracket. Fine. So this is the formula which I can apply here when I basically have the conditions which I just mentioned right now. Okay. Now next thing that comes here is that now I have even some more formulas to apply here. Conditions. Now, if we, second thing, that if I basically, let's say if we, okay, if we divide the random variable by n, okay, basically what I do, if we divide the random variable, okay, the random variable that we have, if I divide it by n, then basically what we have, random variable here is my capital X, right, that we have taken. So X basically approximately equal to n. So that X which I have just taken here, it is my random variable, right? So if we divide the random variable by n, okay, the mean by n, the mean which we have taken, the mean by n, mean is my n dot p, right, the mean by n, and the standard deviation by n, and the I would just simply write here as SD, not too much large name. So I will just write here SD and the standard deviation by n. So standard deviation is under root n dot p dot q. Right? So if I divide the random variable n, the mean n, and the standard deviation by n, okay, then basically what we get. So I can just write here that we get a normal distribution. We get, I would just add here, we get a normal, and let me come down so that I can just even write it properly. So we get a normal distribution. Okay, we get a normal distribution of proportion, I would just write that thing here, of proportion with p dash. P dash we had taken as a variable, right, that we had taken previously. Same is continuing here as well. So we get a normal distribution of proportion with p dash, and which is basically what it is called. It is called the estimated, proportion. It is called the estimated proportion as the random variable, as a random variable, right? I would just add this thing like this. Fine. So this is basically what I just get from here. Fine. Now, applying all the things onto the formula, what I will be just getting is that, so I wrote that I would be dividing the capital X, that is my random variable, by n. So I have done that thing, right? Now, after that, next what I have here, I will be putting that equal to sign, p dash is approximately equal to n, and I had said that I'll be dividing mean by n. So n dot p is my mean, right? I would divide it by n. After that, what I have, I'll be dividing my standard deviation, that is n dot p dot q. I'm dividing it by n. So I've applied that thing as well, right? So if you just simplify it using algebra here, so after simplification, what you'll be getting as the output is that under root of n dot p dot q divided by n is equal to under root of p dot q divided by n, right? This is the formula that you will be getting here after applying the simplification for the algebra process, right? Come to the next line, come down a little bit. So basically here the p dash, okay, p dash follows a normal distribution now, okay? P dash follows a normal distribution. P dash follows a normal distribution for the proportion, right? For proportion. So it's like this. And what is that formula which I can just write down here? So from the simplification and all the algebra process that I have done. So it is basically P dash is approximately equal to N. In the bracket it is P, comma, and here I can just put the under root of sign and I can just write down P dot Q divided by N. Right, this is the formula which just came after the simplification of all the above things which I have written. Right, now here basically what is the form of the confidence interval? So okay, so here I would be writing that confidence interval has a form. What is the form of that confidence interval? Let me just come down and write down that thing here. So it is basically P dash minus EBP. Okay, EBP is my error bound for proportion. Okay, just make sure to remember this full form, that EBP is my error bound proportion. So P dash minus EBP, comma, P dash plus EBP, right? These are the confidence interval of the form of the confidence interval. Right, now from here you know that what is P dash. Okay, so P dash is basically x by n. So from here that P dash is actually the estimated proportion. I would just add on this thing here. I would just write the estimated proportion. Okay, the estimated proportion of successes. I would just write that thing here, double S. Fine. So P dash is the estimated proportion of success. X is basically what is now the X here which I have defined in new term. So X is basically the number of success. Okay. So it is basically the number of successes. And what about the N, the number which I have taken? So N is basically the size of my sample, as we had just this thing previously, right? The size of sample, let's say. Okay, so these are the three terms which I mentioned here, and these are the meanings that P dash is basically the estimated proportion of success, X is basically the number of success, and N is basically the size of sample. After this, basically now what is the error bound for a proportion? Right now I've just mentioned EBP. Now if I just have to find that EBP, then what do I have? So for finding out that EBP, so I would just write that the error, okay, let me write that E as capital here. So that is the error bound proportion. Okay, error bound proportion, right, like this, right? So the error bound proportion is, the formula for that is basically EBP is equal to small z, that is alpha by 2. Small z, that same thing which we had seen in the previous things, right? Same thing. Put a multiplication sign, then under root of P dash minus Q dash. This is Q, okay? Make sure P dash minus Q dash upon N. So basically what is the value for Q dash? So Q dash is 1 minus P dash. So if you just want to find out the Q dash value, so you'll be like subtracting the value for P dash from 1. Right. So this is actually what we have as the error bound proportion here. Right. So these are some few conditions and some few formulas. Let me now just put on the things once again here in a brief way. So basically if we have the value for N as large and P is basically not close to 0 or 1, the values are 0 or 1, then what we can use a normal distribution to approximate the binomial, and the formula for that is mentioned here. Let me quickly take out one highlighter so that I can just highlight the main formulas, because here I have mentioned too many formulas, right? So this one is the main one. So now if we divide the random variable by n, mean by n, and the standard deviation by n, so we get a normal distribution of proportion with P dash, and which is basically called my estimated proportion as a random variable. Right, so this one is the thing which I have just said right now, that if I divide the mean, the standard deviation and the x by n, so this is basically what I just mentioned right now. Now if I basically simplify all of these things, and if I just come to a final place, so this is the final output, final formula which I can just say from here, that this is the one which I can just find out using finding the some simplification and all those things. Right. Now basically what is the form for the confidence interval which we have here? So in this basically we have P dash minus EBP and P dash plus EBP. So EBP is basically my error bound for the proportion. And what is the value for p dash? How will be finding that? So that is x divided by n. Now here basically what is x? So okay, first deal with the p dash. So basically p dash is my estimated proportion of success. Okay, x is basically the number of success and n is basically the size of the sample which we have here, right? And after that finally the formula for the error bound proportion is EBP is equal to Z divide alpha by 2 multiplication P dash by Q dash, sorry, P dash multiplied by subtract Q dash and divided by N, right? And how to find out that Q dash? So finding out that Q dash, what you can just do is that you can subtract P dash minus 1, right? So I hope that you have got a clear and a fair idea regarding all the formulas which we have here in this confidence interval for the proportions, right? So here we have the confidence interval for the population proportion. So all the formulas are clearly mentioned and all the conditions are clearly mentioned. Now in the next video we'll be seeing one example regarding the same so that you can have a better idea of the topic, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now today basically we are going to discuss a question on the topic which we had seen previously, and that was confidence interval for proportions, right? For population proportions, right? This was the topic that we have discussed previously. So now today we are going to solve one question on this thing. So let me just quickly take a pen and okay, let me quickly take a pen and let's begin up with the things. Fine. So this is my, okay, just 1 second. Let me just come down, right. So this is my question which I have here, that suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones, right. So 500 randomly selected adult residents in the city are surveyed to determine whether they have cell phones. Of the 500 people surveyed, 421 responded yes, they own cell phones. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of adults residents of the city who have cell phones. Right, so this is the question that we are actually having here, and let's begin up solving the question, right? So I hope by the time even you have paused your video and read the question by your side also. Let's begin up with the answer. So first of all, I would simply take a variable, let's say x. Okay, let's say x is equal to the number of people, let's say x is equal to the number of people in the sample, I would just add here in the sample who have cell phones, right? Let's say, okay, I would just add on here as phones, right? Let's say this is the thing that I can say here, that let's take a x as a variable and that is equal to the number of people in the sample who have cell phones, right? So here I can just say that x is binomial. I can just come down here, I can just add on that x is binomial, and from this what I can just add on that x approximately equal to capital B, and into the brackets it is 500 comma 421 upon 500. Now what is this 500, 421 and all these things? So this 500 is actually my n and this 421 is actually my x. Now what is the n and x? What are all of these things? So n was basically, remember we had discussed this thing in the previous video. So n was basically the total sample that we have, right? The size for the sample. And okay, let me just take you to that previous slide as well where we have discussed. Let me show you at that place only, it will be more clear to you, right? So see, so we just have a look that what was x? X was the number of successes, right? This was the number of successes which we have, that is x. And moving to the n is basically the size of the sample. So that same thing we have taken here in this question. Let me show you that thing here, that I had taken the value for x and n. Let me go to the question here. Have a look that 500 randomly selected. This means that this is n, and right over that 421 responded yes. Responded yes means that it is a success, right? So I just mentioned that 421 here as well, right? Let's take a different color and let's start solving the question for now. So basically, now what I need to do is that I need to calculate the confidence interval, right? So I would just add that thing here to calculate the confidence interval, that is C. I am just simply writing a short form, let's not write that whole name here. Okay, so to calculate the CI, what you need to do is that you must find, what I need to do is that I need to find out P dash, I need to find out the Q dash, and even I need to find out error bound for the proportions, that is EBP, right? So I have the value for N. So the value for N I have as 500, right? I have that value in my question as well. It was given. After that, what do I have? I even have the value for X. So what is X actually? X is the number of successes, right? That we had even discussed right now. Just writing that as well. Okay, a successes, that is ES. And what is the value for that? So value for that was 421. This was the given value which we have in the question. Right, so we have N and X. So from this we can first of all find P dash. I had already mentioned that how to find P dash in the previous video. So P dash was basically X divided by N. Right, I have both of the values, that is 421 divided by 500. So the answer that I am going to get here after the dividing is basically 0.482. Just do that on your side, okay? Just do a simple dividend, devise this division on your side and get out the answer. Fine, that I have just find it out. Now, as I have find it out the P dash. So from this P dash, what I can just find out? I can find out the Q dash. So Q dash is basically equal to 1 minus of P dash, right? This was the formula that we had seen in a previous video, correct? So now what I would just do is that I would just write that P dash is equal to 0.842. Okay, and what is this? And this is the sample proportion. And this is the basically the value which I have just got it out here. That is sample proportion. Okay, and what is this? This is the point estimate of the population proportion, right? That I have just got it out. So I would just even write that thing also, that this is the point estimate, this is the point estimate of the population proportion of the population. I would just simply write pop and a dot, that is basically referring to a population. Okay, just mean that only. And here it is the population proportion, right? So if I just want to find out the value for X dash right now, so what I will be doing is that I will be writing here X dash is equal to 1 minus of P dash, right? And the value for P dash is equally, so I would just write 1 minus, and P dash value is 0.842, right? And after the subtraction of these values, I'll be getting here 0.152, right? Do that subtraction on your side. Fine. So that is just done here. That is 0.152, right? Now, I had just got out the value here, that is 0.152. Now, what I can just say from here? So, I can just write since confidence level, that is CL, that is 0.95. Now, how can I just say this thing? How can I just write that directly? So, just if you have read out the question very carefully, you have got out the answer that here I was mentioned that using a 95% confidence level. Remember? So, from that portion, from that side only, I just refer that CL is equal to 0.95. Okay. Then from that place, I can just find out the value for alpha. So alpha is basically 1 minus of CL, right? We had even seen this thing in the confidence interval part, right? So 1 minus and 0.95, and that will basically result me as 0.0. That will basically result me in 0.05, right? Now what I just need to do is that I need to find out alpha by 2. So alpha by 2 is basically equal to 0.025. This is the value that I can just get from here, right? And from that, if I just want to find out Z alpha by 2, so I can just say that Z of 0.025, and that is equal to 1.96, right? This is the values which I can just find it out from here, and I can just get that values. Okay, fine. Now what I need to find out is that I need to find out my EBP, that is my error bound for the proportion, because there were three things which we need to find out for the confidence interval. That was P dash, Q dash, and the EBP. So we had find out the P dash till now, we had find out the Q dash till now. The thing that is left is now EBP, right? Let's find out that thing. So the formula is the divide and the dividing. It is basically alpha by 2, right? Now, what I just need to do is that I need to put a multiplication sign, and under root, what I need to do is that I need to write P dash minus Q dash, and that is divided by N. Right? So value for P dash minus Q dash divided by N. So if I just put out all the values here, so it is 1.96, and which is multiplication with the here multiplication sign, that is okay, just remove that dot. I would not put it like this, right? And here I would just put the value, that is 0.84 multiplication 0.158. Okay, and down the line I would just write here the value for that, and that is 500. Let me just go above and like show you. So here have a look, that this is the value for P dash that we had found, 0.842, right? And this was the value for Q dash which we had find out, that was 0.152. Okay, so multiplication of both of these, and okay, that is 15. Just one second, let me just find out the value for the, that is 0.842, and here okay, it is fine, so 0.158. Now what I would just do here is that I would do the multiplication, division, all those things, and I would simply get the 0.032, right? That answer which I had just got out here. Come down. Now what I need to find out is that I need to find out the form. I need to find out the form for the confidence interval. And that was, first one was applied as P dash minus EBP, right? Remember? P dash minus EBP. So here I have the answer as 0.842, that subtract with 0.032. And the final answer that I'm going to get here is 0.81. Right? Same thing, I would just apply with the help of plus sign, and that is P dash plus EBP. So that is 0.842 plus 0.032, and after that the addition of both of these will result me as 0.874, right? So we had finded out all of the values which we actually need for finding out the confidence interval, right? So I can just come down now once again, and I can just start writing here that confidence interval, that is Ci of true of, okay, just let me write out the correct spelling for true, of true binomial population, of true binomial population proportion, is, okay, so confidence interval of true binomial population proportion is, so from here I can just mention that form which I had just right now find it out, that is P dash minus EBP, and put a comma sign and add on here that P dash plus EBP, right? So I have both of the values, that is 0.81 and 0.874. So I would just write on that thing here in the next line, that is 0.81 comma 0.874, and this is the form which I have here for the confidence interval. Now my very final statement for this question is that I would even I just told you previously also, I would just write that item again, if repeating. Let me come down first of all so that I can write it properly. Fine. So we estimate with 95%, we estimate with 95% confidence. Okay, we estimate with 95% confidence that between 81% and 87.4% of all adult resident of this city have cell phones, right? How could I just say this thing 81% and 87.4%? So just have a look here, where I had just find out the form, that is 0.81 comma 0.874. So from here I can just say that it is 81% and 87.4%. So we estimate with 95% confidence that between 81% and 87.4% of all adult residents of the city have cell phones. And yes, this was the question that this was the thing which we wanted to find out, and which was given us into the question. Let me take the highlighter. Fine, so it was given that what we need to do is that using a 95% confidence interval, compute a confidence interval estimate for the true proportion of adult residents of the city who have cell phones, right? Okay, let me just quickly give you an overview of the question that we had run right now. So I had taken a random variable that is x, and that was equal to the number of people in the sample who have cell phones, right? So after what I just find it out from there, that for finding out the CI, that is my confidence interval, which was asked in my question, I need to find out the values for P dash, for Q dash, and even for EBP, that is error bound proportion. So I was already having some values into my question. So I was given the value for n, that is 500. I was having the value for x, that is basically the number of successes, and that is 421. So from there, first of all, I just find it out the value for P dash, and that was 0.842. Firstly, this thing I just find it out using the formula that is x by n. So after this thing, I can just quickly find out the value for Q, as the formula for finding out the Q dash value was 1 minus P dash. So from that point, I just find it out 0.152. Okay. Now, after that, I can even find out the value for alpha. The value for alpha my came as 0.05. So from that, I find it out the alpha by 2, and that is 1.96. And simply, I applied the formula for finding out my EBP. That was that of alpha by 2 multiplication P under root P dash minus Q dash upon n. And after putting all the values and computing the values, I got this answer, that is 0.032. Then basically, I found it out the firm values, that is P dash minus EBP, were resulting me the answer as 0.81, and P dash plus EBP were resulting me the answer as 0.0874, right? These were the answers which I got. And at last, what I just mentioned, I mentioned the correct form and the full form for the confidence interval, and that was 0.81, 0.084, and sorry, 0.874. And simply at last, I wrote that we estimate with 95% confidence that between 81% and 87.4% of all adult residents of the city have cell phones, right? So I hope I made this thing and even this question very clear to you, that how you can solve out the question if you have got the question regarding the confidence interval for the population proportion, right? This was a question which belonged to this topic, that was finding out the confidence interval for a population proportion, and I mentioned the whole procedure which you can follow for finding out the answer, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So this is the second question for the topic which we have discussed previously, and that topic was actually finding out the confidence interval for population proportion, right? This was the topic that we had seen previously, and now this is the second question for that topic. So my question says to me that for a class project, a political science student at a large university wants to estimate the percent of students that are registered voters. He surveys 500 students and finds that 300 are registered voters. Compute a 90% confidence interval for the true percent of students that are registered voters and interpret the confidence interval. Right? So this is the question that we have here, and I hope now by the time you are able to understand that yes, this is a question for finding out the confidence interval for a population proportion. Right, that we had understood by now. And even you are able to understand that okay, if these are the values which are given, so what value actually belong to which thing, right? That let's say I would just start writing the solution here for this question, and before that I would just recommend you to just pause the video here and solve this question on your own, and then verify that the answer which you have done is correct or you had made some errors in that, right? Fine. So I have the value for x here, and that is given as 300. Okay, the value for x I am having here as 300, and basically the value for n I am having here as 500. So n is basically my total sample that I have, and x is basically the value for the successes, right? It is the value for the success, and n is basically my sample size that I have. So as we know that we have three things to find out for finding out the confidence interval, that are P dash, Q dash, and EBP, that is error bound for proportions, right? These are the three values, the three things that we need to find out. So let's begin now with finding out the P dash for the very first, and I would just write here that P dash is equal to. So The formula for finding out the p dash is x divided by n. Right? This is the formula that we had even seen in the previous videos. So that is the value for x I am having here as 300. And x is basically the value for the success. Right? And the value for n I have 500. So if you are going to divide this thing, so I'm just going to get the value as 0.600. This is some value that I am going to get after division of both of these. Right? So as soon as I have found out my p dash, right now I am I'm just able to find out my q dash very easily, because there is a very simple formula for finding out the q dash, and that is equal to 1 minus of p dash, right? So 1 minus of 0.60, right? So from the here I can just get the answer as 0.40. Even if I add the 0, so here also 0 is added, right? This is the value which I have just got here for q dash. Now the next thing and the last thing which you need to do for this thing, and we just need to go on with the process, is that we need to find out the value for EBP, that is my error bound proportion. So for that I need to do a little bit more things. So I would just write here, since my confidence level is 0.90. Now how could I just say this thing very accurately this here? So here I was mentioned in the question that compute a 95% confidence interval, right? So I had taken that thing only, nothing different, right? So if I am having the value for CL as 0.90, from this value I can just easily calculate for the value for alpha, right? So I would just put one comma here. Okay, just put one comma here, and I would just write alpha is equal to 1 minus of CL, right? So from here 1 minus of 0.90, and that will basically result me the answer as 0.10. So this is 0.10 is basically my value for alpha. And now even if I just want to find out alpha by 2, so that would be 0.10 divided by 2. So from here I would be getting the answer as 0.05, right? Fine. So these are the values which I would be getting here as an answer, right? Now what to do here? Next, what I need to do here is that I need to find out the z, here z alpha by 2, and that is basically equal to z of 0.05, and that is basically 1.645. Okay, now that I have found it. So from here what I can just add on, what the things I can just write here is that I can just write one thing from here, that area to the right of z of 0.05 is 0.0, sorry, just one second, is 0.05. Okay, this is the area to the right of this value. And if we want to find out the further left, and I would just write here, and area to the left of z of 0.05, it is basically 1 minus 0.05, and that will basically result me the answer as is 0.95. Okay, so for finding out the left side, what we just do, whatever the answer we had got for the right side, we just subtract that from the 1. So 1 minus 0.05, and that is basically resulting me as 0.95, right? Fine. This is done. Now next I need to find out the value for EBP, that is my error bound for proportions, right? I need to find out that thing. So I would just write on Z is here, and I would just write alpha by 2. Multiply, this is a multiplication sign. Firstly, I would be writing out the formula and just not put the values directly here. So that is P dash minus Q dash, and that is divided by N, right? This is the formula that we had actually seen. So if I just try to put on the values into this formula, so that will be, okay, let me just go down and here put it. Fine. So that is 1.645. This is the value which I just got for z of alpha by 2, right? What I would just do, I would just put my multiplication sign, put the under root here. Value for P and Q, just quickly go above and let's see the value for P, and P is 0.60 and Q is 0.40. Fine. So it is 0.60. Okay, multiplied by 0.40, that is my value, just like this. And just let me quickly take the eraser and remove one bracket because I have put one extra here. Oh, fine. Okay, let me just quickly write the things one more time. So just one second here. Okay, So 0.60, and that is multiplication with the 0.40 like this, right? And divide it by n. So the value for n I am having here as 500. We had seen even this thing above, that n is basically my whole sample size, and that I am having as 500. So after finding out this simple calculation, you are gonna get as 0.036. This is the value that you are actually gonna get here. Fine. Now, what I need to find is that I need to find out the form for the confidence interval that we had actually seen. That was P dash minus EBP and P dash plus EBP, right? So I would just write here P dash minus EBP for the first, and that will be equal to, so P dash value is 0.60. We had seen this right now. And the value for EBP is 0.036, right? That will basically result in the subtraction as 0.564. Okay, 0.564 is the subtraction for both of these values. Now, if I just do the same thing for P dash plus EBP as well. So, P dash plus EBP, my error bound for proportion, 0.60 plus 0.036. Only just replace that subtraction sign from the addition one. And here I'll be adding 0.636 like this, right? Now, if I want to write the CI for the true binomial, for the true binomial, just let me come down. Just 1 second. The CI for the true binomial, and I will just write that population in the short form POP like that. Okay, population proportion is, and I would just add on that form here, that is P dash minus EBP, comma, and that is P dash plus EBP. Okay, just let's go above and quickly check out the values that what we have for P dash plus EBP and P dash minus EBP. So 0.564 and 0.636. Fine. So I will just add on that values here. Let's say here. Right, put the bracket, 0.564, comma, 0.636. These are the values which I got here, right? So for the final statement, for the final estimation, what I can just add here is that I can add that we estimate, okay, we estimate with 90% confidence, 95% confidence. Let me come down a little bit more. We estimate with 90% confidence that the true percent of all students, DEN, and here dash TS, right? So we estimate with 90% confidence that the true percent of all students that are registered is basically between 56.4% and 63.6%. Now, by the time you have just understood that, how can I just say that 63.6% and 56.4%? So yes, I have even just taken it from that particular, from this form itself. Let me just now go above and highlight out the main thing. So the value for P dash which we had finded was 0.600. 0.600, and value for Q dash was 0.400. We had find it out. Value for alpha by 2 was 0.05. Value for alpha was 0.10. Then value for Z of alpha by 2 was 1.645. Then basically we had find it out the value for EBP, and that was 0.036, right? Then find it out the form, that is P dash minus EBP and P dash plus EBP. So minus EBP was 0.564, right? And the plus EBP was 0.636. These two values. And then finding out the confidence interval, we had estimated this final result, which was 0.564, 0.636. And at last we wrote out the final estimate that we estimate with 90% confidence that the true percent of all students that are registered voters is between 56.4% and 63.6%, right? So now I hope that you have a very fair and a very clear idea that basically how to solve out the questions, which are basically if you are getting the confidence questions for finding out the confidence interval for population proportion. Right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically now today we are going to see that how you can calculate the sample size n. Till then for now what we are seeing that basically how we can calculate p dash, how we can calculate q dash, and basically how to calculate the EBP, that is error bound for the proportions, all this confidence interval, all those things you were seeing till now. That what if we are not given the sample size only? So if it is not given the sample size, we will be not able to proceed in the question, because this is the very first step that we need to apply the sample size. And if we are not given that thing, then how to solve out that thing, how to solve the question, what formula to apply, what not to apply, and all that things, right? So now we are just gonna say that thing. So let me just quickly put on the heading here, and that is basically calculating the sample size n. Calculating the sample size n. Okay, this is the topic for today that we are gonna discuss right now. Fine. So basically we have several formulas for finding out the sample size, that is n. Okay, let me just quickly list that formulas, and after that we are gonna see one example also. So let me just write down here that error bound formula for a population proportion, proportion. In the short form, basically I have just written here that formula for EBP. I'm just writing that full form as well. That is PROPORTION. Fine. So error bound formula for finding out the population proportion is basically, we had the formula previously as well. So that is basically EBP is equal to Z of alpha by 2 multiplied, and I've just put one under root sign here, and that is P dash Q dash divided by N. Okay, this is the formula which we have here for finding out the EBP. Right, now from this formula only, I just want to transform this formula and I just want to make it available for finding out the n value as well. So we all know how we can just do that thing, right? So I would just mention that same thing here, that solving for n, basically solving for n gives you an equation, for the sample size, right? So I can just mention here that n is equal to Z of alpha by 2 whole square, right? This is actually whole square. Do not take it simple square, so it is whole square, right? Multiplication with the P dash multiplied by Q dash, and which is actually divided by EBP square. And now what I need to do is that, let me quickly erase this thing here and let me write that thing in the middle of this line, and that is like this, n is equal to. So yes, this is basically the formula which we apply for finding out the value for n, that is my sample size. Okay, so that is z divide, in the dividend it is basically alpha by 2, it is the square of the whole square. After that, multiplication with P dash Q dash and divided by EBP square. So for finding out the value for n, these are all the things which I need to have in my question, then only I would be able to find out the value for n, and that is my sample size. Right, so we were having a previous formula for calculating. Oh, hold on, just let me take out the highlighter. Fine. So basically we were having a formula for finding out the error bound for the proportion, right? And that is basically EBP is equal to Z of alpha by 2 and multiplication with the under root of P dash Q dash divided by N. Right, now if it is transformed that formula, so okay, just 1 second. Okay, after the transformation, basically what answer will I be getting? I would be getting that for finding out the value for n, you need to apply this formula, and that is Z of alpha by 2 whole square at multiplication with P dash Q dash, and that is basically divided by EBP square. right? This is the formula which you can apply for finding out the value for n. Now basically I'd be taking you towards one question as an example, and now that is a very nice example. Let me show you the question here itself, right? This is the question that we are going to deal with. So my question says to me that suppose a mobile phone company, okay, let's say my question says to me that suppose a mobile phone company wants to determine the current percentage of customers aged 50 plus that use text messaging on their cell phone. Okay, so it wants to determine the current percentage of the customers. Now, how many customers aged 50 plus should the company survey in order to be 90% confident that the estimated proportion is within 3% points of the true population proportion of customers aged 50 plus that use text messaging on their cell phone? So this is the question that I am given here, and from after reading this question, I am just able to understand, and I can say that in this question I simply need to find out the value for n, right? But now how to begin up with the procedure, how to apply that? So from this I can just say one thing which I'm just able to see for this question. I can just add on that thing, that from problem, okay, this I'm just saying it as problem. Okay, so from problem we know that we are actually given the value for the EBP. So that I'm just given as 0.03. How I just can say that? So it is basically my 3%. Just have a look here. That here it is, the company survey in order to be 90% confident that the estimated proportion is within 3 percentage points, right? 3 percentage points of the true population proportion, and that is my error bound for my proportion. Right, so from here I had just one thing to find out, that is EBP. So I had just find it out that thing. Now from this EBP I can just find one another thing. Okay, so I can just apply that Z of alpha by 2, and that is Z of 0.05. Now how I can just say that? Because I have the 90% confidence. So for that 90% confidence, this value actually remains the same, and that is basically 1.645 for my 90% confidence. Right, so from here I only have two things, that is my EBP and Z alpha by 2. So now two things are left to find out for finding out the n, that is my sample size, and for that I need to find out the Q dash and even the P dash, and even I have nothing of them to in my question. Fine, let me come down here. Now if you do not have any source of finding out the P dash and Q dash, then in that case basically what we do? So in that case I would just write that thing here itself, that I would just write that to find Q dash, we need the P dash. This thing we all know, right, that Q dash is equal to 1 minus P dash. So for finding Q dash we need P dash, but we even do not know about this P dash as well, right? Now I would just write it here that since we multiply, I would just add on some things here. Now please make sure to look this very carefully. So since we multiply P dash and Q dash, together, okay, if I just multiply both of them together, we make both equal to both equal to 0.05. Okay, if I just make both of them equal to 0.5, that is like this 0.5, because now why I am just making them equal to 0.5, because P dash multiply Q dash is equal to 0.5 multiply 0.5, and that will result me in 0.25, and this is the maximum largest possible product that we can have for the value of the value for P dash and Q dash. So why I'm just adding it? Because now this results the largest possible product. Right, so this is the why I am just taking this 0.5 and 0.5, because this actually results me the largest possible product. right? Now let's say if I just take 0.6 and 0.4, so that will result me as sorry, if I just like take some other values as well, so that will not result me the correct answer. Okay, if I just take 0.6 and 0.4, that will result me 0.24, right? And all those conditions you can just apply. So these are two maximum values which I can take, and that is resulting me the maximum P dash and Q dash value. So I'm just taking this as well. Now what is the like basically what is the motive behind taking these? So that also I'm just mentioning that I would just write that here, that largest possible product. Okay, the largest possible product gives largest n, largest n, that is my largest n value. And this largest n values, so basically what it gives, so it gives, let me just come down here. Okay, and this gives us basically large enough sample, and if we have the value for n, so that is my sample is even large, right? So and even a large sample, what it gives me, the large sample, this gives a large sample, so that we can be 90% confident, that we are within 3% points, of true population proportion, PROPORTION, right? So I hope by the time you have got the answer that why actually I have taken the values as 0.5 and 0.5. So there is a huge reason behind this taking these values, right? Now I would simply find out the n because I have all of the values with me. So that is z alpha by 2 whole square p dash q dash and divided by EBP square. So value for that I have 1.645 square. So let me write that. Multiplication with 0.5 and then 0.5 and then divided by 0.03 square, right? And from here basically the answer that I am gonna get is 751.7, and if I just round it off, okay, and I would just get as 752, right? So I hope I made this thing very clear to you that if you are getting some question for finding out the sample size, that is n, so how will you be doing that thing, right? So here I have just find out the sample size, and that is basically 752. I'm just trying to round it off the 751.7 value, and that is basically giving me 752, right? So this is basically how we find out the value, and this is the formula which we apply for finding out n, that is equal to z alpha by 2 whole square p dash multiplied by q dash and divided by EBP whole square, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So till now we had studied several topics under the confidence interval topic, right? We had seen about what is confidence interval, we had seen confidence, many things we had seen. We had seen student C distribution, we had seen n number of things in this topic, right? So there were a lot of formulas which we need to remember, and right now it like I just can understand it can be a little bit of messed up and all those things. So basically now today what we'll be doing is that we'll be doing a quick revision of all the important formulas that we had seen in this under the confidence interval topic, right? So there was very many formulas, so I just will take a one short video. In that basically we'll be discussing about all the formulas which we have in this confidence interval topic, right? So let's begin up with the things for here, and I will just take one color and let's start it. So right, so I'll be writing here, let's say the topic that I would be taking here is, let's say, okay, just one second. The topic that I would be taking here is, let's say, the summary of formulas. Okay, so today we are just going to take one revision of all the formulas which we had discussed till now in this confidence interval topic. Right, so let's begin now with the very first thing, and just let me quickly change out the color so that, right here. Right, so first formula is basically the general form of my confidence interval. That what was the general form? I would just write this thing here. General form of, and I will simply write here Ci for the confidence interval. Okay, I'm just not going to write whole of the things here. So general form of Ci, that is my confidence interval. So the general form for Ci is basically, firstly what we write. Firstly we write the lower value in the very starting, right? We write the lower value, and after that what we just write, we write the upper value. So lower value comma upper value, it is the form. And it is basically equal to, now what is this actually equal to? It is basically equal to point estimate. Okay, I would just add on this point estimate minus error bound. Okay, minus error bound. And second form, okay, just one second, BOUNT, and after that basically we even had that point estimate plus error bound, right? So that was point, I would just add on here estimate, okay, point estimate plus error bound. Right, so this was the general form of the confidence interval which we had seen till now, and even we had just done several questions onto this form, that to find out this form we need to find this and then this and all those things we had done, right? So this is the general form for finding out the confidence interval. Fine, moving towards the second, I would just take different colors for each and everything so that it does not actually get messed up with each other. Fine. So number two, basically now we have basically how to find out the error mean when we have the confidence interval, when you just know the confidence interval, how to find the error bound. Okay, so I would just write here to find the error bound when you know the confidence interval, right? This is one condition which can come, that how to find out the error bound when you know the confidence interval. So for that basically we have one formula, and that formula is actually error bound. So that is error bound is equal to upper value. Error bound is equal to upper value minus point estimate. So error bound is equal to upper value minus point, I would just write it as here estimate. Right, this is the first thing that comes. After this basically we have even one more thing which we have even discussed also in our video. So let me just tell you that thing as well here. So second one is basically, so I would just write here as error bound is equal to, and that is actually upper value. So here I have upper value minus lower value, and whole of the things are actually divided by 2, right? So this is another formula for finding out the error bound, right? I hope you just got the idea. Now let me just quickly take another different color, right? This one here, so we just write on there as 3. Fine, now what we have, I have even many more things in this. So we had discussed about the single population, right? We had discussed about the single population. Then we have single population mean, right? Then we had discussed about known standard deviation, right? We had seen about known standard deviation, and then we had even discussed about the normal distribution, right? So we had even discussed about the normal distribution. So after, if I just have all of these things, so basically how can I just find out the value for the EBM? Okay, so for that basically if I just have all of these values, so finding out the EBM is super easy. I would simply write EBM is equal to, that would be my Z score alpha by 2. Okay, just let me make alpha more clear. That would be like this, alpha by 2, right? And after that basically I have a multiplication sign, and then I have sigma upon under root of n, right? So if I have all of these things known, then basically these are the things which I can use here. And basically then the confidence interval format, then the confidence, so here I would be adding the confidence interval format is, and I will be adding that thing here, that it is x bar minus EBM, okay, comma, and it would be x bar plus EBM. Okay, so it's x bar minus EBM and x bar plus EBM. Even we had just seen this thing many times, but today we are just gonna do we are doing a revision, so I'm just revising all of the things. Right here, after that my next color comes this one, and I would be adding the number as 4 here. right? So number 4th, in which we had covered about the single population mean. Single pop, I will just simply write the population as pop, okay? So that is single population mean. And then we had seen about the unknown standard deviation, okay? Unknown, I would add here standard, and here we have deviation. So unknown standard deviation. After that, it was students, I would add students T distribution. It was after that students T distribution. Alright. And basically when we have the students T distribution, all of these things, and we have the degrees of freedom. So how we just find out? We just find out df is equal to n minus 1. Right. And what is the formula for finding out the EBM? So instead of that Z score, we just write here T score and T, and it is basically alpha by 2. And multiplication which is s upon under root of n, right? This was the formula which was applied when we were having this thing, right? Fine. Now come to the next one. So 4th is actually done here. Now moving towards the number 5th. So let me take some color here. Let's say this one, right? So now discussing about the 5th one. Now till now we had just discussed about the student seat distribution and all those things. Now comes the topic about single population. So I would just add that single population proportion. Okay, just one second. Let me write it like it is actually readable to you, right? So it's actually single population. So it's single population proportion, right? We had discussed this topic actually a little bit recently itself, right? Single population proportion, and we had seen the normal distribution. So basically with using of the normal distribution for a single proportion, what formula we had applied? So that was P dash is equal to x upon n, right? X was the number of trials for the success, and n was basically the sample size, right? This was the things that we have applied. And how do we just find the error bound for the population proportion? So EBP was having the formula as z of alpha by 2 multiplied under root of P dash multiplied by Q dash upon n, right? And what was the basically relation between P dash and Q dash? So P dash plus Q dash was equal to 1. This was the relation which we were having between the P dash and the Q dash, right? Now, basically what was the confidence interval format that we're having here? So I'll be adding the confidence interval. So the confidence interval format. So that I would be adding confidence interval format, and coming down I would be just writing here as P dash minus EBP. P dash minus EBP, comma P dash plus EBP, right? This was the confidence interval format that we were having for this, right? And after that we had even discussed about the point estimate. So let me just now take one another. Okay, let me do it from this side only. Let me just take one color, and basically now we'll be writing the point estimates, right? So I'll be adding the number 6 here, and that is basically point estimates, right? So I would be just writing that thing here. So it is basically point estimates are actually basically, so x bar is a point estimate. X bar is a point estimate for mu, right? X bar is a point estimate for mu. Let me come down. And yes, now basically P dash. So P dash is a point estimate. P dash is a point estimate for rho. Okay, and after that basically S is a point estimate. S is a point estimate for, and that is sigma, right? So these are the point estimates that I have for different things. So these were all of the formulas which we have actually seen in this confidence interval topic. Let me give you a quick revision once again. So the general form for confidence interval was lower value comma upper value, and that is equal to point estimate minus error bound comma point estimate plus error bound, right? After that, if we basically needed to find the error bound when you know the confidence interval, so in that case you are having two formulas. So the first formula was error bound is equal to upper value minus point estimate, and the second formula was error bound is equal to upper value minus lower value divided by 2, right? After then that, if we have known the terms for that was single population mean, known standard deviation, normal distribution. So according to that, if we just wanted to find out the error bound mean, so for that we simply used this formula, which is z alpha by 2. Z is my z square, alpha by 2 is my value which I'll be calculating, and that was multiplied by sigma upon under root of n. Right? So the format for the confidence interval was x bar minus EBM, comma x bar plus EBM. Right? After that, if I was having single population mean, unknown standard deviation, and student seed distribution, so in that basically I was having df is equal to n minus 1. As basically my degrees of freedom was n minus 1, and my value for the EBM was t alpha by 2 multiplied by s upon under root of n. After that, I was having single population proportion normal distribution. So my single population proportion value was p dash is equal to x by n, right? And after that, I was having error bound proportion. So that was z alpha by 2 multiplied by p dash into q dash, right? Divided by n. And basically the relationship between p dash and q dash was, so p dash plus q dash is equal to 1. And the format for the confidence interval was p dash minus EBP, comma p dash plus EBP, right? This was the format between this basically confidence interval. And after that, basically what I was having, after that I have point estimates, right? So point estimate, so x bar is a point estimate for mu, p dash is a point estimate for rho, and s is a point estimate for sigma. So these were the point estimates that we were having here, right? So basically these were all the formulas, all the things, a quick summary regarding the topic of confidence intervals. Now basically from the next video we'll be starting up with a new topic. So this is all for this video. Till then, thank you and take care.